2 minutes. 2 minutes and I'll get us started. Sound room, just like last time, I'll have LH1 and LH4 as well. One minute. 1 minute. We'll get started. I'll grab LH1 so I can walk around. Testing. 1, 2, 3. Testing. 1, 2, 3. Give it a 30-second countdown, folks, and I'll get us here. You all know when we start. You know how much I start yapping and yelling. 30 seconds. Crazy wild power outages, by the way, for those who live here, right? Crazy. I have some friends who are not going to get electricity until Saturday, apparently. Especially in the greater Seattle area, like Kenmore and Basso, Bellevue, some areas over there. Okay, I've made you wait long enough. Hello, Internet, watching in the live stream. And of course, hello, people who are here in person who have made it this far to Handmade Seattle Day 2. Welcome. Just staggering turnout yesterday, and we'll see what happens today. I have no idea, given the conditions, right? Like weather over here and like work over there and the economy. It's like, who knows if we'll have more people or less people. I don't care. The turnout has just been staggering. Thank you for making it despite what's been going on in the world and what's happening literally here in Seattle. But I hope this has been like a nice reprieve, like a nice safe haven for you to nerd out with fellow programmers who care, hopefully, about building better software for their users, who care about software quality one way or another. And if you're watching this for the first time today, Handmade Seattle is pretty much a conference by a programmer for programmers. It's indie. That means that we have no sponsors. There's no companies giving me money. There's like nothing to influence how the event itself is organized. And that means that speakers can say whatever they want. They can say whatever they want. And you kind of saw that yesterday, didn't you? So, you know, even in our own house, there can be critique and things like that. And I think that's fantastic, actually. That's really important. Because the way the software industry is declining, I don't know if you agree with me, but I think it's declining, it's going down a cliff. Has to do, I think, a lot because of the conferences. I'm gonna take my own shots. There are conferences out there who are sponsored up to their eyeballs with corporate sponsors, who then the speakers are now afraid to say something wrong that'll upset the organizer's sponsor. Or maybe, you know, a sponsor looks at a slide, a PowerPoint slide, and tells the organizer, I don't like this speaker slide, by the way. Like, that actually happens a lot, more than you think. I'm not saying every conference, but a lot, right? So you don't have to worry about that here in Handmade Seattle. You can enjoy the presentations, raw, unfiltered, honest opinions. And what's funny about Handmade, I don't know if you noticed yesterday, we do critiques, but at the same time, we're like friends. Like, we just have banter and we respect each other. But so the critiques can be harsh when it comes to the actual software, but when it comes to people, you know, we get along. And that's rare also. I'm grateful to this community. It's not really just, it's not me, it's you guys. And I appreciate that a lot. Okay, just to finish my Jimmy Wales Wikipedia speech as always, and we can introduce our first speaker. I also wanted to mention that for those who are, once again, watching online, we value your presence. We value, and for those who I know still couldn't make it today because of those delayed flights given the storm happening in Seattle, thank you, thank you, thank you. This means a lot. This is just literally a conference by a programmer for programmers. We care about software quality one way or another. This is a 10-year anniversary of Handmade, by the way. Like, the community's been going strong for 10 years. And yesterday, as you saw, we had a lot of speakers that were kind of like old school Handmade folks that we love and appreciate. And I thought for day 2, we should reach out to other communities too, who might share some of our values and who might have new insights to give us, the Handmade community. So of course, you know, yesterday we had a lot of low-level stuff. We're gonna still have a lot of low-level stuff today. But also we might venture into the esoteric, into the artistic, into the creative in ways that you wouldn't expect. And I hope that that inspires you as you're building your own handmade software, integrate those new ideas coming to life. So our opening speaker today has been with us before. This is Devine Lu Linvega. You can correct me later if I said that incorrectly. Devine Lu Linvega. From the Merveilleux Town. I hope in the chat server people can put up that link, Merveilleux Town, leading that community. And we hit it off ever since I met them. It's just fantastic. They have fantastic ideas. Their last talk was also in Handmade Seattle, Weathering the Software Winter, which is very appropriate given the state of the industry. So also I would love it if people in the chat can put up that link, Weathering the Software Winter, so you get to know more about Devine. But today's talk by Devine is just, I don't even want to like spoil it too much. I'm just going to let them kind of like introduce themselves and explain what's going on. So let's venture into the weird, the unknown, and the interesting today, and the creative and the artistic. Round of applause for Devine Lu Linvega. Remember the projector, right? Yeah. Back. Yep. Pointer if you need it. I've got a timer for you too.
Timer this time. All right. Can I just test this? Yes. Thanks for having me once again. In my presentation in 2022, I talked about resilient systems and how to preserve software from the past. This time, Abner asked me if I could talk about the potential futures and alternative ways to think about computation moving forward. But before I begin, I would like to thank Abner and all the Handmade teams for making this happen, because this whole conference is unbelievable. It's unlike anything else I've had a chance of talking to with. Rec for helping me make some of the slides. Wryl, who's gonna speak later, to gracefully take my hands and teach me about all the stuff I'm gonna be talking about today, for which I'm infinitely grateful. Shout out for the Merveilleux community who's been giving support, advice, and also even showing up. Yeah, cool. And as well as the concatenative language community for giving us a space where we could, give birth to these ideas. I would like to begin by saying I'm super grateful for this, but we have a chance here of creating I feel like this is one of the last bastion where we can be celebrating the artistry of programming, the people who make it happen, the craft, and the hands that make it happen. I would like to say fuck capitalism and fascism and all this reactionism shit in its automated forms. All the slides here are hand-drawn, and it respects, I find, the handmade ethos. Not only that, the slides, the programming language I used to make the slideshow, the programming language I used to make the programming language I've written, so it goes deep. Let's begin. So I had a dream, and in my dream I was in a library. But you know how in some dreams you might recognize someone and they don't look like this person, but just because of the environment of the dream you can tell that it is this person? Well, this is how I knew this was a library. Not that it mattered for most people living in the library, but in the backdrop of their lives were bookshelves. But most people didn't pick a single bookshelf in their lives. They spent their lives in these large octagonal rooms. In these rooms, there were 4 hallways, and each hallway connected to another octagon. Sorry, did I say octagon or hexagon earlier? Well, anyway, octagons. In each room, there were 4 hallways connecting to other rooms. And in between these rooms, there was like restrooms and all the facilities needed for life. And from the center of the room radiates a permanent light. From the ceiling of all these rooms hangs a fruit tree. In the silence of the library, people communicate with signs to each other. Every conceivable meaning is communicated quietly this way. And each sign corresponds to one of 32 words, or 16 numbers. For example, in my dream, people counted with their fingers. But the way they did it was a bit slightly different, so they would count, 0, 1, 2, 3, 4. So if we look at in German, in Inglourious Basterds, there's this pun where it's like you're 3 beers. Well, Americans would say 3 beers. Well, in the library they would say 3 beers. In each octagon there are 4 walls, and each wall holds 4 shelves. On the shelves, instead of Borges' 410 pages books, which are each 40 lines high and 80 characters wide, well, these books are perfectly square, and each line contains 16 letters, 16 lines made of 16 characters each. The pages are made of a material that feels like bark a little bit, and on it grows a moss that you can sort of like mark with a reed and erase like a carpet with your hand. Like you write something on a carpet because the fabrics would like lean on one way. The language uses one of these 2 glyphs, letters. You don't need to learn them, and I won't be teaching you them. I just wanted to show you, some of the attributes of the language. There are also 16 characters, and if you notice, they basically correspond to the 4 fingers. And I showed you before. If you say 3, it looks like this. The alphabet have the properties of some other alphabets that we're familiar with. Like on the left we have Aleph, Bet, Gimel, and on the right you have the language of the dream, and it's like one. Well, there's even names for them, but In, Po, So, Ro, whatever. But unlike the Latin alphabet, in which most of the organization of all the permutation of the Latin alphabet will not unlikely give you something that has meaning, well, in this alphabet, it does. In the Latin alphabet, you might write something, it has no meaning. I mean, this has absolutely hopefully, has no meaning to anyone, but every permutation of this alphabet does. So that has some quirks. Well, one of it is that if you change one thing, it throws the meaning of the whole book in a totally different direction. Where with the Latin alphabet, well, I mean, it doesn't really matter which way you can sort of like, it still can make up some sentences and words, even if the letters are shuffled. But this language has other quirks. One of it is that, for effect, a sentence might tell you to read the same sentence 5 times. This is the sentence that tells you, go back and read it again. In the library, in the dream of the library, people would call lazy people who would see a word like this, which means infinity, and not infinitely read it, but just move on. It would be like, okay, so this is the word for infinity, I can use it in a sentence. But not everyone has this peculiarity. Some people would just, get stuck reading the same, the same sentence over and over again, not knowing it would end. So in these infinite recursion and in these books telling stories that might not end, people who pick up books might spend their whole lives. And since you can't be sure if a sentence will end, some people are certain that it must hold some kind of meaning, so they keep on reading. They are fiendishly difficult or vicious sentences like this one, which is basically the implementation of the TAC function, if you've ever seen it, which is brutally recursive. Well, people will pick up these books and get stuck in these sentences that just recurs forever, or well, seemingly forever. You can imagine that this consumed a lot of readers' times. Here's a fragment of a book which can be read in both directions. I mean, it's hard to see or to understand if you don't know the letters, but if you can sort of have a glance at, the first few letters are the same one that ends at the other one. Well, I mean, people in the library would call these a palindromic book. So the question with the palindromic book is that, people wondered if maybe if we read each book from the first page to the last, or to the last to the first, might not we find, actually meaningful books doing this process? Well, people suggested that this would save time. Others realized that, well, they might have come upon the book, not just misreading it, like maybe someone from Japan would have picked it up from the last page and read it backward, but it made people question if maybe they hadn't missed out on an actually meaningful book. This sentence just so happens to print the words tenet in ASCII. That's just a quirk of the. Some people in the library believe that the astronomical number of permutations that we can find in these 65,536 letters books were too few. Others that we didn't have enough pages in the books and that the alphabets had too few many characters. Some people will be, get on with the times, we need more books, bigger libraries. And I was, in my dream even, I was sort of struggling with this, and I was like, no, we haven't even begun to explore the library. But even in my dream, I had the feeling that other libraries must exist, just by seeing the negative spaces in this. Some believed in the library that we use too many characters, and we might as well just reduce it to 2. Why bother writing what was before if you can just write this? You have 2 characters to learn. 16 times easier to learn as a language. But others, which had an interesting point, told me something that is interesting. We could do away with some characters, and it would lead us in different ways. In fact, in my dream, wandering the halls of the library for a long time, I found an ancient stairway that led me closer toward the sun. And as I made my way deeper toward the sun, I traced my fingers on the walls, and I noticed that the brickwork changed. And at one point, I realized that the library in which I was living was built on top of much older foundations. And at the end of this stairways and hallways, I found myself at a sort of something that looks like the shape of like in a tower where people would throw arrows from. And at the end of this dark little narrow corridor, I noticed someone was looking at me from the other side. And for some reason, this person evoked in me a sense of loss. But we started talking. And this person convinced me that by just using these 4 characters, we could recreate or at least retell every story of every libraries. And I was very dubious, I guess. I mean, I was incredulous to that at first. But I would like to explain to you how it worked. So from now on, the slides, I will stop using the conlang and all the weird glyphs. We're going to use numbers because otherwise it's not going to. So I'll use decimal numbers. Prime factoring means that you're basically breaking down a number by its indivisible parts. Some people call it the DNA of a number. When you multiply a number by a fraction, what you really are doing is decrementing the value of 1 prime by the denominator, which is the number underneath the fraction, and incrementing that prime number by the nominator? No, the one on top? Numerator. When you multiply a number by a fraction, the number underneath, the denominator, removes 1 prime, and the one on top adds one prime, which is an interesting effect. So, for example, in this case, if we multiply 18 by 2/3, basically what we're doing is removing a 3 and adding a 2. And if we multiply by 3/2, what we do is remove a 2 and add a 3. So we can think of a number as a sort of a bag, I guess. A bag that contains numerical values, primes. The books of this library, where you only could use a single operator, which is the multiply operator, you'd find pages covered with these fractions. And a book might read like this. So as an example, it begins with the bag, which is the number 28, which I showed you before. It holds the number 2 and twice the number 3. Now we have a series of fractions, and we'll consider this as our story, multiplying 18 by these fractions in a sequence, starting by the first one. If the modulo of 18 over 2, the denominator, or over 3, if it yields 0, that means that it's a way for us to test if the bag contains a specific item. So, for example, if we start here with 18, we would do like 18 multiplied by 5/2. 18 does contain a 2 as one of its prime integer, so we take it off and we put a 5. Then we try again. It doesn't have another one, so we move on to the next one. We remove twice the number 3, and we end up with 5 times 5 times 5, which is kind of interesting because basically what this little sentence does, made up of 2 fractions, is adding 2 items in the bag and putting us the result 3 of adding 1 plus 2 in the 5th register. From this, we can devise a sort of like a computation model that is implementable like this in pseudocode. So that's kind of interesting because most languages, or like single instruction computers that I'm familiar with, or sublec and all these, are much wider systems, even if they claim in their simplicity that they are not. But I mean, even this is too complicated. Like there's a fundamental, primordial way of looking at this that is even more accessible to people, and I think that might have been overlooked. And I would like to show you how that works. So basically, a fraction, it's a bunch of numbers, and the brain doesn't parse this very well. There's a better way of looking at this. So this is the fraction 3/2. Basically what we're doing, we're replacing whatever you have in your prime number 2 and putting that same amount of things in your prime number register 3. So basically you're moving one thing from a bag and putting in a different one. Let's say you have this word that would say, like, take out an apple and put down 2 oranges in your bag. Well, you can represent that transformation by a single fraction, and multiplying any number by it will apply this to its prime. And if you name the primes apples, oranges, shapes, triangles, whatever, you're getting exactly this. So the program that we had before, you're multiplying 18 by 5/2 or whatever it is, which is opaque as hell, can be explained by these 2 simple sentences that basically like rewrite rule of an apple for a sum, an orange for a sum, basically evaluating the page of this book. What you get is the result in sum, which is 3. I'm using words, but we might as well just use shapes or sounds or taste or whatever. And but this goes through the whole computation stack. I mean, I've just shown you how to add stuff, but I mean, I might as well just show you how to make logic gates and other things. But for example, this is how you would have. This could be represented in fractions and stuff, but I mean, as we're human beings, this is much easier. This is a logic gate, and if you have an item X and an item Y in your bag, and the item AND, because we're going to use, you replace these 3, you take off these 3 things, and you put a true in it. And this is basically what computation is. It's a state of transformation of state, and here we were just representing it as fractions or rules or changes. This is how you would get the difference between two things. So if you have 3 apples, 2 oranges, well, you remove one of each time, and what you're going to end up is a difference. You can do Fibonacci number. One of the interesting quirks of this system is that it's reversible. I think even in my dream I had a shiver when I was told this. There are sets of rules or pages in a book that have programs that are reversible. That means that by starting by the end state, you can, because of the primitive of the system, which is a fraction can be undone by swapping the denominator and numerator, and you would undo this fraction. Well, because of that quirk, you can read the book backward and find out where you started from, which is an interesting thing. This only holds if the right side or the left side of the fraction is unique, but still kind of interesting. So where does that leave us? Well, in my dream mind, I guess I was reeling. I mean, this is crazy. Like have I just was told that like a primordial way of doing computation in my dream? Like, what does that mean? Like, this can be explained in 10 seconds. It can be done. It can be played with if you have bricks or marbles or lint or whatever. And I even made a zine. I gave some away yesterday, and it's like 6 pages long, and it basically covers this whole talk. I mean, I'm just like stretching for time right now, but because the idea I want to communicate is so simple. I mean, I'm using that platform to communicate this and made pretty slides, but really in 10 seconds, we tried it, and you can basically teach anyone to, like, it's tally marks, Roman numerals, all these kind of things people are familiar with, but actually you can do computation with that. But yeah, like I was so excited in my dream. I want to see the other libraries. Is there libraries where there are no books? And the person at the end of this hallway that looked like at the hole where people would throw arrows from, well, yeah, there are other libraries that have no books. People in them burn the books, and I just couldn't believe it. People would actually do this. Like, what's wrong? Like, what's wrong with them? It's inconceivable, and I mean, it's painful enough to think that some people don't even pick up a book from the shelf. What's wrong with them? If it was up to me, I would just force everyone to be reading books all the time. Well, the person stops me. Well, why do you think, the first person ever pick up a book from the shelf? I don't know, like fiction. They were bored, fiction. They want to learn some history or understand the universe. Well, it was so they could better kill someone at a distance. Then I wake up, and dreams are weird. And I noticed I fell asleep in front of my terminal, waiting for the ARM architecture manual to open. and it's still loading. Thank you.
All right. Would you mind joining me here for a little fireside chat? I think, one more round of applause for this. This was just... Fire away your questions on the chat server, everybody. For those, some of you are new today, coming in today, thank you for making it. We try to do everything on the chat server, and if you can, Q:, that helps me a lot when it comes to parsing the questions. If I ever feel that in the chat, like questions have died down, then we can go here in person and like find people. But I'm trying to give benefit, especially in the weather conditions, those who are watching the live stream who couldn't make it, trying to give them the same access to the speaker. So yes, thank you again. Let's take a look at what's going on. I'm excited. So my first question though, are you still living on a sailboat?
Yes.
Nice. For those who didn't know, they've been sailboating since 2016, I think?
Yeah, it's been 9 years now.
Developing esoteric software experiments and doing all kinds of...
What else are you going to do on a boat?
I remember this one story where you were trying to, in your last talk at Handmade Seattle, trying to download Xcode.
Yeah.
How did that happen again?
Well, we were in French Polynesia. We had to raise the phone up the mast. And
Raise a phone up the mast.
yeah, and we had these 5 gigabyte data cards, and the update was 11 gigabytes. So the trick is to bring the phone down, change the SIM card, and then keep going without the laptop noticing. Because if it fails, it starts over.
Wow. And it's like 11 gigabytes at the time, I think.
Well, now it's probably 100. But
That's what, now it's probably a lot more for Xcode. Somebody confirm how big Xcode is these days. That's insane that you try to make it work even at those kind of speeds. All right, so we got our first question. I don't know if you actually did get to explain it. What does the : operator mean?
I just wanted a way of saying like this is the beginning of a rule or the end of the one that came before, just so we had a sort of like a visual indication that this is not. It doesn't mean greater than. It just means it's an arrow, starts on the left and goes this way.
Yeah. What does the library smell like?
Pears.
Interesting. This is amazing, by the way. Next question from Red Line. Sorry.
No, wait. Before
if you want to continue, please. Yes.
I recommend everyone to go read Mark Twain's Number 44. Pears.
Okay. Please, people, keep linking on the chat because I want to check this stuff myself. So next question from Red Line. Thank you. Sometimes I don't say people's names. I apologize. You have far more interesting dreams than I ever have. Where can I read more about them?
All right, so if you make very, very spicy ramen before going to bed, you will have very wild dreams, I promise.
What about people like me? It's funny because I was saying yesterday I'm from Puerto Rico and I've always been the shame of my family for not tolerating spicy food. I cannot. And what would you say to me?
You will have very wild dreams.
I should still try anyway.
Oh, well, yeah. I mean, like, you build a tolerance for this. I'm pretty sure. I mean, my dreams go downhill the more spicy I eat. But then, if you don't have any tolerance, you're gonna like trip balls.
There are better ways to go on trips. I hope. No, okay. Next question from the professor. Hey, the rooms were hexagons or octagons?
I can't remember. It's blurry.
Next question from Charles. Thank you for your question. Quantum circuits also follow a reversible model of computation. Is this an intentional link? Like, does the library have Hadamard gates? Did I say that correctly?
I mean, it's just trivially gates but I mean, yes, this person is reading into the talk and translating. Okay, so like 2 years ago, I gave a talk that was sort of like minutely technical in a way. This time around, I wanted to use a story, a sort of fiction to communicate, but it's the same ideas. I mean, obviously, the books here are computing programs, paradigms, that kind of things. Alan Kay was saying at one point, I think, that as computers will evolve, they will resemble nature. They will start to resemble the natural world more and more. I think he was making that, or maybe Joe Armstrong said this, but like the point was that at one point they would be, as parallel as the universe. I mean, right now, the way we live, this room around us, is not waiting for one event to happen till the next one can happen, right? Everything's happening all the time at the same time.
Right.
Well, I mean, you could read Shannon and how like the universe is not destroying entropy, like the events that are happening now are not burning the state that made them happen in the past. Like, it's just change, right? We're moving things around, but our computer programs right now don't correspond to this image that we have of the natural world. That means there's a disconnect between the way we program and the ultimate end of the things that we're building, right? But if we want to, bring this closer together, well, we'll have to develop new paradigms of computation, like rewriting systems like this, or the interaction nets, or super parallel way of doing computation, but also that don't destroy state, are fascinating and worth looking into. Right now, obviously, it's fringe. The quantum computation people are the people sort of like exploring this. I mean, I'm not a high-tech person, but I can't think of another way where things can go. Like, quantum computation is probably going to be what's going to happen because even though it seems more high tech, somehow it's just more closer to how the universe works.
And I'm glad you brought that up, because the next question is from Anne, who was asking, what, if anything, does this have to do with programming?
Well, everything and nothing. I mean, do I spoil? Well, okay, so we're all making video games and text editors and stuff like that on military tech. And we're going into everyone, it's like putting a computer in their face and like, learn this, it's gonna be good for you. I don't believe that everyone should be forced to use computers, and I don't believe that computers are necessarily net good. I mean, I think their use should be limited to giving silly talks and making pictures, music, like harmless things. I think the talk is sort of like my story with living with these these conflicting ideas.
Yes. From Miguel, is this a recursive dream?
Kinda. I will not lie that has been like my life. These thoughts is not like it's not being born in a single dream. It's like yesterday someone was saying, you spend 4 hours every single day of your life in this library. Well, at one point you might as well learn the culture and like pick up, try to see how the pages are made and like what does it mean, so like the talks, all of this, like even the program that runs the talk is written in this conlang. It runs. It takes less than 64 kilobytes of memory, so it is a book that exists in that library. So the dream is basically, no, it's like that's my life.
I wonder how much one of my own stories relates to this or not. You can tell me, but I have had dreams that have helped me solve programming problems, for example. So I do value dreams in that way, because it's happened more than once, where it's like, oh, okay. Sometimes gnarly low-level problems, by the way, just like a dream kind of like brought it to my, right? And often, although I wish it would happen more often, there are ways to make this happen more often. Actually, there are techniques to do this. Like I have been lucid in these dreams. So I'm kind of curious how has that happened to you in the library, where you're lucid, or do you have to recall later and remember, and then you forget and their memory loss?
I mean, I'm using this as a metaphor, but it's more like a daydream. Like
like
sometimes you're programming and you're like you seeing yourself from outside. Well, this is sort of like where I find myself when that happens.
I love daydreams too. Okay, from Bjorn, thank you for your question. Would you say this dream has impacted your life? Is there like a before the dream and an after the dream? And if so, how has it changed things for you?
Okay, well, one day you're lifting up a phone up a mast to get X code, and then you realize that all computation is garbage. And then the next day you're writing a computing stack, and then 4 years later you're at Handmade talking about it. And I think like it changed everything to like build that library and start to living in it.
Wild. Next question from Felix. Thank you for your question. Can you explain how the rules work and why they are reversible?
Well, yeah. Okay, so a rule is made of a left side and a right side. If the primitive that you're operating with is fractions, well, fractions are a reversible thing that doesn't waste entropy. So I mean, like I didn't mention this person by name, but basically in my dream I'm speaking with John Conway across the hallway. John Conway made a very silly paper called Fractran, and in this paper, in John Conway's style, it's like become a 10x programmer. That was in '78 or '80s or something, and he was like,
yep.
like give up on Fortran and learn Fractran. And Fractran can be explained in 10 seconds, and the only thing you get is multiplication of fractions. And when I saw this, I thought it was like a really interesting thing, but I couldn't really see through the opaqueness of it. But then zoom in a few years later, and then I get in contact with the person who's going to speak it next. And now there's a different way of looking at this, where you have rewrite rules that explains a transformation from a left side to a right side. Well, okay, you're walking up these lists of rules from the top to the bottom, and you're doing these transformations. And at the back end is the fractions. That means the fractions, by flipping the two numbers, you're getting the results back.
Wow.
So during compilation, you can make sure that no fraction has the same denominator or the same numerator as another, and then you have reversibility because there will be only one thing that will allow you to go from one state to the next.
Well, where do you see this question comes from Gregory. Where do you see the rewriting leading to, like, as an experiment? Like, what's next?
Okay, so this is speculation.
Sure.
People will not notice that the backend changed underneath them. So you're writing Python one day, and suddenly Python is 10 times faster. And people will wonder, like, oh, what happened? Was it a hardware change? Well, partly. It's probably going to be partly a hardware change. But the paradigm that we use to do computation, where we use these big RAM machines, where a lot of events have to wait for the other. Even people who do Haskell and have a entry into computation from binary lambda calculus, or sorry, just lambda calculus, they'll notice that a subset of lambda calculus is much faster and parallelizes really, really well. And I mean, who knows? Maybe it will be called HVM. Maybe it will be interaction that's driving this whole thing. But to most people, they will feel something has changed. But then what that will lead to is that at one point, people will start to be interested in becoming native in the architecture that drives whichever version of Python people use in 100 years. But rewrite rules will become something that people are more accustomed with because it's more fundamental, I think. But
that was Devine's official speculation.
I'm gonna get like trash for this.
I'm already looking at that.
I know. I just
next question from Lynn. Thank you for your question. Is this an analogy about bit hammer? I don't know what bit hammer is actually personally. If you can.
I don't play Fortnite or Minecraft or.
Yeah. Are we both becoming older? Is this what's going on?
I have that feeling. I sit up the front now so I can see the slides.
I just shocked myself. I guess I am older. Jesus.
Yeah.
Okay. Sorry guys. Next question from Mark. Thank you for your question. Any ideas of why they burned the books?
Okay, so let's say things can go different ways, where people realize that they don't want computers, that the best way to live is away from computers. Like, I mean, we're still living in the fallout of the ENIAC, which was used to calculate ballistics. I mean, maybe we'll realize that we just can't escape this sort of like militaristic aspect of computer, and it would always be used to control others. Like, it's either everyone understands the tools that they use so they can use it for actual emancipation, or there's always someone going to make sure that someone else doesn't know how it works so they can oppress them. I don't know enough about social sciences to know the answer for that, but I mean, I can see a version of this where people are just like, fuck all this, I'm gonna go live in a nest made of grass, and I don't want to touch computers, see calculators, I don't want to see QR codes, like all this, I don't want. And I mean, maybe this is the human race way of saying like, we'll transcend this because we don't need. I mean, we've moved beyond this stuff.
For my conference, I apologize to you and your community for having to scan QR codes, making you scan,
I just slipped through.
No, I saw you come in and I told the staff, don't scan there. I'm being for real. Next question from Lynn again. Yeah, it's a good question. Can you torrent Xcode? I guess this is about the boat, right? Like, you mean like P2P?
Wait, can you torrent and then what?
Oh, Xcode.
Okay. Yes, you can. You can download an old version of Xcode that will not let you push builds to Apple.
Oh, interesting. Okay. Oh my God. I hope Twitch does not ban our conference.
I haven't used Apple in 10 years now, so fuck that.
Next question from Victor. Thank you for your question. Oh, it's a statement. I absolutely love how this conference offers a stage for esoteric talks like this. Yes, absolutely. Gotta give space. I offer you a buffet of viewpoint.
Ask this person again in one talk. See if haven't had their fill of like weird shit.
We're like, yeah, we're going on a trip. We'll land back on our feet after lunch, okay? All right, Voran, thank you for your question. What can you do to remember or write down your dreams before it all drops out of your head? I guess that's technically what I asked earlier too, but it sounds like it was mostly a daydream though. But
Well, yeah, if it keeps happening, you just don't have to write it down. You just
I guess it is recurring over and over. Yes, and it's recursive too, apparently. Ruben, thank you for your question. Do you see a future for a computational machine that deals in fractions and not integers and floating point?
no. And no questions. No, but I mean, John Conway's insight was brilliant. Obviously, this is not what it's going to look like. I mean, that's like I use this as an invitation to look at other paradigms. When I was considering the talk, I was like, well, I need something that is not the weird conlang things that I'm using every day. I want something that is like other, but not. I'm not going to use brainfuck or sublec or other thing. I was like, there has to be something that will feel novel. And has something that can survive a long time. I wanted something that I could see as a potential future for computation. I don't think that we'll be multiplying fractions. I could be wrong. I mean, but it will basically be the same thing. It will be some version of a very primordial concept, something that we will be able to explain to a kid in 10 seconds.
Scott, thank you for your question. What does the programming languages that you used to make the slides look like?
It looks exactly like the slides.
Really?
Yeah. I mean, this is just English. But the little glyphs, the 256 little glyphs.
Yep.
They correspond to opcodes in a virtual machine I've been using for a while. And I mean, when I'm programming, it looks like assembly, right? So they have these names like swap, and it's like a stack machine, so it all looks like fourth opcodes basically. But it's called UXN, so I'm sure you can look it up. You're gonna be like, nope.
That was the next question actually. It's UXN. Travis was asking about the language. Yeah. Ben, hey Ben. How does this relate to other rewrite-based programming systems like Modal?
All right, so to give you an idea of the extensive scope of people interested in rewriting, well, in this room, you have like 90% of people who give to them. So there's a language that is not made by either this person or me. It's called Mode, M-A-U-D-E. And this doesn't relate with Mode whatsoever. But Mode is a good entry point into programming with rewriting rules. What I'm using here is multisets. Multisets is unordered. It's rewriting, but 10 times harder. But there are games that can help you break into that kind of thing, like Puzzle Script. Puzzle Script is a game, or Baba Is You. Baba Is You doesn't let you program with rewrite rules, but it lets you live in a sort of library where everything is governed by rewrite rules. But Puzzle Script is the scripting language that you use to create your game is exactly rewrite rules.
I played Baba Is You, by the way. How many people have played Baba Is You here? Just whoa.
Everyone.
Whoa.
Yeah.
Solid. Dante, thank you for your question. Are people born in the library? Can you enter or leave?
Yeah, I wanted to leave that out because I have no idea. I can make a whole talk about how
we really could.
How do you have enough protein? Eating pears 3 times a day?
Seth, thank you for your question. I'm having such a great time. Your dream seems to be an alternate reality library of Babel. Have you seen that?
Well, yeah, I mean, right at the start, I contrasted the books in that library by, they are not Borges' library. The books are not 410 pages long, they are 256 pages long. But yes, the Universal Library by Borges, Library of Babel, is excellent. I mean, this is sort of like a play on, riffing on Conway and Borges, and I think the idea came to me for the first time when someone was like, 64 kilobytes of RAM, that's too little. Mm-hmm. And I was like, can you imagine the number of permutation that is? We haven't begun exploring what can be done on the Famicom, and now we have a PlayStation 6 or whatever. We've missed out on low-hanging fruits there by just keep moving and expanding the scope of things. But So like, I mean, the original vision was like, oh, like I'm whining about people leaving the library for like going for like a 128 kilobytes of memory, like bigger books.
And I remember yesterday's demo, you guys remember the Mies engine, right? Like that's a great example of what they're talking about here. Next question from Res Mason. This one's a blunt question, I like it, but it's up to you to answer or not.
It's okay, I can go see Res later and just like...
Hey bud, you're a contractor still, yeah? I always wondered, how does the rest of your life interface with your business? For example, do you protect your dreams from your work? Or do your dreams inform your work, or what?
Okay, I do not believe in the division of labor. My life and my work is one and the same.
I'm like that too, actually, yeah.
Like, I cannot just program. It has to have music and drawings in it, and it has to have pictures and UIs, and I have no interest in CLI tools, and I'm not really a fan of the terminal. I think... I know. Well, I mean, okay, so if your terminal has 6 cells, I mean, you're like 10% there. But I like this interconnectedness. I mean, like it's having a discourse between the two halves of your brain. Like it's like like I have a story and I have something to tell. You can't do without one. And everything across all the disciplines that I'm interested in, I try to bring a bit of both. Like, these slides would be so boring if I was like, all right, so we're going to fragment this drive here, and then we're going to break it down, and this is going to jump. And no, like it's, I mean, John Conway was the master at making things playful. He had a playful mind. Everything was geometrical. Everything was play. Nothing was a weapon.
Exova asks, do any books point to other books?
Oh, shit. I didn't think about that. That's genius.
Brilliant.
Well, I mean, FFI.
Oh, no.
I don't know. I like...
foreign function interface for those. No, please. Next question from Daniel Hooper. Thank you for your question. Were there brave souls in the library whose job was to read new books for the first time, not knowing if they would get stuck reading them forever?
I mean, maybe someone picked up a book that said, like, I don't know, fractal, and they're like, oh, well, I can't wait to see how this ends.
CLI asks, how do the people in the library learn this language if the books are all being burned?
No. The books in that library are not burned. The book in the other library are burnt. And I don't know. I haven't been there. I'm going to have to eat some ramen.
Rui Calderon, could there be a book in the library that tells you to find and start reading another book? Oh, interesting.
Well, I mean, you two should talk.
I was going to say, there's got to be a link up here. Okay, Bitwitch, can you point to any resources that would help wrap my hand around the concepts in the talk? I feel like I'm missing some context.
So, unfortunately, if you look up rewriting, my website will turn up first. But I mean, it's not a sign of pride. I think it's a very shameful thing of, like, a defect of the programming scene. But I mean, I don't know. There's a
I mean, I'm seeing a lot of links being posted here on this chat. I hope that's helpful.
Yeah, I think someone's probably gonna like suggest that there's like discords. There's like really weird discords with really weird people talking about this. Come and join us. And
come and join us.
And well, so Fractran is either a really good way of breaking into it, or like the worst imaginable way of breaking into it. One thing I noticed is that programmers have like, if you come into this with preconception of like what a program is, it's going to be super confusing and you're not going to get it. You sort of have to turn off your brain because, you know, like, this is so simple. It's not simple, it's simplistic. There's very few moving parts. So, like, find an angle that feels familiar. I mean, fractions and multiplication, that sort of stuff, might not feel familiar enough. There's other ways. There's other languages, like Mode, the language, is a really nice way of doing that. Puzzle script, playing Baba is You for like 200 hours, also another way to rewrite your brain to be more receptive of that sort of stuff. But right now, it's unfortunate, but there's very little resources. I found like a mailing list from a French university, and they talk about rewriting, but it's so boring. Like, I tried to go through the archives, and I just, ugh.
Can a rewrite rewrite rules?
Yes.
Lovely. That's so cool. Awesome. Mary, thank you for your question. What keeps you going post-Dream?
What else are you gonna do? Like, I mean, this seems to me like an art project. Like, and I want to see where it goes.
Okay, Pradi, thank you for your question. Who was the figure looking at you at the end of the tunnel?
John Conway.
John Conway. I was gonna guess it. QG Carver, thank you for your question. How do you feel about the application of interaction nets for user/programming? For user interface / programming instead of just a functional language, a compile target. Yeah.
UI and rewriting is perfect for each other. Like it's great. Like I mean, I don't have enough. Like I could make a whole talk about UI implemented in rewrite rules, but like I had my brain melting every single day for that when I was doing UI with it, and it started by like we were like, let's make tic-tac-toe in rewrite rules, but then you implement the rules of tic-tac-toe, and you're like, let's make the UI. No, the UI already knows what it can do and cannot do. So there's no like MVC is sort of like irrelevant. You don't have the front end. Then the thing, it's like the front end is the capability of your program is the front end, and that for me that was like whoa. So we made like character controllers so we could move a character on the screen. And so how do you do that? Like it took us a little bit to figure it out, but then like oh well, if I put 5 left arrows in my bag, and then my character register is right after, that means that the more left arrows I put in my bag, the more it pushes my character on the right of the screen. Okay, let's say I have arrows to move my characters left and right, up and down. Well, what is the rewrite rule that should fire when I press left? Oh, it takes a right arrow out of the bag and my characters move left. Oh, okay. Well, I mean, you never have to write UI code. It's just baked in the design. Interesting quirk. I don't know what to think about that.
Kind of tangential, but related. So Miguel asks, does your keyboard have custom characters to make your language easier to type?
I wish. Then no.
You wish.
I mean, I would like to have an answer like this at one point and be like, yeah. No, but it's too many characters.
I think we got a couple of more questions. Time for a couple of more questions. So where did you learn to think in this way, referring to like the life, work, play stuff?
I think just hanging out with very interesting people who looked at things a different way. Like in my career of programming, like I find the algorave people had a massive impact on the way I looked at liveness and interactive systems, and just even programming languages that were like live first. Like there are some languages that are obviously like you're gonna go through a compile step, but there's some languages that are just like they're wanting to be interpreted, and like what is the difference here? And like exploring this, like seeing programming languages as UX led me to hang out with programming language designers, and they're just like the most interesting weird people in the world and every time I had an opportunity I would like ask all my silly questions, and once in a while someone would like take my hand and be like, all right, I'll show you how to build this. There are countless people who did that in my life. There's all the people that inspired me and helped me to make UXN, and even in this adventure, like there's like so many people who like took the time to show me how it works and also to play with the things, because yeah, this is kind of fun, right? But then you're like, all right, everything you want to do, you're the first one to do it. Like finding an implementation of Fibonacci number counting in Fractran, like no, it's not on Stack Overflow.
Some of those programming languages I'm just talking about, some of them are right here for sure. Like you might get accosted during lunch hour.
Accosted? How
Yeah.
Victorian.
Let's finish up with this question. This is the last question for you today, sir. What would you like people to take away from this talk?
Well, one takeaway I didn't want people to take from my first talk was that they should go and learn UXN. And this talk, I don't want you to go and learn Fractran. Like I picked a random language that I could use to demonstrate that, yeah, you might live in the perfect, awesome library, but then it's built on top of other libraries, and there are other ways to look at things. Like in a group of programmers, like 90% of them will be doing Python or JavaScript or some other thing like this, and then it's people who 4 hours a day think in a very similar way. But I think to really get things moving along and solving some of the software crisis problem that we're having, we really need people who think outside of the box. So, and you find that in the ESOLang communities.
Devine Lu Linvega, everybody. Big round of applause.
You can leave it right there.
Loved it. Fantastic. We've got one more talk before we go to our nice and long 90-minute lunch break that I hear is really popular. Really cool, really cool. Okay. Yes, so they were referenced a couple of times in this talk, who our next speaker is going to be. Let me just say a few words about that. They are a first-time speaker, so let's be forgiving and understanding for first-time speakers, but I'm excited anyway. This is going to be very interesting. So Devine did introduce me to Uriel. This is going to be our speaker. And you've had an interesting life because you've been kind of like on the ground, local, independent, helping smaller businesses and things like that. But you've also worked for like corporate, I believe. You worked for Amazon, for example. So you've been on both sides of the equation here. Like myself, I've never been in corporate. I started straight from Puerto Rico to NASA, and from NASA to Jonathan Blow, and from Jonathan Blow to the creators of Myst. I don't know, you guys probably know that game, that studio. So those are studios, it's not corporation. I have no idea what it's like, right? And you've also worked with, guilds and small business. Like I believe your mom works at the Small Business Administration and like all of these things. So like you have a lot of knowledge about that. With the nonprofit that we announced yesterday, the Handmade nonprofit that Ben announced yesterday, like you gave us a lot of expertise on like how that process works, and amazing. So it's cool. And we were talking about the software crisis, which is an interesting situation that we're right in the thicket of, the software crisis, right? And you have some interesting thoughts about that. You're calling your talk Democratizing Software. I believe there's going to be some programming discussion, but also just bigger picture things like we've seen with Devine today. So I hope you can put a round of applause for Uriel, our first-time speaker here at the Handmade Conference. Here is this is the one you want all the time.
Gotcha.
We can go back with red.
Gotcha.
And you also have a pointer.
Oh, wonderful. Oh, look at that.
Yeah.
That's amazing.
A little timer too.
Oh, look at that. That's amazing. Check, check, check. Hello, am I audible? Cool. Good morning, everybody. My name is Wryl, W-R-Y-L, and today I'm going to talk to you about something very near and dear to my heart. The title of this talk is Democratizing Software. And this talk is the culmination of research, observations, and principles that I've cultivated through my journey with programming. It'll have ups, it'll have downs, it'll have some new concepts, it'll have some old concepts. My primary goal is this: show how we can democratize software. I want to enable people of all backgrounds, anywhere you are, to participate in the beauty of computation. But first, we have to talk about some difficult things. We have to talk about how difficult it is to participate in the craft of software and how it's akin to scaling mountains of concepts and abstractions. We, as mountaineers, take for granted how easily we can traverse the terrain. We tolerate so much because it's the only way that we can get from point A to point B. And personally, I'm very, very tired of hiking around. Imagine how newcomers feel. This is a common parable. Newcomers and curious folk come to us and ask, Where should I start? And we'll respond with something like Python or JavaScript or defer and say, whatever you can get your hands on. Wherever your feet touch the ground. If you're in a university somewhere or going through a boot camp or finding some entryway, you start there. Instead of pointing them to some well-trodden paths, we ask them to survey the mountain range, to blaze their own trails, navigate the terrain on your own. A lot of people get lost, and sometimes they don't come back, which is disheartening. And the reason why they get lost is because of the effort required to scale these mountains. The terrain here is hazardous and often makes no navigational sense. Stacking concepts and abstractions on top of one another means that each layer is a new concept to be understood and internalized. We also don't have the limitations that real mountains do. We can build arbitrarily nested structures, things that contain themselves, layers and layers of indirection. I don't think we really know how many people we've lost to this, and it kind of scares me, keeps me up at night. We're setting ourselves up to look like aliens. As curious individuals can't really understand what we do at a glance, if at all. They need a guide to help them up and down the mountain. And sometimes they find a steward to do it. They find someone who is willing to take them on the voyage up and down those slopes. This is bleeding into how we're writing software, as eventually we'll end up writing things that we can't comprehend fully, only partially. Eventually you're going to run out of energy to climb. Blind spots can and will develop. The trail will disappear and be overrun with brush. When you run out of energy to climb, nature and gravity take over in the worst ways, and there's very little ways to stop that. And this compounds in so many different unpredictable ways. Our lives are filled with certain flavors of chaos. We may not be able to comprehend what other people practicing our common craft are doing. Context switching, emergencies, and the general flow of life drain what little energy we might have for crafting software. And it's very, very difficult to recover that energy and gear up for another climb. Look at how burnout develops and how long it takes to learn how to walk again, let alone climb the mountains that we are required to climb. We can't keep pace. Even as experienced mountaineers, I fear we're kind of hitting the limit. I certainly can't keep up anymore, and I've been programming for 15 years. I've tried. I can't. New mountains appear every single day. And we even have tools that generate new mountains for you on demand. Anyone ever use a framework or Rails or any flavor of thing that generates mountains for you? We're getting to the point where that two people studying the same craft can't talk to each other or relate what they're working on to their friends and family, the people that you know and love. We've turned something that is deeply, deeply human into something bordering inhumane. What do we do about it? How do we even begin to clean any of this up? How do we tear down the mountains, the scaffolding, and all the unneeded complexity down while staying in touch with basic human intuition? How do we do this without sacrificing the last 60 years of advancements? How do we build tools that can withstand chaos? And for those of you who think of robust systems, this talk's for you. But to even start, we need to talk about how humans learn, explore, and internalize new things. We also need to talk about how they maintain and update that knowledge. We need to have a good, solid grasp on how knowledge is constructed and how concepts weigh in our minds. We really need to understand how much conceptual weight we have piled up in our heads, because it's getting out of control. And I'm getting very, very tired of carrying it around. Learning is often seen as the process of layering. We layer new, isolated concepts on top of each other in the hope that they'll interlock. Once everything clicks into place, you'll gain a greater understanding and intuition about things, right? That's the way it's supposed to work. That's the hope. We follow the exact same patterns in constructing software, layering abstractions on top of each other in the hopes that they will click together, and you will gain newfound powers over the systems that you build. But it's all the same stuff. It's all the same practice. It's all the same geology. Layering is how mountains are built, and it often takes less time to build a mountain than you'd think. In my observations, learning is less about layered, isolated, interlocking concepts, and more about connecting with pre-existing intuition from all over a person's mind. I have a small background in education. It started about 10 years ago. And my learnings from that, my connection with humans who want to desperately understand this field, that's something I don't want to trade for anything. Hobbies, habits, activities, interests, they're all great candidates for this intuition. If someone loves to cook, I can connect algorithms to recipes and have them understand what I mean. This is something that really doesn't take place in introductory computing courses. You have to go out of the weeds to find it. The more prominent and strong the intuition, the more it can be used as a basis for new concepts. Learning is less layering, and it's more akin to weaving, like web weaving. It's all the same cognitive material, just woven in different patterns. To that end, this weaving of intuition can happen in a number of different ways, each of them individualized and deeply personal. And learners have to be able to explore how they can weave their own intuition so that they can carry themselves forward, because we can't handhold forever. We can offer them a nurturing environment and give them a push in the right direction, but they need to be able to explore the space of possibilities, to rewind and fast forward, to pick apart alternatives, and to examine and internalize cause and effect. I take some action and something happens as a result. They need to be able to play and learn through play. A grand majority of the tools that we hand to beginners cannot and don't meet these requirements. And it's not because it's an inherent flaw of software. It's because of the force of historical inertia. These are the models we've used. This is how we teach software development. This is how we teach computation. And this is how we make a living from it. And nothing can change, ever. It's frowned upon, which I think is absolutely wrong. We need to break this cycle of inertia, else we'll continue to be swept up by it, never ending. So to break the cycle, we need to look into how we lost pace with our tools and how the old masters developed their intuition. I'm of the opinion that something went very, very wrong in the past 40 years. And it's been largely unaddressed, despite it being pervasive and visible. You'll hear whispers of it in retro computing and low-level programming circles. It's as if it's forbidden arcane knowledge. It's not. It's just forgotten, cast away, swept away by the tides of time. There's this idea of growth versus mastery. The idea that, given some set of tools or resources, it takes some time to fully master their usage, to effectively utilize those tools and resources. We see this everywhere. It's why the demo scene is impressive, and why developers on older console generations shipped more technically impressive games at the end of a console's life cycle. The Mies engine, that thing was amazing. Like, it demonstrates mastery. They mastered the platform. It may be days, weeks, months, or years before things really start taking structure, but mastery can be attained. That's the one thing that we know. But if the tools keep growing in complexity and features, the criteria for mastery keeps getting larger, and it becomes impossible to keep up. It's just that it's gotten so much harder. Fewer people understand totally what a given system does. Fewer masters emerge, and the flow of knowledge is broken. This leads to mentorship gaps, and large institutions or companies rarely have a solution to this problem. It sits unaddressed, and it leaves everyone feeling some flavor of worthless. Crafting software becomes incredibly painful, and we often try to avoid pain. We seek comfort in counterculture. I'd argue that handmade is a form of counterculture. We're trying to ease the pain of practicing our craft by going against the grain, by trying to avoid the things that got us here. It's comforting, because here, the growth and mastery curves are fully aligned. We have they're fully aligned. It's so satisfying to see something actually work while having a complete understanding of it. It's incredibly empowering. And counterculture should be empowering as a first principle. But we should take a critical view on the solutions that counterculture generates, because there are no silver bullets. But there might be some really cool alloys. Often we shrink the mountains, but lose the ecosystems that are thriving on their slopes. We lose things like office suites, web browsers, and the standards of interoperability that we've come to expect of the systems that we build. Mastery that is easy to obtain, but ineffective once obtained, sometimes stings very badly. We're reminded that the real mountains exist, and that we need to climb them. It's hard not to feel incredibly discouraged. You are still doing real useful work, though, and that never changes. How can we make counterculture work? What if we switch things up and focused on cultivating intuition as the basis for a computing model? What if we had our cake and ate it too? How can we give any individual, regardless of where they are in their computing journey, tools that are universal and easy to understand? What would it look like? What form would it take? How far could we get? Turns out, there exists a model that may check all the desirable boxes that we're concerned about, including some ones we really didn't even plan for. It's beautifully symmetric, easy to implement, provides a basis for common language and the communication of computing concepts. It's called rewriting. Much of my work in the past 8 years has been focused around rewriting. As an independent researcher, I've come to the conclusion that is the perfect candidate solution for the problems that I've been talking about. It takes many forms and has many interpretations, but the basics are incredibly easy to grasp. As Devine mentioned, it's also woefully underexplored, and it offers some very beneficial technical aspects, some of which are very hard to obtain in traditional languages and paradigms like functional programming or imperative programming. And doing so, achieving those benefits in those paradigms is often an entire PhD or an entire research thread in its own right. In contrast, rewriting can be explained in a few minutes. It offers a very clear path to mastery, as there are very few moving parts, both implementation-wise and conceptually. However, some developers seem to struggle a bit with it, trying to search where the complexity went and where it's been shifted, and we'll cover that. But first, I need to introduce you to the fundamentals. There are two fundamental concepts in rewriting: structures and rules. Structures are the medium in which you encode your data, the things you want to compute with. And there's typically just one single global structure to act on. You can treat this global structure as your kind of main memory, your brain, the place you store your thoughts, your scratch pad, something that you're performing computation on. While rules are code that transforms a part of the structure in some way, guided by a form of pattern recognition and pattern matching. Everything we need can be built on top of these two intuitive concepts. Structures can be any data structure you're familiar with. Strings, trees, sets, multisets, maps, etc. Rules are equally simple. They tell you what to search for in your structure of choice, and they tell you what to replace it with. Rules always search for a substructure or pattern in some global structure. If you've ever used find and replace in your text editor of choice, congratulations, you're a rewriting programmer. You've used string rewriting rules. Just, you have a button to do it. We have a ton of ways to handle the matching of the rules as well. Different evaluation strategy exists. If multiple rules match at one time, I can roll a dice and say, okay, rule number 3 popped up on the dice. I'll just match that one and continue going. Or we can have priority-based evaluation. Rules that get written before other rules take priority. We have a lot of options here. Based on specificity, what you really care about, you can choose the evaluation model for. And this also opens the door to a lot of parallel evaluation. But I'd like to narrow my focus to multi-set rewriting, as that's what I've been researching for the past few years. And I'm also going to go with simple, basic, priority-based rule evaluation. Right? You go from the top of the rule list and you go down each of the rules and you say, does this one match? No. Does this one match? No. Does this one match? Yes. Fire that one and then go to the top. But what about our data? What's the structure? What in the world is a multi-set? A multi-set is a fancy name for a bag of stuff. Right? You have you have a bag that you can put stuff in, just throw stuff in. Maybe you have multiple of the same thing. Maybe you have a bunch of rewriting zines that you threw in your bag and then started handing out at a conference. You have multiple rewriting zines, right? These bags don't have any order to them. They can have duplicate items in them. It turns out that these structures pop up everywhere in places you don't really think about. And they have some really, really useful properties. If anyone is looking at technical stuff, multi-sets are a CRDT. Food for thought. Think about every random scribbling or unordered list that you've ever written. Think hard, because a lot of things might qualify as unordered bags of items. Grocery lists, to-do lists, ingredient lists. You will start seeing them everywhere eventually. And not only that, several processes that occur naturally are able to be written very cleanly in terms of rewriting. The passing of time, the changing of seasons, the cycle of crops, the act of cooking, the process of crafting and manufacturing. Everything involves some before and after, cause and effect, things that we consume and produce. Which means that we can connect with a lot of baseline intuition that folks who are new to this field come pre-equipped with. This is a simple rewrite rule. It searches our bag for 3 things: apples, oranges, and cherries. If it finds all of them, the rule will match, and we'll remove apples, oranges, and cherries from the bag. We'll then put a finished, fully prepared, hopefully well-sealed fruit salad back into the bag. And we need all of the ingredients, all of the conditions above the arrow to match a rule. If you can understand this, well done. You've seen your first rewriting program. This is effectively Hello World. We can have multiple rules. Here's a simple to-do list. The first rule searches the bag for a do chores item. And if it finds one, it replaces it with do laundry, do dishes, and sweep floors. The second rule searches for a laundry done item, a dishes done item, a floors swept item, and replaces them with a chores done item. Reads kind of nicely, doesn't it? Here's the chores I have to do. Here's how I know if all my chores have been done. If I've done the laundry and washed the dishes and swept the floors, I'm done with my chores and I can go play video games or go read, go do whatever I'd like. This looks familiar, doesn't it? A simple game loop. Now we're talking. Okay. This doesn't look like a rewriting rule, does it? It just looks like some kind of procedure, some kind of method definition or function definition. That is not an accident. We get procedures for free with rewriting rules. They are a universal control flow structure. We can write in something that is effectively pseudocode and have it mean what we intend to mean. By the way, this is an actual real piece of sample code. This is a common loop that I include in rewriting programs that use some graphics and input. I can reuse this little rule to say, hey, I'm writing a graphical program or something that looks vaguely like a game. Just go ahead and include it in the program, no problem. Let's get a bit weirder. What if the items in our bag were lists of words? All right, so you have multiple lists of words in your bag. What if we added the ability to add wildcards or variables to our patterns? Well, you gain the ability to write more general rules. Here's a simple tool to help you navigate the weather relative to some entered preferences. The rules are above. In this case, there's only one. And the initial state of the bag is below. We start off with 3 items in the bag telling us that it's rainy outside, we don't like rainy days, and we don't like cold days. The highlighted words, the ones with the gray background and the black text, represent holes in our pattern, variables that can take on any value. What happens if we try to match this rule? Oh, cool, looks like it matched. We searched through the bag, found it's rainy outside, searched even further and found I don't like rainy days, and consumed them both. We replaced them with I'll stay inside today. And because nothing else matched, we stopped. Simple, right? But how can we take this further to something like, I don't know, game logic? What if I have some complex information that I want to throw into my bag? Say I'm writing a roguelike and have some pieces of information that are relevant to my game. I can write them in a very straightforward manner, something that resembles note-taking rather than defining data. Here I'm constructing a very small game world, one where things exist at some X and Y coordinates, can have weapons, can get struck by lightning if they're holding a conductive weapon, maybe they're unlucky. Notice the absence of things like classes or types. I just wrote down what I wanted in my game world. I conjured data from nothing. And I can write some pretty straightforward logic that handles those lightning strikes that I want in my game world, including a general rule that looks up and applies the appropriate damage value. It's pretty self-evident, right? I'm assembling what I need to do some useful work immediately as it's required, on demand. I don't have to care about classes, methods, attributes, types, or anything that is conceptually heavy. What happens if we run this? Oh, looks like the enemy we defined earlier got struck by lightning because they were carrying a sword, which is conductive. They were then hit for some damage after the strike happened. It's important to note the sequence of events here. Every time we successfully find a rule that matches, we fire the rule, consuming everything above the arrow and producing things below the arrow. We then go back to the first rule in the list and start checking for matches from there. So the first rule matched, which consumed information about the lightning strike. And then the first rule failed to match because the lightning strike went away. So the second rule takes over and says, okay, I'm able to match this. Let's deal some damage to this enemy. And then because nothing else really matches, evaluation stops. Your program halts. This is time to cue video 1.mov. It's not like this is some kind of hypothetical system either. This is Grimoire, an interactive fiction system written by one of my team members, Yumekas. Underneath, it's utilizing rewriting rules to govern transitions in the story relative to choices the player makes. It also governs the resources, the notes, and various other aspects of the game that are kind of governed by rewrite rules. What's really cool is how slim this is. Yumekas had the idea and implemented it in a matter of hours. They were able to get off and running because rewriting lends itself well to small, simple interpreters and compilers. If you're familiar with Twine, this is incredibly similar, and it's super cool. The source is also incredibly, incredibly small for what it does. The semantics compress very, very well. How many of you in the audience have seen Devine's rewriting playground named Tote? Show of hands. Okay, well, you're about to see it now. So the representation of rewriting rules doesn't need to be strictly tied to text or any kind of specific encoding or language. In fact, we can build programs in rewriting languages without having to touch text at all. We can use hand-drawn symbols instead, making the resulting language pictographic. And all of the magic is preserved, if not enhanced. Load MOV2. This is an example Tote program. It depicts a farmer tending their field according to the cycles of harvests. The rewriting rules model the passage of time, the growth of crops, the farmer's harvest of the crops, and the growth of the farmer's field. This isn't just an algorithm. This is describing a real-world process. It doesn't just describe a computation, it conveys an idea. There's incredible power here. And because of all this beautiful symmetry that rewriting languages give you, I have never seen this in another model of computation, ever. Nowhere. Load MOV3. I'll see if you can tell what's happening here. I don't know about you, but as I kind of watch it working, like, it's beyond magical that that even just worked. Those are actual UI elements, right? That's an entire board game phrased in terms of rewrite rules over arbitrary symbols, right? Hand-drawn stuff that you can edit in on the actual canvas. Like, that's proof of life. That's like watching actual magic happen, at least for me. The tool also supports backward and forward execution now. Tote was developed over the course of about a week after I described my plans for an IDE for rewriting. Imagine that, an IDE in a week running tic-tac-toe. I'm so glad I nerd sniped you, Devine, because this is really magical to watch and all come together, like flat out. It was brilliant. These are real programs. They run on your computer. They share the same underlying model of computation, and they're quite portable. I can take a program I've written, import it into Tote, and experiment to my heart's content. I can export rules I've written from Tote to a textual format and do crazy things like compile them to native code, or run them in an interpreter, or embed them in my application. This is a fraction of what's possible. To show you what's possible, I'd like to introduce you to Nova. Nova is a lightweight language for conversing with computers. It is a programming language, a data format, a computing stack, and I hope the technical portion of the solution for the problems I've discussed today. Nova is my attempt at an understandable computing system. It is intended to be conceptually lightweight, but flexible and malleable enough to fit into any situation where communication gaps exist. Nova can serve as your primary programming language, as a note format, as a method for conveying ideas, and as a sketching tool for software. It's based on rewriting, and you've seen some examples of it earlier in the talk. It unifies several threads of research, some of which date back to the 1920s, and I'm very excited to get to open up about it. But first, a disclaimer, I am not here to promote my own language. I'm not just here to preach to you about how I have the solution to all these problems sitting in a repository somewhere. I am not here to start language wars. I'm here to show you how rewriting can be applied effectively. I'm here to show you how I'm applying it to my project and what it can really do. Rewriting is incredibly powerful. I'm just the messenger for that idea. Because these concepts have been locked behind impenetrable walls for decades, they deserve to be brought into the light. So Nova is a rewriting language. Nova performs rewriting over a bag of variable length tuples, that lists of words concept that we went over a little bit ago. We call this bag the knowledge base, and we call the tuples in the bag facts, little atomic pieces of information that you, the human, are concerned about. Like we covered earlier, Nova rules search for and consume items in the knowledge base according to patterns. These patterns are simple and can contain variables that are bound to values as the search happens through the knowledge base. Your only method for specifying any kind of data is by writing down facts. And your only method for writing any code is by writing rules that consume and produce facts. Here's some example facts. The sky is blue. The player has a sword. You're in the foyer. It is dark. You are likely to be eaten by a Thu. So let's shed some light on this. The previous slide was example code, and I'm going to reiterate that a lot. Simple white space delimited tokens are really all we need to pull the magic off. It's a simple touch, but because we're not doing any kind of natural language parsing, it makes implementing Nova so much easier. Maintaining the balance between easy and simple is key. I have tried to design it such that beginners can pick it up and run. Having a low amount of conceptual dependencies is crucial. Newcomers don't need to understand nesting, scopes, or any special cases or interactions between different language features. It's just rules and facts, flat and simple. Fresh terrain to roam. And while the implementation is simple, the leverage it gets you is much greater than you could possibly imagine. Things that would necessitate something like an entity component system, ECS, or a textbook on data-driven design and event sourcing take just a few lines in Nova. I don't have to think in terms of arrays, lists, or any other structures that aren't explicitly required for me to express my intent. Right? I don't have to encode my thoughts. I guess that's why they call us coders. I can model complex logic, cross-cutting concerns, and corner cases that would be time-consuming and buggy to model in traditional methods. Let's look at an example. Let's build a simple text adventure movement system, starting with some sample locations and a starting location. Let's also define some useful information about directions, like north is the opposite of south, east is the opposite of west. A reminder, this is sample code. This is actual data that we can manipulate. This is the initial state of our program. Let's see what the code to handle movement looks like. What do these two rules say? If we're in a place and we move a direction, and there's a place to move that's in that direction, we're now standing in the adjacent place. The missile knows where it is. Or if we're in a place and we move a direction, and there's a place to move that has a connection to the place I'm at, but it's in the opposite direction, well, I can move there because the connection exists, so I'm now standing in the place I tried to move to. I only have to specify one connection between two places, and these two rules will detect and derive implicit information from little bits of knowledge that I gave the machine. What happens when we run it? Looks like the second rule was the only one that matched, which is great. We're in the foyer. We try to move east. The kitchen is west of the foyer, and west is the opposite of east. Therefore, there's a connection between the foyer and the kitchen. And because that rule fired, we're now sitting in the kitchen. I can imagine the equivalent code in C, Python, JavaScript, or any other language. It's not that complex, but it forces you to encode your thoughts into a new format that the computer can run. Wouldn't it be nice if we could just write what we meant? There's another example. Here's a little image of a smiley face. I love him. And this is encoded as some Nova facts, emphasizing that it's a data format. We have some XY coordinates, some RGB values, and an image name. Let's say, for example, I wanted to generate a palette from this image. I want a collection of all the colors in the image, and I want to give them unique names or identifiers so that I can use them later. What would the rules look like? Well, they look like this. If I have a pixel in an image with some RGB value, and this RGB value is already in the palette that I'm generating, replace the RGB value with the name of that color in the palette. All right, I'm replacing the actual pixel data in the image with an index into a palette. If I have a pixel in the image with some RGB value, and it's not in the palette, meaning I don't have anything else, no other rules matched, right? Then generate a brand new palette entry with that RGB value and replace the data on that pixel with the name of the color that's in the palette. Now notice, like, in the second rule, this is not in the left-hand side. The word color, or the variable color, isn't in the left-hand side. If you use an unbound variable, we'll just generate a unique value for you. We'll fill in the blank, right? We can play Mad Libs that way. This is incredibly useful, if not crucial, for things like games. Right? I can just spawn an entity, slap an ID on it, and go. I don't have to worry about a ton of things that I would need to in other systems. How about some simple input handling? I'm pretty sure this is self-explanatory. I assume some rules exist that grab mouse input, do some rudimentary bounding box math, and handle some actions. It's all out of sight, but it's phrased in the exact same rule formats that this particular rule is using. It's super versatile, super simple, and can even act as a kind of configuration language that can either be incorporated into your build process or into running code. What does all this buy you? This is pretty esoteric, right? It's a little far out of the, out of the reach of a lot of stuff. Well, rewriting languages model time in terms of rewrite steps, right? With traditional virtual machines, you have a program counter that zips all over the place, and if you're working in a higher level language, you have to role play a computer line by line and see how your code executes, right? And those are the individual steps. But here, there's no breakdown of those steps. We find rules which match, apply those rules, and repeat. That means if you stop the execution at any point, you can take the knowledge base, throw it on another computer, and resume execution. Rewriting is natively reentrant, which buys you a ton of newfound power. Each rewriting step is like a database transaction. Read, modify, write. It doesn't matter if it's in memory, on an SSD, on spinning Rust, or on another computer. Everything is transparent to rewriting if you want it to be. Each of these things individually is a research project in and of itself, but we get all of these properties for free with a simple model switch. Nova can function as an independent language or as a way to augment existing languages. I can take a piece of Nova code and compile it to assembly, C, Go, Java, JavaScript, you name it. Imagine being able to hand someone a note file written in Nova, integrate it into your build system, and collaborate with people that don't use your particular programming language, but can now express computations and ideas in a common portable format. You can communicate with people who are not programmers. Big win for a lot of things, including things like game studios, small businesses, and people who just want to write simple, easy to understand tools for themselves that are self-evident. I did not design this as an educational language, but it fits the bill. With educational languages, there's a common thread. You can't carry them with you throughout your programming career. MIT's Scratch and Seymour Papert's logo can't fit into the places that we really need them to without some heavy effort. Newcomers have to graduate to new, real languages to continue their journey. And I don't think that's fair to them. We need to build tools that can evolve and persist as people grow and explore. If we don't, we're just setting them up for constant context switching and giving them conceptual dependency graphs that rival some of the worst NPM packages. We're craftspeople. We need to start acting like it. We need to acknowledge our relation to other crafts and trades and ask, do we really have the right mindset here? If we don't, we'll lose sight of the ground. We'll lose sight of what it means to be a trade. We can't keep this process of discarding skills and tools and methods up. It's just not tenable. Potters do not outgrow clay. It is crucial to their craft. I am really grateful to be presenting this at Handmade. I feel like we're at a tipping point where people are genuinely fed up with the status quo. We're sick of seeing our craft exploited, our dreams grifted, and our hopes for the future dashed by another social problem peddling a technical solution. And it's here I feel the most difference can be made. Something has to change. And it'll come in two parts, technical and social. Our craft will have to change. It has to in order to survive. We have to become proper stewards from all angles. With that, some closing thoughts. Brett Victor's presentations motivated me heavily when I was younger, but as I got older, I realized that he was using the exact same material as everyone else. He showed that we didn't need to have to keep thinking of programs as opaque boxes that were constructed by role-playing as a computer. But even then, he was limited by things like JavaScript. When you're fighting your language or your computing model, everything is incredibly hard. You're fighting the forces of nature, and you will lose. The only solution is a change in model, in perspective and in principle, usually all at once. We have to find symmetry and balance in the things that we build and use. This work did not happen in a vacuum. I spent the last 8 years digging up old papers and concepts, searching for fragmented pieces of knowledge via the Internet Archive. And I've tried to piece together the past that had been forgotten. There's so much research that didn't get capital infusion and was left to die. Everything in this talk was an aggregation of that research. And in that same spirit, gain some perspectives and tear the scaffolding down around your programs and around yourself, if applicable. Get rid of unneeded structure, needless complexity. Try to connect with people around you that aren't doing what you're doing. Think about how they'd understand what you're working on, and if they couldn't, simplify, simplify, simplify. Doing more with less is one of the major principles I've been following, and will continue to follow. Ideas should be multifunction and cover as much ground as possible. This lets you breathe and avoid falling into cognitive overload because you have a few small, simple things that you can remix. I don't like to use the analogy of Taco Bell, but same 5 ingredients. Don't build factories. Don't build things that you can't physically relate to. Physical engineering has the benefit of having a limiter on the degrees of freedom of anything that's built, enforced by things like gravity. We don't have those kinds of constraints. Don't focus on cramming as many concepts in your head as possible. Instead, ask, well, I know X, so can I rephrase Y in terms of X? Every time you encounter a new concept. It'll help you connect the new concepts to the old ones, and you'll have an easier time learning. Be careful about assuming what others know about what you're working on. It's easier to assume nobody knows what you're working on, and that'll give you the ability to explain what you're working on in simple but clear terms. It'll make you more confident, and you can practice it every day by talking to friends and family, people outside your circles. Spread the joy of computing around. Alan Perlis would be proud of that. And in doing so, you can build people up. You can tell them that they matter, and that it's possible to have agency over their own lives. That if a human understood this once, a human can understand this again and again and again. That mastery is achievable, and there's a ton of other people that want to help them along, should they need it. Most importantly, you can tell them that they aren't alone, because we aren't. We never really were. We just thought we were. Thank you.
Thank you. Sit right here. We can
Absolutely. Shout outs Team Vega.
All right. Before we go to lunch, let's have you answer some questions, okay? It's a lot of questions. I'm not even sure we can get through them all. So like I tell my other speakers, if you can later in the chat at your leisure,
Of course.
respond. I'm just gonna pick the popular ones, okay? I'm just gonna go populist here. There's some that have a lot of thumbs up. Like this one, for example, has almost a dozen thumbs up. From Ben. Hey, Ben. Isn't it hard to understand the execution of large programs when you have to hold a large list of rules and their priorities in your head?
Ah, that's a good one. So how do we organize large programs typically? We break them up into smaller subunits and then rearrange them as needed, right? Why can't we do the same here? In fact, I'd argue it's a lot easier. A lot of the sort of physical intuition about rewriting comes out when you say, hey, if you remove the machine, how are you going to organize this program? A common analogy and actually organizational method we use is something called a note card, right? Just a simple piece of paper that you can write a rule on. And you're like, okay, so if I have to juggle priorities around, fixing a bug or working with priorities or adding a new feature to my program is just adding another note card on top of the stack of existing ones. If you want to actually execute a program, you would go down the list of note cards and say, okay, does this rule match? This rule match? Nope, 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 nope. Okay, next card. Which I think is kind of neat because it, in some ways, looks like Hollerith punch cards. I don't know.
Mark.dev asks, what are the rough edges of rewriting languages?
Ooh.
For example, are there times you wish you could just do X, Y, Z thing from a typical procedural language?
Yes. The thing about it is that while it is a universal control flow construct, while I can express anything I'd like to in terms of rewrite rules, I still need to think a little bit about sequencing and priority, but the more you use it and really get to grips with it, it kind of fades into the background. The place where I would say, things get a little hairy and a little pointy is the idea of mathematics, right? We have complex mathematics expressions, and depending on your flavor of rewriting, those may be a little bit hard to express. My language modal was mentioned a little bit ago. That's a tree rewriting language. So how do we normally write mathematical expressions or any kind of piece of code that goes through a compiler? Well, they're typically structured in terms of trees, parentheses, and that's actually kind of where the original concept came from, expression reduction. So in tree rewriting, math is actually quite easy, right? But in something like multi-set rewriting, math can be a little bit difficult. In Nova's case, what I do, and also in the general case of multi-set rewriting or bag rewriting, what we do is we say, okay, I want a computation to happen. Throw out a flag into the universe, and then eventually that flag will come back, say I want to throw 2 + 2 out into the universe, and then out back comes 4. So it's throw and catch, right? And I can delegate that. If I have 2 people in a room and I say, you're following this rule set, and I'm following that rule set, right? I was like, oh, I need this result from you. Scribble, scribble, scribble. Here you go. Get back to me. Okay, thanks. Now what does that look like? That also looks like I/O. How many people have dealt with monads in the past and be like, why do functional programming languages and why do all these computational models fail at the I/O test? Because it's incredibly hard to do. Lambda calculus wasn't built around I/O.
From Felix, thank you for your question. What about performance? Role-playing as a computer allows us to be fast.
That's the kicker, isn't it? So we are doing real-time things with this. Like I showcased a little bit of a few snippets of this language. A member of my team, Capital, and another member of my team, Umekas, collaborated to write a small zombie shooter demo using these principles, right? So when we're concerned about performance, what we're really concerned about is the speed of a rewrite rule. That's a concrete thing to optimize. How fast can we actually get rule matching and resolution and firing done? If you actually look at the structure of the generated code, and you don't need to squint, it looks like a custom-built virtual machine for your program. You are defining the opcodes. You are defining the rules for the machine to follow. And if you look at the generated assembly or C source or whatever you're working with, it's going to look like a dispatch loop for a typical bytecode VM. And you can make those obscenely fast. And you can also choose your granularity. You could say, hey, I want a line drawing primitive because my implementation is kind of slow. Great, call out to SDL. Good luck.
How does a rewriting language like this not become a mountain again? If you don't have control over memory or other low-level things, then you will have to give it up and learn something else when you hit a performance wall.
That's the thing, is that like once you hit a performance wall, what do you do? Well, since your language is built of input and output, what did we do when graphics processing on the CPU became heavily intensive? When you were literally sacrificing cycles to draw a box, what did we do? We added a graphics processing unit. And the same can be said with literally any other language. If you try to plot pixels in C, right, you can make it incredibly fast, but good luck, because you're going to need to drop down to assembly, bypass a lot of the existing APIs, and really try to do basically what amounts to direct memory mapping. I don't have to really concern myself with that, because every time I hit a performance roadblock, I can say, okay, what can the system around me offer, right? What built-ins, what invisible rules can I give the system that take priority, right, over all the other rules do for me? I can add a line drawing primitive. I can add a polygon primitive. But if I ever want to do those in the language itself, I can drop down very far and sort of like gain performance out of that. What we're doing right now is we're actually experimenting with a rule-based assembly language that compiles straight to assembly. So you have control over the low-level aspects. I can drive a GPIO pin if I wanted to. I can run this. I can compile something and run it in a boot sector. It's the same material that you've been working with, just phrased in a different form.
What is the difference between Nova and a rules engine like Drools? I think I said that correctly? Yeah.
Yes. So there's this flavor. I'm going to mention logic programming, because I'm sure anyone who's taken a university course or who has been in esoteric circles probably has heard of something like Prolog, right? You probably also heard of Eclipse, right? The Common Lisp rules engine, actually built and sponsored by the JPL.
Really?
Yeah, Eclipse. Yeah, because they needed like task guidance and automation. It's actually quite neat. So what's the difference? And really, there is no difference, except for how you escape the problem of memory. In logic languages, especially things called forward chaining logic languages, you say, here's the facts that I know about the world, go ahead and just run these rules and then like stop until saturation. It's like, here's some facts, tell me everything you know. Well, unpacking that from your brain is going to be like, it's going to need like gigabytes of memory, if not more, depending on the complexity of your problem. What Nova allows us to do is say, okay, we embrace rewriting. That means we can get rid of stuff that we no longer care about. We can sort of prune our knowledge base, which is kind of where all this started. We can say, hey, yeah, I'm hungry. Get up, move around, go to the fridge, open fridge, grab food, go back. I don't remember that I was at the fridge, or I don't experience that I'm at the fridge on the couch and eating food at the exact same time. That's a process that happens.
Fascinating. A couple more questions. I think I have time, but there's so many. You're gonna have
sure.
fun.
I'm
gonna
sure.
have fun.
Thank you for the homework.
I am a beginner. In practical terms, how does this help beginners? Or is it all conceptual?
No, it actually definitely does help beginners. If I ask you to like invent, if I take you through what computation is, if I start you from scratch and say, okay, look at the world around you. Try to find some examples of computation that you experience every day. This idea of cultivating intuition and connecting new concepts back to old concepts and weaving them together, right? We all experience computation daily, like in the processes that we go through at the checkout counter at the grocery store, at work, right? We have process flows. We have process engineers who are literally like orchestrate the entire movements of humans throughout a corporate system. Like, we experience computation and yet we're blind to it because it's so unlike what we do with machines. And this is why I say computing right now is kind of inhuman, because it doesn't mirror what we're doing every single day.
Ooh, Mark.dev asks, any pointers to source code like the zombie shooter?
So if you join our Discord or go to the wiki in about 2 days, once I've had some sleep, we're going to have all the source repositories for not just the
Awesome, yeah.
stuff demoed here. Yeah,
That's so cool. It is noon. It is time for lunch. But like this was incredible. Round of applause to Uriel. First time speaker. Are you serious? With that booming voice that you have, huh?
I thank you.
Amazing, amazing. Okay, let's talk about lunch before you guys disappear. Excellent. Okay. All right, so as I promised, first things first. I gave you, no, I didn't give you this. These speakers gave you wonderful, interesting presentations that do go into the outskirts of what Handmade is used to. And I think that's important. I do think a conference should offer a buffet of different things, not just the classic things that we know and love. We should probably try to poke around a little more, okay? Although this afternoon, we're landing back to ground what? Ground zero? Is that how you say it? Ground zero, And we're going back to like the classical handmade stuff that you like, but I really enjoyed these presentations. Really important. Look at those questions that you got on the chat server. Really interesting conversations from both, thanks to both of you. So for lunch, 90 minutes. Once again, I promise you got the full 90 minutes, okay? And I wanted to make a couple of announcements about food. So Taylor, can you raise your hand again, Taylor? Hey, there's Taylor right in the center. He just suggested on the chat server, on the meetups channel, suggested La Palmera. I like that. It's a Mexican restaurant. I believe it's within walking distance. And then some people are going to the Armory again, as the meetups channel says. And I'm going to flag, I'm sorry, Ben. Raise your hand again, Ben. Hey, follow Ben. You remember him from yesterday. He will probably help you guys too if you don't know where to go for food, right? So good times. We come back to presentations, demos again, okay? It's gonna be fun. Day 2 of the conference. It's time for a break. For the online track, oh yeah, you guys can start going, no problem. So for the in-person track, go have lunch, enjoy yourselves, all right? Come back by 1:30, do your best. And then for the online track, we are going to rebroadcast a presentation that I did at Handmade Boston, okay? It's with Basso, the creator of Animal Well, who was going to be a keynote speaker for this conference, but because they got awards, nominated for so many awards, thanks to their game, that got shipped this year. We're talking like 2 huge shows. I think the Joystick Golden Award, something like that, and the Jeff Keighley's famous The Game Award. So we got lots of nominations. So we agreed to bring him back next year as a keynote speaker. We just couldn't make the scheduling work. So listen to this interview that I did with Billy Basso full 1 hour and 30 minutes. Fantastic conversation about how he followed Handmade from the very beginning to ship Animal Well, and is now off, doesn't even have time to come here because he's just accepting awards. So please enjoy online track, a rebroadcast of Billy Basso on making handmade software for Animal Well. Hello, Internet, and welcome to another Handmade Boston. This is the second Handmade Boston we've ever done. As you know, the Handmade conferences have always been in Seattle, and just last year, for the first time, we're trying to expand our presence a little bit, grow this indie movement a little bit. And so Handmade Boston we call it like the sister conference to Seattle because it's smaller, it's more intimate, and we're trying to go back to the OG spirit of just like talking to somebody that we admire, who's done interesting work, and get to know what they're up to a little bit and like what their thought process is to build this kind of software that we love, right? So today we are joined by none other than Billy Basso, the creator of Animal Well. Hello, Billy. What's up?
Hello. Happy to be here.
You're alive?
Yes, I'm alive and feeling all right. Feeling pretty good.
That's awesome. Congratulations on the work that you've done this year, and especially a year that is not easy, for many people. There's folks who have been affected by layoffs, or folks who just like have too many personal life situations. It feels like almost everyone I talk to has a situation going on, right? It's just one of those years. And so it's fun to hear that, there are still some, definitely some success stories going on that we got inspired by. And so good work with that. And let's start actually with how we even met, you and I, in the first place. How about we surprise the audience with that?
Sure. Yeah. So I'll just start. I've been following Handmade Hero and sort of the Handmade Network stuff since the very beginning. When Casey started streaming, making his game engine and game from scratch. So that was, I think you told me back in like 2014. I remember actually watching it while I was at work. I was at Phosphor Games at the time, and just like, I remember kind of some people at the office being like almost like joking about it, be like, oh, well, why doesn't he make the computer himself too? Or why doesn't he why don't you build the universe? Just like kind of extrapolating the sort of the philosophy to a comical extent. But then, I have just been sort of aware of what's been going on and followed along a lot. And it's been, very inspiring, like useful resource for me for a large part of my career. And we actually met in 2019. I went to Handmade Seattle that year just because I was a fan, and I think we chatted for a little bit and probably just blended in with the crowd. But I was in the first couple of years of working on Animal Well, and it was still like kind of in its early infancy. And I was just there kind of checking out all the cool stuff people were working on.
And that was a core memory unlock when we talked recently. It's like, yes, I remember. And I even went to the ticket sales records. I'm like, there's Billy. It's like, That's cool. I do remember a little bit of that, and
Yeah.
that's awesome. And in some ways, it shows the progression between us a little bit because that first Handmade Seattle was like a very scrappy, tiny conference, just starting out, and now I can do it full time. And then you kind of like in parallel are writing, making this video game. It was early on. Did you even know how far you were gonna get with it, or?
I think it was still like, yeah, kind of early on, and it was a thing I just like was kind of working on my laptop, and I remember sitting and waiting for like the Mike Acton talk that year in the room, and I was actually programming Animal Well and just kind of just I forget what I was working on, but it was just this thing that it's like I kept in my bag and was just kind of doing on the side for fun. And yeah, I was actually, I think I wanted to show it at Handmade Con, maybe the following year, and that's what I was asking you about, because I was like, I think people would appreciate this, but then I kind of got very busy and development kind of exploded in complexity.
Yes, I can't imagine. And we'll get into the
And
development.
COVID happened. I forgot about
Oh
COVID.
yeah, yeah. That was a huge pivot too, because I was all in person. Then COVID happened. I'm like, should I run the conferences only online? How does that work? And in some ways that helped, because after the COVID, I just decided to do like this hybrid live streamed physical online track kind of like conference, and that's what exploded for me to be able to be full time with it. And but today we're not really talking about me here. I want the audience to be inspired by what you've done with Animal War. I just thought it was interesting that we've talked we talked many years ago already, and it's awesome that we finally get this chance to discuss some more. So what led you to, let's just dive straight into, so I'm assuming the audience has played Animal Well. If you haven't checked out Animal Well, please do. It is on Steam. And do we have any other platforms?
Yes, it's on Switch and PlayStation 5 as well.
There you go, guys. So check it out in terms of the game. But today we're talking about the development of it, the programming aspect of it, the audience here. Many of us are programmers in our own right. And we're kind of curious in this question that we get asked all the time, although not as much anymore, because people are seeing the value of reinventing the wheel a little bit finally. Like the industry is finally seeing value in reinventing the wheel again. But it's still a question that comes up, like why reinvent the wheel? And I am curious, I'm excited to ask you, like, what led you to take ownership over your tech stack? And honestly, what does that mean? Because, you might have somebody making a web app where they said, oh, I'm handmade, or like, I'm low level, and what that means for them is that they're not going to use the huge giant JavaScript framework, right? They'll just use vanilla JavaScript, vanilla CSS, and things like that, which is great, right? But they're still on top of some big platform like the browser, right? So that's what handmade means to them. So what would handmade mean to you? What does it mean for you to do everything from scratch, so to speak? And we talked earlier about, like, you're not writing your own RISC-V ISA, CPU, right? Like, so where are you in that kind of like abstraction barrier? And then why? Like, why did you decide to take the plunge?
Yeah, so just as an overview, Animal Well's, it's written in like kind of with a custom engine that was sort of developed alongside the game, and it's C++ based with almost no additional libraries. I use the STB libraries for loading Vorbis files and PNGs, but other than that, it's just using on Windows just the Win32 like basic stuff. It's not even using like Glut or anything like any sort of Windows framework. But yeah, so it just the way it came about was just, I don't know, kind of natural. When I was in college, I took a couple game engine classes. Actually, we had a teacher named Ed Keenan who used to be the tech director at Midway back in like the late 90s, early 2000s. Yeah, just kind of learned a lot about just sort of the basics of what go into a game engine. It was just part of my like sort of core curriculum, but I found it really fun. And I think a big part of the draw to like software and video games to me is just knowing how they work. That's kind of at the core of what's intrigued me about them. They seem, like really kind of magical, like seeing these moving images on screen and stuff. Like, I think as a kid, you just don't know any idea how it works, and it is just incredibly complicated. So like, it's amazing that we have all this software and technology, and so many people just take it for granted about how it does all the stuff it does. So I think, yeah, that's just part of programming. Is I want to get those answers to like, how does this thing I've wondered about my whole life do its trick? Like, and it's just a mountain of questions and answers like that. So in a way, like using higher level frameworks or game engines is kind of like, it's sidestepping the fun part to me, where it's like it's like brushing it under the rug, and it's thinking like, don't worry about how this does the thing it does. You just want to design your game in La La Land and just for the imaginary system, and don't worry, you can just come up with the ideas and use this interface we made up for you, and work that way. So that just feels like, I don't know, kind of a little hollow to me. And I had a lot of experience using like Unreal and Unity at software jobs I've had. So I think in a way that was still helpful to learn, to see examples of how these like large scale systems are put together, and to be able to use Unreal Engine like 3 and 4 and have access to the source code, and on a daily basis be able to kind of like peek into there and step around and just observe how that's all put together and get ideas. But yeah, ever since I like had those classes in college, I was always kind of on the side trying to make a game engine, just as almost like a learning exercise, and continue just trying to make things myself. And actually spent about 2 or 3 years just making a general purpose like 3D game engine.
Oh wow!
Well, as a side hobby, and it was like one of my first like large scale software projects that I made on my own, and this was before Handmade Hero. I started on this before I had even encountered that, and so it's like your typical, like, I think, junior programmer, like learning all the mistakes that you would expect. Just kind of just learn it as I went. Even then, but it was still like an OpenGL engine. But I was using it was object oriented. I had like this big object hierarchy with all these classes, and I was using smart pointers everywhere. And just like kind of all these, and
modern
like not really
isms. Yeah.
Yes, all the modern C++ isms that you kind of just like stumble into using as you're just trying to kind of come to terms with learning how to be a C++ programmer. And there's so much, I was reading, let me see the books. I think I have it right here, like Effective C++ and Modern C++, all those books where you're just learning the language, and you're like trying to advance your skills. So you get a lot of sort of opinions, like kind of unknowingly while you're doing that. And so yeah, that project just kind of ballooned and ballooned and ballooned, and I didn't have like a critical sort of pitfall to it in terms of it actually like shipping into anything, is I didn't have like a clear game idea in mind when I started working on it. It was more just like, maybe I was thinking like, oh, eventually I'll have enough tools here that it'll be like really easy to just make a game, and I'll come up with the idea later. But in the meantime, I'm just gonna build an editor and all these libraries and utility functions for like hypothetical things. And to be fair, it was mostly, I guess, just a learning exercise. It was just an area to have fun. But yeah, it was after I really started watching Handmade Hero, and I kind of, those first so many episodes where I saw how like Casey set up his like gameplay code in a DLL, and just was using just the basic Windows like sort of message pump to, just set things up. And I was like, okay, wow, I've been doing so many things wrong.
You saw the very bare bones
Yeah.
to get something up and running, and that was shocking to you.
Yeah. And it just made me, it was kind of like a little bit of a wake up call. So I continued, I think, working on my current engine at the time for maybe 3 or 6 more months, just like maybe, adopting a little bit of that ethos. But then eventually I was just like, okay, I need to, let me just start from scratch here. I want a clean slate. And I want to just like forget the idea of making a game engine and just like try to pare back the scope of this as much as possible. So and I want to make something with the goal of finishing it and shipping it. And my new ideology is just being very pragmatic in the terms of like what I implement, and only write code to solve a very specific problem like when it arises. So just start with, don't make any assumptions about what a game engine is or what is needed to ship. Just like my strategy was just like, I will deal with it when it becomes a real problem. Until then, I will not do it. So even like silly things like, I didn't even write myself like a vector 2 class for this like 2D game engine. I was just like still doing like just like loose float variables for like the X and Y position, because I was like, I don't know if I need that yet. Let me just see how far I could go. And then eventually
Did you
it's
wrap
like,
it in a struct at least, or not even?
No, not even. But then eventually, like that was early on. It's like, okay, this is a right thing. You need to make a vector struct.
Ooh, so you learned some heuristics as it became painful. Certain things became a little painful, and you're like, oh, okay, I see that this part makes sense to
This part is right. Yeah, it was in a way I was trying to validate everything I thought I knew with like a practical use case. So I didn't write anything preemptively. If I'm working on like I'm early on in like my next project now, and I've learned so much from shipping Animal Well that now I do have a lot of sort of expertise and knowledge about what things are necessary to ship. So I can like, I've like learned some things that I can preemptively implement that I know I'll need, and that'll save me some time. But back then I was more like, I've never shipped a complete game myself. I've worked on larger teams, and I've worked with these like larger engines, and they have, hundreds of features, and you can't just start by implementing those hundreds of features, because it's unfeasible for one person to do. So you have to really kind of just trace the outline of your requirements very, very closely to minimize the amount of work that you actually need to do to get the thing that you want done. So anyways, that was sort of my rule that I sort of made for myself. And I kind of just followed it all the way to the end. It still took 7 years to finish the game, but every step along the way, it wasn't until I did something, 3 or 4 times, and it was becoming obvious that like, there's some redundancy here, and like I waited a good healthy amount of time for the like abstraction to emerge in whatever the system I was making in, and then I would.
And you waited a lot longer than most people think you would want to wait. It just sounds like you really let it go on until you actually felt this almost certainty that, okay, yes, this can be abstracted in this and that way, because, but that's a lot of waiting time that people are not used to. And but now you said though, for your next project, I'm curious, you sounds like you're gonna make some educated guesses of abstractions that you think are going to be useful right away. But I'm wondering, that doesn't mean you're going to put yourself in a straight jacket with those scaffoldings, let's say. Like, do you have a strategy to just say, okay, I was wrong about this educated guess? How straightforward or trivial is it going to be to like break down the scaffolding and build a new one? Like, have you thought of that a little bit? Or
so like there's a few easy examples that are like kind of no-brainers. Like when I first started the project, I think just the scope in my mind was different. I wasn't planning on doing localization, for example, and I wasn't planning on doing any ports. So when I was starting the project, I'm like, this is just Windows. I'm going to embrace all the Windows-ness of this, and I'm just going to use. I'm not going to use wide characters or UTF-8 or anything. I'm just going to use C strings everywhere, single byte characters, and assume that. So later on, I was like, okay, we're going to have to get this localized, and Japanese and Chinese characters or whatever take up multiple bytes. So that was like a thing I had to go back and kind of go scrub through the whole code base and kind of add support for that. So that's like a mistake where I'm like, okay, now I know. I'll never do that again. If I'm going to release a game and put many years of work into it, it's going to be localized. So I know that from the beginning. And then in terms of like porting, like platform abstraction, I think I want to work even harder to minimize the amount of like platform specific code. And I think just out of habit before, I kind of would put more functionality into like the renderer or the audio system or any of these, like when I was like wrapping DirectX or X input or X audio, it got a little tempting to be like, well, I'll wrap this API, but then I'll add some extra stuff to it, like kind of make it how I wish it were. Like I will just kind of hide the fact that there are blend states or something in DirectX, and I'll just like set one up by default inside the initialization code for the renderer. But then when I port it to Switch or PlayStation, now I have this code in there that it's like I'm setting up this sort of like game specific data. And it would have actually been less code if I sort of just kind of followed the API I was wrapping more closely, and then like let the game set that data up, and then it could create multiple blend states. And so that was like another thing I sort of changed mid development, and I was like, okay, well, let me just keep anything that's like that's sort of specific to this game, like in the game code, and like my like engine, which is more just like the platform layer that sort of abstracts what the platform is, just like really be more strict about that, like and try to keep that as small as possible. So then when I do have to port to another platform, there's just less code to write. So you want to just like, you want the porting process to have like require as little code as possible to happen.
It also sounds like your engine, it's not like you said it exactly, but I got the sense that you stopped thinking about your engine as an engine almost, because
yes, yeah.
And I wonder if that shift in thinking really unlocked productivity in ways that maybe it didn't, because I'm curious about your thoughts, because very often if I play devil's advocate for those who tell us to use an engine pre-made in order to ship software, ship a game, whatever it is, have like this pre-made framework, it's because, hey, like there's dozens of people who are smarter than you many years ago who have iterated over this framework or over this engine many times, and it's feature parity in all the ways that modern gamers expect, right?
Yeah.
And so when you feel that you want to make your own engine because you value the ability to understand everything as a programmer, you love the experience of knowing what's going on at all times, and that's just a value that you have as a programmer, is that you love the understanding of everything. And I'm sure that helps also with like innovation. And I know it's a tired cliche, but truly, if you want to innovate on a project, the more you know about the thing you're driving to make the project, obviously, like the more innovation you can do, because like there's no black boxes, right? But it feels scary that people are telling you, like, look at all these engines and all this stuff that they have, and now you feel that you have to prove yourself with the engine that you write from scratch that matches almost all of these features. Or if they don't match it, you feel like you have to excuse yourself somehow, like apologize and like this and that, right? So it almost sounds like for you to drop the whole this is an engine, oh sorry, this is not, for you to say this is not an engine, it's almost like you cast away all of those debates and arguments and concerns and anxiety. Am I correct in that assessment? Or
Yeah, I think that's a perfect observation because in the previous project I was talking about, I was making that general purpose like 3D engine. I had the mindset that yeah, I'm making an engine, and I would say this is my game engine, and there was no game; it was just purely an engine. Um, but then my idea, the shift in perspective I had with Animals development was like I'm making this game without an engine. Like I'm just making the game. The goal is to make the game, and the later on you can point to parts of the code base and be like, oh, that's the engine that like kind of formed under the surface as I was solving problems. Um, that I'll and then in future projects I'll be able to like pluck out certain parts and be like, okay, this solved this problem nicely in a generic way. But I don't want to like assume it's actually counterproductive to like I think make that like an engine's it's it's a mental model that we have. It's not a real thing. Like there's a lot of I think that's a big part of like data oriented programming and like kind of we talk about that a lot, but like a game engine's all it's like object oriented programming where it's like the engine's not real. There's not a single thing you could point to, but like the platform SDKs you're using, those are real. The development kits are real. Like the hardware, the processor and stuff, that's all real. So it's more just like trying to write code for the game, and then when those parts are different, when you're targeting either like an ARM architecture or x86 architecture, it's like okay, at this point the solution is different if I'm writing like intrinsics or something. So it's like here I'll have a pound define depending on what platform I'm on, and that's a real thing that needs to happen. I didn't make that up. It's something I kind of encountered while I was working. And so yeah, that helped a lot. And then in the parts where I did kind of, not follow that idea like close enough, I kind of regretted it, by putting any extra code in mixed in with like the renderer or stuff. It just made porting harder because I just had extra stuff in there that needed to be duplicated or pulled out later on. So yeah, that for sure like was the right call.
Oh my God, I'm curious once again. I'm trying to make explicit certain things that I think you're saying secretly. For your next project, it almost sounds like you're not going to be reusing the entirety of the existing, engine, not engine, of Animal Wow.
Yeah.
Whoa. Tell me more.
Yeah. So, the way I've been thinking about it, because I've been working on it for the past few months, and it's still very, very early. So don't assume I'll have a new game coming out soon or anything.
What's the title? Let's reveal it for the first time at Handmade Boston. I'm kidding. Go for it. Continue.
Yeah. But yeah, it feels like it's like when you move and you kind of use it as an opportunity to like pack up all your stuff and then maybe throw away a lot of things that maybe weren't that you don't that you don't need anymore, and you've been kind of putting off a lot of like reorganizations and stuff. So I'm viewing this as like I'm setting up a new clean project, but I'm harvesting a lot of code from Animal Well, and but like while I'm doing that, I'm kind of maybe sometimes just keeping it mostly exactly the same, but a lot of times it's kind of cleaning up the API, doing almost a postmortem for myself of like, did I use this the way I would originally intended to, or it's like, how did I end up actually using this API in the game over the years? And I have these like real world examples of like how it ended up working. And so I'm kind of able to sort of do like a version 2.0 or these like API breaking changes to things now as I set it up. So it's actually a pretty fun process. It's like I'm getting the satisfaction of like building an engine from scratch, but it's going a lot faster because I just have a bunch of pre-written code that I can kind of draw from, and I can kind of like piece it together
I'm
much quicker.
imagining you in a garden, that's the animal well garden, and you're just walking around and harvesting, like you said, picking up, oh, I like this plant for the new garden, and I like this little soil manure that I'm going to use it for the new garden, right? But other stuff just stays in place. It's like, okay, this was nice for this garden, but it's not going to be useful for the other one. That's can we discuss a little bit of the harvesting that you've done so far? Because I'm curious, I'm assuming you have some kind of, well, maybe not asset streaming, but you got to have a way to import the art assets and audio assets and anything that is like basically static binary data that's not code, and that needs to be imported in a project in a kind of like CPU friendly way, whatever that means. And like those things don't change too much across projects unless you're really making again, you don't have to reveal anything, because like if the game is like so alien to the current one, like we're talking 3D and like VR innovation, whatever it might be, right? Like maybe the asset streaming or asset import does have to change a bit, but otherwise, in general, like I would imagine you would want to harvest certain classical things, right? So, like I said, importing assets, maybe audio streaming, and I'm not sure what else. So, can you tell us a little bit of the things that you think are like, yeah, this is easy to harvest. It's just trivial to pick and pluck.
Yeah, so that is actually something that kind of got brought over and also kind of enhanced. So the way assets work in Animal Well, it was pretty important when I was during development that I would be able to iterate on the assets. So in a debug build, they're all like in an asset folder, and I actually have two. I have like just an asset folder, and then I have a generated assets folder that's sort of platform and build configuration specific, and so. Some things go there, like compiled shaders or converted audio formats. Like I'll keep all my audio in wave files. That's kind of like the source of truth. And then as part of a build step, those wave files will get encoded into org Vorbis files. Or if there was a better file format, depending on the platform that was maybe more natively supported, in theory, they could be encoded into a different format. And so those go in like this generated sort of assets folder. And then I have sort of a system that sort of monitors for file modifications. And it will like reload any of those assets in those folders like at runtime. And then there's like kind of a sort of a callback area in the game that will know how to, depending on the file type, know how to like reload. Whether it's a shader or a texture or an audio file or a font. And then so I can edit all those assets like while the game is running, and they'll get refreshed sort of live. So getting that working was like very important to development. And then in the release builds, all those assets are statically sort of compiled to just C byte arrays that are then just like compiled into the game. So there's no loading. I wanted to eliminate any like failure cases with the file system or error checking that I needed to do. So I'm like 100% certain that when the game is running, every asset is just immediately accessible and is likely in a format that it can just be used like directly. So yeah, I was very happy with how that turned out. And that was sort of a system that kind of went through a few iterations during Animal Well's development, but within the first few years kind of took that shape. And but now there was a few things that weren't amazing. Like it wasn't easy to add new assets, for example, like while the game was running, because it was doing some code generation where it would like create an enum of all the assets with like integer IDs. So none of them were like referenced by string or anything. And sometimes like it was hard to like add to that without sort of screwing things up. So if I wanted to create a new asset, sometimes I would need to shut the game down, put it in there, and then like reload it. But so I've kind of improved things with the new project to I can add things more seamlessly. But but yeah, and then there's like a general entity system that I have.
Oh, wow.
That also kind of it ended up being a little weirder than I've seen in other games. There's really no shared data between them, not even like a position or flags or anything.
Interesting.
But and they were all, at first I was just kind of doing it the dumbest way possible, where let's say there was like an entity type would be like fern. There was like a little fern bush, and I'd have like an array of ferns, and I'd count like how many ferns there were on each screen, and then
Just straight up, I love it.
just straight up. And then when I would like load the screen, I would just iterate over all the tiles, from top to bottom, and I would check like, is this tile a fern tile? Like based on like every tile had like an integer ID as well, and if it were, then like add a fern struct to this array. And it was just like the dumbest way I thought to be able to do it. That also maybe still seemed like, okay, all the ferns are together, so maybe there's going to be some good like cache coherency here. There's no dynamic memory allocation. We're dealing with all the fern stuff at the same time, so maybe like they're, utilizing the instruction cache better than if it were just like a big parent sibling like child object hierarchy, like scattered all throughout memory or something. So then in the beginning I was like, okay, anytime I make a new entity type, it involves creating a new array, like in some sort of global structure, or there's like a screen. Each screen was like sort of had some memory that was like defined by a struct, and then say there's like ghost or something, that's a new entity type, and if you find a ghost tile, add a ghost to the ghost array, and then in the update loop through all the ferns, update them, loop through all the ghosts, update them. In the draw loop through all the ferns, draw them, loop through all the
It's incredible.
ghosts, draw them. So I was like, I don't know, if this gets annoying, I'll deal with it when it comes, but this seems like how the code should be. Or this is like the problem. This is the work that needs to happen. So I ended up kind of figuring out some tricks where you can use the C preprocessor to sort of define a macro for, to substitute some code into somewhere. So I ended up creating a header file that had a list of all the entity types. And I had a macro that was like define entity. And then the solution was then add one line of code to this entity list, which was just a C header file. It would be like define entity, open parentheses, like fern, close parentheses. And then in the various spots in code where I needed to do something related to all of the entity types, I would redefine the like define entity macro to mean something different. So if I'm about to update them all, I'd be like, define entity macro now means update, like, pound sign this entity type, and then include that header file in that point, at that point in code, and then like undefine it. So it's like a trick I've seen other people use. And then when I want to draw, redefine it to mean draw, and then include the header file there as well, and then undefine it afterwards. So I had this one, I like solved the problem of not repeating myself, I guess, in code. But it was kind of like a poor man's like code generation, where it was just sort of inserting all the...
But it was a time-saving trick that yielded benefits, right? Because now you're more productive in iterating on the work. So
yeah, and it ended up working out, and I like look at it and I'm like, okay, this is pretty different than I've seen in any other game engine, but it like solves my problem perfectly. It's like efficient, like performance wise, and it's pretty easy to set up. And it just involves adding one new like source file for each entity type I want to create, and then there's some kind of a common interface. I put interface in quotes because it's not like a true like virtual pointer kind of interface, but just this sort of these set of functions that the linker is going to try to link to based on the macros.
Would you say there's how much meta programming was involved in the making of this game? So we just talked about this poor man's macro time saving trick. It's meta programming. Do we have other forms of meta programming that you felt compelled to use?
Not a ton. There's a little bit. I abused this like macro trick a lot, and I used it for shaders, and I used it for audio files. I kind of, and I think sprites maybe. And so there's a lot of macro kind of substitution stuff throughout the code. And, people get kind of scared of macros, or at least I remember when I was in college and they'd be like, we learned how to use them. And it's like, be careful with these. You should probably use a template instead, because that's like type safe, and it like will protect you. You can really, they'd have all these contrived examples how like, if you put this statement in the parentheses and then the code that like kind of gets generated like is subtly wrong. And but in practice, like once you get them set up, I had almost no bugs related to them at all. So I think
and there's not a lot of indirection overhead, let's say. Like I would imagine if a programmer comes in and looks at your code base and like sees your macro trick, they'll be like, oh yeah, that's pretty straightforward. Like I probably would have done the same thing. It's that kind of macro work, right? It's not it's not convoluted.
Right. It's doing kind of only what it needs to. I'm not trying to solve for overly generalized cases. I've seen some macro things, in the past that are like, it's like, okay, 7 levels deep of like nesting, and it's just like you have to be like a detective to trace back.
Yes. I look at those people. I'm like, you're the reason C programmers get such a bad rap. Like, what are you doing?
Yes. Or even like if you look at like the standard template library or even just some of the Windows libraries, and you're like, it's just macros upon macros of like type def.
I've seen those.
That you have to figure out what the actual type is of some of those things, that you got to trace like 7 type defs back to like.
No. Okay, before the PTSD comes in, let's discuss the. Okay, I'm glad that you also mentioned that in the harvesting of your animal well code garden. There might be some things you harvest as is or almost as is, and then there might be others that you're like, okay, I like this, but it's gonna have to change a little bit. So you move it over and then you enhance it, like you said. So that's pretty interesting. How about memory management? That's an interesting question because
sure.
It's a hot topic in the past few years, in the systems programming community. Let's say everybody who uses a systems language like C++, C, Rust, Zig, Odin, etc. Nim, I suppose, and you have all of these languages, and Jai as well. So a big question, like there's like a rift. There's a rift in the community, let's say, and I'm not sure what the ratio is, but certainly there's a strong contingent saying like, memory safety is king, and so why aren't you making your games or applications or general software memory safe? And obviously we have to consider that systems languages are used for more applications than we know. Like it's just a lot, right? You have space exploration, you have video games, you have desktop apps, you have literal phone apps, everything, right? So we have to be careful not to be too generic about the value of memory safety and what you mean by that. So I don't want to get too generic. So let's narrow it down to just games, and specifically indie games for one person. What are your thoughts on the idea of memory safety? Because you chose a language that some people would call, like you're going to have issues with memory management. So did you have issues with memory management? And and how did you, and whatever issues you might have had, how did you address them?
To be honest, no. I didn't really have issues with memory management, but it did fall into the category of things where it's like there's a lot of conflicting opinions about how important memory management is and like how you should deal with it and how you should prioritize it. So this was another thing I was like, I'm going to just see, I'm going to like if I another goal was just like I want to kind of validate all these assumptions people have, and if I end up like kind of shooting myself in the foot in the process, like that's fine.
So be it.
Because I'll learn, and I'll deeply
Love that.
intuitively learn the value of why people say you should do it this way, and then I'll be like, I understand now. But so yeah, I from the early on I wanted to like kind of minimize just dynamic memory allocation as much as possible, because I mean that's just, there's no argument that that's bad for performance, and you know, making like a kernel call to in malloc is slow, very slow compared to most things. So a lot of the code is just or a lot of the data is just defined in structs or nested structs, and I think I literally have just one like global state struct that's for the game, and then everything on screen is in another struct that's like the screen state, and it lives, or then maybe there's like the game state, which is everything during like one play session of the game, and that lives in the global struct, and then the screen state is all the things that are like active in memory when you're on one particular screen in the game, and that lives in the game state. And then there's all the entities that are each a struct, and they live in the screen state. So it's like this pretty clear, like, I don't know, nested hierarchy of memory. And well, I guess I do some like kind of clever things at certain points, but I'm never sort of asking the operating system for memory. I do allocate it all on startup, and there's just some hard-coded limit that I kind of figured out while I was developing the game of how much I needed. And then I just get that big block of memory, I think I just called malloc once, and then the sort of engine executable holds on to that memory. And then when I ask the game to like update itself or draw itself, I sort of give it a pointer to its big memory block, and then it's sort of and that happens every frame, and then it sort of just holds on to it. And then if the DLL reloads, the memory is still like intact, and then the new DLL is just kind of just give it back its pointer to its memory. So that was a cool trick. And being able to just in general hot reload the code is, I think, the single most important feature you could ever write for yourself if you're making a project in this way, because it just alleviates the need to make so many tools and little editors for yourself. Because if you could just, you have like the text editor, and if you could just like reliably change values like while the game is running, that it's just like, so that one thing is so powerful, and it just like just removes the need to make so many other things you would potentially need. But that's just an aside. I highly recommend that you prioritize that, because that paid back more than like I think anything I did.
Arenas? Any arenas?
Yes. So, and I'm actually trying to do more sort of arena allocation in this new project, just because I found, so on one hand, statically allocating everything is good when you know how many you'll need. In a lot of cases, I would just have a fixed size array where, say there's like particle effects. I'd be like, okay, at most there can be, I don't know, 32 particle effects at once going on. And if it like, if I need more than that, it's like a ring buffer. It'll just start like stomping over itself. And that's fine. But also by needing to like globally sort of define the entire layout of the game in memory, it does cause a few complications with like header dependencies, because for a thing to like have something nested into it, it needs to know the declaration of it. So like you need to kind of include the header. If the global state needs to know about the game state, which is inside of it, it needs to like have the definition of the game state. And maybe that's what you still want, but
I agree.
But by having like arena allocators, like you can just, and having those defined for the various sort of points, like sort of life cycles in the game. Like say you have like one arena for just like, this is when the game starts up, and if something just needs to be sort of statically allocated and just exists once, you can have an arena for that. Here's an arena for just like the life cycle of one game session. So it'll get cleared if you go back to the main menu. And so when the game starts, it can allocate from that. If you have a screen in the game that you walk onto, you can have an arena just for that. And then anytime you switch screens, it gets cleared. And then you can have one like per frame. So every frame, it just gets cleared. So I think it's like a really nice and kind of intuitive way to think about memory management. And when you ask yourself, like, what arena should this go in? The answer is pretty like obvious. So I'm trying to do more of that, because then you can then ask, you can make like a function where you pass it in an arena to like allocate something, and it'll just like push it onto it. And it doesn't, the calling code doesn't need to know the size of the thing that's going to get allocated. So it kind of helps, I think, decouple sort of a lot of the header dependencies that can slow files down.
I want to say it's interesting and noteworthy that you didn't have to go too deep into arenas for your first game. And
yes,
you're only now seeing it more useful as you want to decouple things, because you're going to have multiple maybe projects going in, and maybe again, I love that verb, harvesting, becomes just more straightforward with arenas, because then your function signatures take in the arena, but they don't have to take in kind of like hard-coded, well-known sizes, part of some global state on one particular game, right?
Yeah, exactly. But I think so. Yeah, it wasn't super necessary. I did have like, you know, some maybe more header dependency than I would have maybe liked, but I still, because I was only writing the code I needed to, and I was programming in a very like, you know, plain old data style, struct C style, the compile times were still pretty fast, and I could reload the DLL, like recompile it within, I think, like 2 seconds or something. So it's still like a pretty good workflow. So it never got to the crazy point where you can have like I remember trying to recompile, just do an incremental rebuild for like Unreal Engine 4 was like, I don't even know how long. It was just like you spin around in your chair, like and like look at the ceiling, like while it happens. It's definitely long enough to like totally break your train of thought.
Billy, your approach to you dynamically initialize the memory you want once at init time, and that's it. By the way, this is a NASA approved approach. So
good. Yes.
For those in the audience who have never heard of me, you know, I started my career in a very lucky way with working for Kennedy Space Center. That's at Florida. That's NASA. And oh my God, like there are rules for programming, because they use C a lot for sure, vanilla C. And it's like, yeah, only malloc once. Like, that's it, no more at init time. And other strict rules that you may or may not have to follow for a video game, obviously. But it's like, yeah, no more than one pointer per function signature. And that just solves pointer aliasing in many straightforward ways. You don't need to have, we don't want recursion either, so you cannot do recursion, and some other interesting things. So as you were talking to me about your memory management strategy, I'm like, this is NASA. This is cool. And about the memory safety thing, you might also find this interesting. Like, at least my coworkers at Kennedy Space Center, my team back there, I'm not there anymore, obviously, but like they tell me they don't adopt Rust for their satellite tracking software, for their rocket launch control software for the rockets. Like it's not Rust. And it's like, hey, wouldn't you want Rust to be there because it's memory safe? And I'm like, Rust is not memory safe for our purposes. And it's like, wait, what? and that's the danger of blunt memes, right? That everybody just like says, this is the slogan, memory safety, Rust, right? And like, it just throws away context. You know, for Kennedy, it's like, well, hold on. Like, we care about the code gen. What is, and how trivially can we review the code gen? So you compile something and you have generated code, and like that needs to be small, trivial, straightforward, and it's gonna live on some satellite sensor tracking software for decades in space. And so we want a compiler that is tiny. We want a compiler that we understand, and we do not understand the Rust compiler, and we cannot prove we cannot prove that the code gen is going to be safe and straightforward for us. And we have like 5 levels of testing per project. Like when I added 2 lines of code, Billy, to my NASA, when I was allowed to write code for NASA, that was amazing. I was still an intern at the beginning. I wrote 2 lines of code, and that went through 5 levels of verification with like level 1, my peers, level 2, my manager, level 3, the department director, and then like a QA department, et cetera, and then the final chief signs off on it. It's like when you are in this environment, like Rust and memories, like all of that's kind of like doesn't make that much sense. Like the memory safety meme there. So I thought you'd find that interesting. I'm not sure. I hope that was it.
Yeah, no, that's super interesting, because you would think like, oh, they would care about it the most, but
is there even a spec for the Rust Rust language? So I don't think there's even a language spec. I think it's just a compiler. So it's just anyway. It's interesting. Like when people tell me use Rust to be memory safe at NASA. Like we know, like literal NASA engineers don't agree with you. So how about we avoid those dead slogans and memes, right? It's my opinion.
Now
hot take.
It just like memory management just wasn't that big of a deal. I was able to kind of reason about it pretty reliably, like as the project got bigger and bigger and bigger. So I think it's overstated, at least in terms of games.
It's not like it doesn't have its place, right? It's just I definitely have a visceral reaction to blunt memes that like spread on like fire on Twitter. Like Rust and memory safety. It's just like, please, like you need to be more grounded in reality. Exploit your context. That's a lot of handmade stuff. It's like know your context. You just have been talking about for the past hour about how very specific you were with your problem solving. Just like solving the situation at hand, knowing your context, knowing your environment. Like that's amazing. And like generic branding memes to like silver bullet, like that doesn't help. It just I don't think we're programmers here. Like, we're engineers, hopefully.
And I think only accepting complexity when it solves like a very specific problem, I think it's really important, because overall the problem I've faced with, projects in the past, and I've seen other things, that the thing that prevents you from shipping or finishing a project is like the slow accumulation of complexity or things you don't understand. So like, I'm very reluctant to like add anything to the code that I don't like understand pretty deeply, because then like it's like a crack in the foundation, because once you put it in there, and then it is now going to be in the back of your head as like a potential failure case for the rest of the project, and that could be years and years and years. So, and those things they don't go away. And so you're always going to be wondering like, oh, maybe if I'm I don't understand how the memory is allocated, like maybe it's like out of memory, or I don't know, or maybe there's like a circular reference, or I'm just like giving a very abstract example, but it's like, if you don't really understand how it works, like it can be doing, you just don't know all the ways it could fail, and you're going to be like really like sort of superstitious about like what might be happening. And so, I think another like benefit that, people are often intimidated by like not using these off-the-shelf libraries and engines, but it's kept development like pretty predictable. And even, after almost 7 years going up to launch, I still, if I needed to make a dramatic change, it was like, it was a predictable amount of work, because I knew how everything worked in the code base, and I knew what needed to change. It might be like still like a good amount of work, but it wasn't, it was like predictable. It wasn't like, oh, this might take 1 day, or it might be literally impossible because the SDK doesn't support it, and we would need to put in a pull request to get like it fixed or something, and they might not ever do it. And because I've been at studios where we were like, requesting features from Unity, or there's a bug in Unity, and you'd open a support ticket and be like, can you fix this issue? And then 9 months could go by, and then one engineer that maybe implemented that feature would be like, okay, it's on the roadmap, we'll let you know. And then until then, you're literally just screwed. Like, the problem is like unsolvable because of like the tech stack you've chosen to use. I could have written like, 20 renderers in that time from scratch. Like, and it would have been like horrible, but that's at least like predictable work.
And yes, and before members of my audience who love Rust leave the chat and ask for a refund for the tickets, I do like the Rust. I do like what they're doing. They're solving a class of bugs. They really are. Right? It's just there is a portion that we already know is an infamous portion. I even think like I joke around that years ago before Rust really took off, I had fights over things like Vim versus Emacs, and interpreted languages like Python versus C, and like just like these classical flame religious wars around editors, languages, and things like that. And I feel like that's almost dropped down to zero. I don't have those interactions anymore. It's like all the zealots in the programming industry have moved over under the Rust umbrella, and now it feels a little bit like that. So no hate, overall, and like I used software written by Rust, RIP grep. I love it. It's like way better than grep, and et cetera, right? So anyway, Billy.
Yeah, I'll also just make it clear, I have not used Rust at all, so don't. I have no strong feelings about it. I write my code in C++, mostly just because it's there and I have experience with it, and it's also just kind of part of my philosophy for this project to like not do any work unless it's like absolutely necessary. So it's made sense for me to just like use the language I'm comfortable with, and if I ran into a complete like roadblock or like is really the language has not really gotten in the way of on my day-to-day programming tasks and problems. It's not like super joyful to use, but it's not that bad to use. It's definitely not like the bottleneck. The bottleneck is like coming up with creative ideas, and mostly it's been design and art. Bottleneck, the engineering's been like pretty predictable.
That's a good way of putting it. I love that. Billy, let's switch gears to you didn't just write the tech stack. You also did game design. You also created art. You also even like voiced things. Like there are things beyond the programming that it sounds. You worked with a publisher to get your game off the ground and into the mainstream. You have there's a skill set here beyond just programming to be able to ship Animal well. And I am so curious about this, intrigued even, because the Handmade community is full of talented low-level programmers who always, if you go to their Discords, like they have a showcase channel showing, hey, look at what I did, and like, look at that. And it's like, you're like, whoa, like you're really, the Handmade ethos is powerful. You can really, as an indie person, write software that can really eat the lunch of, corporate software. It really can. Yeah. Because like you said, you're diving deep into how things work. You're not afraid of opening up your black boxes. You're not just stitching together magic functions and not understanding what's going on. No, you have like a complete understanding. More and more, you're curious about how things work, so you can innovate a lot more. That's awesome. But we have a never ship-itis problem. Never ship-itis. Like, it's hard for us to ship. It really is. One of the reasons I brought you to the conference today, and I'm grateful that you're here, is talk to us a little bit about, tell me about Animal well beyond just the programming, whatever you feel comfortable sharing with us, the skills that you needed to maybe develop to get it out the door. And maybe there were things that you're not comfortable doing that you had to do, like many programmers in the community, we're not necessarily particularly social people. I'm a bit of an exception. I'm a social butterfly. But most programmers, and I understand, just don't want to do a lot of people stuff, right? But I would imagine that you also have to do people stuff, and I just don't know. Tell me, tell me how you got Animal well shipped, because that's quite an accomplishment.
Yeah, so I think I'm like a kind of a programmer first and foremost, but that being said, I discovered programming pretty late in life. Like, I didn't have anyone in my life that was also a programmer growing up. I had, computers as a kid, but I just used them like from a very sort of basic consumer kind of level, and didn't just was interested in them, and they were kind of like, very, again, magical to me, but I didn't really know how they worked. So early on, I was very much into like just drawing in school, and in high school, I got into like filmmaking. And I was interested in like how video worked and stuff. There's a lot of like overlap between computing and sort of video production, and they're both like pretty, there's a lot of technology involved either way. And yeah, and I first got into, I guess, deeper into computers when I did start building gaming PCs in high school. Because I wanted to play Half-Life 2. It all started because I played the original Half-Life when it came out. I was in like 5th grade, I think. And it happened to run okay on my parents' like beige, junky, like PC they had at the time. Coincidentally, it worked. So I was a fan of that game, but then wasn't ever really into PC games that much. But then Half-Life 2 came out. What is this, 2014 or whatever? And I was like, okay, I should play this. I don't know anything really about PC games, but I want to play this. So I bought it, and I tried to install it on my like family's computer at the time, and it ran at like 5 frames a second. It was just like, so that I think opened the whole like can of worms, where I was like, why doesn't this work? Or like, what is wrong about our computer that is preventing this? And then at that time I realized like, okay, you can get a graphics card, and let's get one of these, and I'll try to fix, got like a basic like Radeon graphics card from Best Buy for like $200, and like getting that is like, okay, and the game like ran all right. It ran at like 30 frames a second or something. It was like playable, but it was still like pretty stuttery, and I don't think I could pick like the highest graphics options, or maybe the highest texture resolution. Then I was like, oh, kind of had to learn what RAM was, and then if like the computer we had could like, if it was even upgradable. And so I was like very rapidly kind of learning how a PC is put together. And then I eventually got like a better graphics card after that, and realized like, oh, the power supply is probably not big enough to support the draw of this. I like upgraded to a GTX or 7800 GT, I think it was at the time, which was pretty good. That was like when I was like more further along. But it was like for a few years, I was like, Half-Life 2 was this like benchmark I had of like, how well can I run this game? And I kept like doing all these incremental upgrades to the PC, and then eventually just like decided I would just like build my own. I like learned enough at the time, went and bought all the parts, and that was like a whole journey. This was probably when I was like 16 years old. Just got really into like PC games, and sort of fine tuning, being like a Windows power user, in like kind of a superficial sense, where I was like installing like mods for games, or doing like registry tweaks to like try to improve performance, or uninstalling like bloatware on people's computers. So I remember feeling like, oh, I know a lot about computers, but I couldn't even tell you, I couldn't even name like more than 1 or 2 programming languages. I had 0 programming ability at all. And so I had this kind of superficial consumer like point of view of how computers worked. And that was the case until I think like later in college, when I sort of had some friends that were programming, and I was kind of like, I kind of had it as part of my identity that I was like, a computer like power user, and I knew how things work. But then there was like kind of a wake up call that it's like, okay, I don't actually know how software is made at all, and I'm actually kind of embarrassed. And then so I started to program, and yeah, just eventually kind of, I started with processing. That was the first programming language I learned, which was like geared towards artists, and then kind of just coincidentally learned C++ pretty early on. And then it was like when you don't really know what you don't know, you just take you cast a really wide net. So I remember I got like a book on Linux. I got a book on SQL. I had a book on JavaScript and C++. And I was like trying to just like learn all that simultaneously. And I don't know, it's kind of funny looking back of like, I don't use most of that knowledge like hardly at all, aside from C++ yes. and maybe a little bit of Linux in certain situations. But I just didn't know what I wanted to be.
Yeah.
So yeah, but it was at that point where I was finally, I don't know, throughout my life, I was just slowly developing all these like a scattershot of skills. And I didn't really know what I wanted to do. I was like in film school at the time for college, and I don't know, just like wasn't super excited about it. I was in the beginning, but slowly kind of felt a little disenfranchised. Just wasn't, I feel like my heart wasn't in it. But then it took a while until I sort of stumbled into the idea that you could program a video game while I was just like learning to program. Throughout this whole like journey, as like video games were kind of always a part of my life. I was exploring all these different hobbies. But since I was like 3 years old, I've been playing like, NES games, and they were just like a constant through line. All this like sort of meandering I was doing. So yeah, I guess all of that is to say that I guess going into Animal Well's development, I had the programming ability because that's like what I ended up doing after graduating, and had multiple jobs developing that skill. But in the back of my head, I did still have some like art skills that were like maybe a little rusty. And also I've dabbled around with music since I was a kid as well, on like kind of crappy like Casio keyboards and stuff, and like took a little bit of piano lessons. It's very basic, but it's something I'm like had a passing familiarity with. But yeah, so the point is like for all these. So you asked about what skills are necessary other than engineering to like ship a game. And I feel like I kind of got sidetracked, but that's
no. It's good to know your background. Yeah, go ahead.
Yeah, it's like a lot of things, and even what I described is not even everything, because people, I think the classic breakdown is like, oh, you need the programmer, the artist, the designer, and the composer or something, and they're like the four like roles that are used to finish a game. But even that's like half of the skills you truly need, because getting something published, getting something like localized, learning how to like play test things, like reading through documentation and talking to the platforms, and learning how to market a game, and going to shows and talking to people, and learning how to interview, give interviews. Like these are all additional skills that I would say are necessary to like ship and market.
Was it overwhelming for you at first?
Yeah, so for a long time, I would say the first 4 years, I was just kind of working by myself, and I kept the scope of the game really low with in terms of art and music, because I was like a little less confident in those, but those skills were sort of naturally built during development. But yeah, it was just like I was doing the like lone wolf sort of programmer thing, where I was just working on it alone and not involving other people. And that was like kind of low stress for me, because I think as soon as I have to involve another person into like the creative process, then I start worrying about like, okay, well, how do I give them feedback if they do something I don't like? I don't want to like hurt their feelings. I don't want to what if I need to ask them for help, or I'm dependent on them, then I'm gonna have to wait, and then how do I reach out with them? And then it just adds all this sort of social complexity. And if you really care about something, and you get really invested in it, like how I kind of was at Animal World, it's like that becomes harder. Like if you're on a team, and it's like at the other studios I worked with a lot of other programmers, but like you kind of have to, I guess, lower your emotional investment a little bit, just so to allow wiggle room for collaboration. So you got to kind of like be less tied to like one particular vision, and you have to trust that other people will do their job.
So you couldn't treat it like you were like this. I'm being overprotective with my baby. Like this game is my baby. I'm being overprotective. You're saying you can't be overprotective. You have to open up to collaboration. You can't be a lone wolf kind of situation.
Yeah, kind of. So in the past, I kind of like knew that like you have to be open to collaboration, and you have to be like polite with people, and you have to like act in such a way where other people like maintain their motivation, and they don't like think you're a total asshole and want to quit the project. But Animal Well kind of was in a spot where it like was my baby, because I was just no one else really knew about it, and all the design decisions were kind of just iterated on internally in my head and never vocalized. And in a way, it was like kind of intended to be that project where it was just like, this is my escape from everything else, where I can just do things exactly how I want.
That's fair
to do them. But yeah, so even still, there was a lot of skills I didn't like have to finish the project. Like I had almost no clue on like how to market the game, because you invest all this time in it, and ultimately you want people to play it, and you want it to be known about in the world. And so about 4 years in, I reached out to my business partner, Dan Edelman, who's a very important character in the game's sort of story. And he was kind of a little bit famous for helping start the indie games business at both Xbox and Nintendo. So he's like very in tune with like indie games, and worked with the developers of like Shovel Knight and World of Goo, and kind of all these sort of seminal games. And then he went independent after about 9 or 10 years of being at Nintendo, and decided to sort of just be a hired gun for indie developers that were like small, either one person or small teams. And he worked on Axiom Verge, if anyone's heard of that. That's made by a solo developer named Tom Happ. So Dan worked with him to help Tom do all the external facing work, just so he could focus on the development, and then just have someone else that would be like their public champion, and apply for showcases, and talk to platforms, and schedule meetings, and just send all the emails that like are not fun to send. So
it sounds like the part where you might want somebody to be your public champion and to do the kind of work that's necessary to ship a game that you may not be that into. It could be like you said, sending dozens of emails to different kinds of business people, or having a strong presence online in ways that you're not comfortable, like putting yourself out there. So like you had you wanted a public champion, so you did your best to find one, and you found one in your business partner. Is that correct?
Yeah, because other than that, my marketing plan was like trying to post on Twitter like once every 2 months or something, and I'm just not a very like online social person, so it was always kind of stressful to do that and try to make a GIF for the game and show it off, and then I'd be like very anxious about like, are people liking the thing I posted? And oftentimes, like in the early days, something would get like 4 likes or something, and then it would actually like hurt my motivation rather than help it. because I just didn't have a big following. And to be honest, the early days of Animal Well it was looking much more primitive. It was a less interesting project because that just sort of, it became that slowly over time. So I reached out to Dan, and luckily enough, he liked the game enough to, maybe want to work on it with me. And he saw the potential in it. Like, the game didn't look as good back then, but the controls at least felt good. And I knew he liked pixel art Metroidvania games because he had worked with other developers making those kind of games. So I picked him because he had the skill set that I wanted, and I thought he kind of had a soft spot for the genre or the style of game I was making. So he'd be able to better extrapolate where the project was going. He could see it in an earlier state than other people and see the potential in it. So that was, I think, my reasoning for reaching out to him. But once that happened, that sort of helped me kind of bootstrap the whole kind of marketing process by getting help in this, the business and marketing sort of side of things. I just wouldn't have to worry about it as much in the future. Or at least that was my thought. I would be like, okay, I have to be brave and reach out to this one person and send this kind of email that may get ignored. And it's just not fun. I don't want to do it. But if I can convince them to work with me, then they'll do all that in the future, and I can go back to my corner and just
That's interesting.
program.
That's interesting because you did say you are a programmer at heart, and you're working on your baby, you're working on your project, and you're like, but it sounds like you do acknowledge, because help me here. I think it's true. I think that programmers, and I understand, they have, especially in our community, typically an aversion to the world of business and an aversion to the world of just the social dimension of things. Because it's there's plenty of what do you call it, snake oil people, and there's deceivers, and there's corruption, and there's just awful things over there, and you don't want to touch it. And my counter argument, because I am social, is that hey, in the tech side, we have snake oil people too. I mean, we have clean code principles, and we have Uncle Bob. Sorry, Uncle Bob. I'm indie, and I'm calling you out. I don't think your clean code principles were a net positive for the tech industry. So we have in the programming side, right, that the same kind of people or behaviors that we don't agree with. So I'm just trying to say that the shit is spread everywhere. And
yeah. No, for sure. And I think ultimately, so my plan was to let Dan do all this work, but what ended up happening was I learned a lot from him in terms of the business and marketing side, and actually found it more interesting than I would have guessed. Kind of just seeing the process of how the platforms work with indie developers, and how they get pitches, and how do you book a booth space at PAX, and there's just lots of logistics. Who do you reach out to get a game localized?
It's genuine work. It's hard work often.
Yeah, it's a lot of work, and I kind of gained an appreciation for it. And I would say, in terms of sort of this handmade ethos, if you want to make everything yourself, or understand the process top to bottom, a lot of those parts aren't programming, and a lot of them are more on sort of the business end of things, and all that stuff is interesting and complicated, and sort of analyzing the market that you're going to go into, learning how many wish lists you should expect a game to have, and how that correlates to sales, and how can you sort of project the finances. And it's a lot of interesting things are what shows are worth applying to in terms of marketing value, and what wish lists you can expect, and which ones aren't, and what's the yearly schedule for all these things. And you end up meeting a lot of cool people that are going to the shows on an annual basis, and it's just it's a whole
Yeah.
this whole thing, and it's actually pretty fun.
A good friend of the community, Dr. Dimitris Panos, gives a good analogy about the business world. It's very much like playing poker often, because you may not know exactly if you're going to hit the market with like, Animal Well is going to do super well. Like nobody can truly, accurately, 100% guarantee your success. But you can play poker a little bit. You're like, like I'm reading, like you said, I'm doing some market analysis. I'm looking at the shows that are available, things that we can apply to. I'm looking at social media. I'm looking at the trends, the zeitgeist, the timing, and like, you can have a nose for it and sort of like place your bets. And some bets, if you can become competent in business, some bets are better than others. And it sounds like your business partner was able to make better bets than most other people, and like that's helpful, and it's a skill. Right. Yeah.
Yeah. No, it's there's a really like a lot of strategy to it, and it's not there's just a lot of people out there like saying the marketing a game is kind of just like blind luck and it's all randomness, and you can be
There's
just
some
kind of
randomness.
nihilistic
Only
about
some
it.
though, right?
Yes.
Yeah.
Yes, there is some randomness, but like I think your poker analogy is pretty good. It's like you don't know which event you're going to go to that's going to like make a big difference, because there's so much randomness involved, but you can kind of increase the odds by just like doing a lot of different things. You just have to assume like anything I do might have a 10% chance of being very meaningful and like opening up a big opportunity. And that's like, those are maybe pretty bad odds, but you can just keep trying a lot of different things and just sort of see what sticks. And overall, like, comfortable probability that like some good things will happen, and then a big part of that is making a good game, and then the other part is like just really putting a lot of work into like showing that game to people and being receptive to feedback, and being honest about like where the flaws are and what work needs to be done, and what your competition is, and knowing what people are going to expect, and then making sure you're like providing an experience that's worth their time and is like worth their money, and can honestly like compete with what other things they would want to do with their time.
If I could give a summary, by the way, when you gave us your background on how you got to where you are, I really do appreciate it, because it sounds like you are kind of like the typical everyday man, jack of all trades kind of person, and then that demystifies you a little bit, right? Because you have the community really admiring you for what you've done, and then we might create a legend around you where we feel we can't ever achieve what you've achieved. And so with you giving us your background, it sounds like, okay, he's human, right? He's human, and I can do the same. And it also sounds like, again, I'm trying to summarize what you said, because I really want this advice to be helpful for other handmade people. You would recommend make the good game first, make your project, make your product. That's obviously. 2 minutes. 2 minutes and we'll begin our afternoon presentations. One minute. I got a few DMs being like, Abner, wait for me. I'm like, dude, you can't do that. That's not how it works. Aha. Let's go. Let's do this. I'm excited. Okay, welcome to Handmade Seattle. There's a lot of people watching online once again because our next presenter, demoer, is none other than Freya Holmér. Freya goes by many titles. Shader Sorceress, Math Goddess. What else is it, Freya? You're in the chat. Say hello, Freya. Say hello so everybody knows how to find you on the private chat server. And yeah, Freya was one of our first speakers when we expanded to Handmade Boston last year. So Handmade Seattle is our most popular conference, but we expanded to Handmade Boston, and she was gracious enough we flew her in, and she gave a great masterclass involving math, which was amazing. And ever since then, Freya and I have been talking some more, and she's been interested in the handmade community and more involved in interesting ways. And she even participated in the Wheel Reinvention Jam that the Handmade Network staff does. And she worked on this demo called Half Edge, this actual project called Half Edge. And I don't want to spoil it too much. That's the point of the demo. So this demo is actually a bit of an interview. Like, I pre-recorded an interview with her, and we talk about Half Edge and why it came to be. And just so you know, Freya is an independent developer, popular YouTuber, indie, and creates her own plugins for Unity, her own tools for game developers. And it's interesting because that feels really high level. I just mentioned Unity, didn't I? That just feels really high level. Like, why would you belong at Handmade if what you think of Handmade is much lower level than Unity? And we start to discuss that too, like how Handmade comes into play for an indie game dev like Freya, who is building things usually using the Unity engine and what's going on there. So without further ado, let's play this conversation with Freya Holmér and enjoy. Give us a summary of the reason Half Edge came to be and what it is.
I think it all started on the one fateful day where I left the company that I was working at, Neatcorp. And when I did that, I no longer had a Maya license for Autodesk Maya, which is one of the bigger 3D modeling packages out there. And those licenses are extremely expensive, and I couldn't afford to license that on my own as an indie. And so I just went full in on doing code instead. And then I started to miss doing 3D modeling, and I was like, oh, okay, fine, I learned Blender. I'll do the thing that you have to do. I feel like it's the game developer New Year's resolution to learn Blender. I feel like everybody puts it there. So I was like, okay, I'm gonna give Blender a shot. It seems really good. Everybody's starting to use it. Yeah, it seems to it's getting more and more adopted, which I think is cool. Then I started using it, and it's very different from Maya. It's like an entirely different paradigm. If you're a programmer who's used to coding in, I don't know, in Visual Studio or Writer or whatever, I would say that Blender is the Vim of 3D modeling. Basically, it's incredibly hotkey based, and it is obtuse, but once you learn it, it's pretty good. That's when you can get really efficient with it, but it is pretty complicated to get into. And the more I got into Blender, I honestly haven't used it that much. I've only used it for maybe a total of 4 days. So don't take all of this with too much weight. But even during that time, and I have a lot of experience as a 3D artist, when I started using Blender, there's so many things where I feel like everything is getting in the way of me doing the thing that I want to do. Blender is a huge application. It can do so many things, which is really cool, but it's also overwhelming when you just want to do a specific thing. If you want to do polygonal 3D art for game development, that is a tiny subsection of Blender. That is not what Blender is about. Blender is about a ton of different things like video editing and node-based geometry and node-based shaders and so many different things. And then I think that there were 2 more things that kind of made me go for making half-edge. One of them is that I was exposed to more than 13 minutes of Blender's UV editor. Those are like lethal doses for anyone who likes UV mapping and like 3D modeling in general, I feel like, and for Maya users. I think it's bizarre to me as a tool developer that there's so many like low-hanging fruit to immediately improve the UV editor of Blender, but you have to get plugins for that because the built-in one just doesn't care about all of those tools. And the weird thing is that, you know, from my perspective, again, as a tool developer, like I know a lot of these things where I know how to implement these things. Many of the features, they're even just basic things. Maybe I want to select a bunch of vertices and I want to line them up to the left. Pick the leftmost vertex and line them up. Just projection in a specific direction. That's like trivial to implement. But if you don't have that, it's like, ugh, okay, now I need to find a plugin, or maybe I need to learn how to do, I don't know what it is in Blender. Is it Python? I need to learn how to do that. It's just this whole process. And yeah, it's like just so much friction. And that bothers me as a tool developer because at every corner, I just get this itch to fix everything. I'm just like, oh, this could be so much better. There's so many unnecessary steps along the way just to get to a specific result. And I think there's many reasons for that. And I wouldn't say that like, Blender has the wrong approach or that it's like, objectively bad in some way. I think it's just that Blender has a different target audience. Whereas for half-edge, I want to make it for game development. Like, I do not care about cinema or like movies or anything like that. I don't even care about like non-real-time rendering. When you want to render a pretty scene, you can do that in Blender, but like, all of these like offline rendering stuff, I don't need any of that. I just want something that is lightweight and fast and quick to just make something for game development. And that basically means UV mapping has to be good. Like that's something that we care about as game developers. You want to have a lot of control over lots of like very minute properties, like the normal direction of a vertex. That's something that matters a lot if you're doing a 3D model of like, vegetation, for example, or hair, or anything that has a lot of different sheets and planes and you want them to be shaded smoothly. Then quite often you want something that you want to have that kind of control over normals. But in Blender, that can get complicated where maybe if you try to get it to work with some weird projection mapping, that's even complicated in Maya as well. Whereas maybe all you want to do is say, select a bunch of vertices, and I want all of these normals to point away from a specific point. That alone would give you pretty good normals for a bush mesh or something. But that is weirdly complicated. And what I want to do is I want to laser focus on game development. And I often compare Half-Edge to Procreate. I don't know if you've used Procreate. It's an iPad drawing app. And I think if you compare Procreate to something like Photoshop, Photoshop has a gazillion features. Like, it has so many features. It's been around for so long, right? Photoshop is good for photo editing and like drawing, like illustration, and all that kinds of stuff. But then if you go to Procreate, Procreate has way fewer features. On paper, Procreate looks worse. It's just not super good. It's missing a bunch of things, right? But Procreate feels amazing to use. I like using Procreate. It's just nice to draw in Procreate. It gives you this entirely different way of approaching art. Software developers can get stuck in this mindset of just features are the only things that matter, right? I need to have as many features as possible, and the more features I have, the better my app is. It's so easy to forget about the user experience. I think that is so important, especially when it comes to making art. If you make art, you want to be in a mindset where you can focus on the art. You don't want to focus on all the buttons and all the technicalities and all of those things. You just want to be in the zone, right? And so if you have to Google for things all the time, if you have to like constantly interrupt your flow by like, trying to like search through menus, like you don't want all of that. You want to be able to just like focus on the art. And that's what I want to do. One more thing that pushed me over the edge was that I saw a lot of, it was Chris Bryant who on Twitter shared a bunch of animations of the modeling tools of Source 2, the source engine. Mm-hmm. And that gave me a lot of insight into how much Hammer has developed over time. And I was just like, oh, this is what I have wanted for so long. And so it started out as, okay, I just want those tools in Unity. Like basically similar tools, but in Unity. Although now Half-Edge is going to be standalone rather than a Unity plugin. It's still made in Unity, but it's not a Unity plugin, which is a little bit confusing.
This is great. So I'm curious about, so the integration with Unity at first was, you wanted to, like you said, optimize, make sure that the artist can be and the creator can be in the zone. Like this idea of massive packages coming from Blender or Maya. Is there any other popular thing out there? 3ds Max, is that dead?
Max, Maya, Max. Blender. I guess there's Cinema 4D.
Cinema 4D.
That's used.
Okay. And like you
Google
said,
SketchUp.
Google's, yes. All of those create, because they focus so much on so many features that you might not even need, but you think you might need down the line. And that's the priority of these developers of making these tools. Then they forget about how hard it is, that Byzantine workflow of like exporting and importing and like you said, layers and layers. It's just like a mess. And I think it sounds like you've made it your priority to avoid that mess in the first place for your workflow. And that's how you've made it happen in Unity, because you work in Unity every day. So I'm curious though, how you made it into a standalone now. Is that for the benefit of other people who are not in Unity be able to use Half-Edge? What's the story there? And how hard was it to make a standalone, to divorce it from Unity?
Yeah, so I mean, I feel like, I don't know how to say this without sounding like full of myself, but I think I'm better than being stuck in Unity's ecosystem. And I'm sure I'm still to some extent stuck there because I'm making it in Unity, obviously. I think my tool has potential to be useful to so many more people if it is outside of being locked into Unity's ecosystem. Like, I've had so many people message me and be like, oh shit, Half-Edge looks so cool, but I don't use Unity. And then you could like open Unity separately and then use my plugin in Unity just for 3D modeling, and then you can export from there. But it's this clunky workflow and it just feels shitty, and like you're treated as a second-class citizen in that case, and that sucks.
How annoying was it to divorce it from Unity and turn it into a standalone like that?
So I started out trying to maintain both at the same time. I was like, okay, I'm going to try to make it so that when I'm in Unity, I have like a separate assembly for the plugin version that works in the scene view in Unity. And then I have another assembly for the standalone version. And then I have another assembly for things that are shared between both of them. But in the end, I started just deciding that I'm not going to make a Unity plugin variant. So right now, I'm just ignoring that side. Maybe I'll try again to do that split, but ended up adding a ton of glue layers between the different interfaces, and that was annoying. And I feel like in the end, one of the things I have to be super careful with as a solo developer is scope. You have to pick your battles. I'm going to take this risk, I think, to make it standalone. But then there's another thing that was a little bit unexpected and interesting to dig into was if you're making a game in Unity and you have, what settings do you have for full screen in Unity? You can make it either full screen, or you can make it borderless full screen, or you can make it windowed, right?
Yes, yes.
That's the three settings you have in Unity. But in my case, for Half Edge, I wanted to have a dark interface in Half Edge, but in Windows, the title bar is going to be like super bright and white, depending on your theme and whatnot. But anyway, many people have like a bright color theme there, and I didn't want that because it looks ugly. Many apps don't have a custom colored title bar or even a custom title bar at all, but I didn't like the way it looked. It looks really nice in apps like Discord. It has a custom title bar. That's not the OS native one. So a lot of people here can probably look at that one right now and see that it's not the OS native one. Same thing in Obsidian or Photoshop. Chrome is a really good example. If you have Chrome, then you'll see that Chrome has an entirely custom title bar as well. The tabs are in the title bar. But Unity is not made for making applications like at all. It's made for games. And for games, you don't usually care about the title bar. Most people don't play windowed. So you'll just either do windowed full screen or full screen, right? But for Half Edge, it has to be windowed because it's a productivity thing where you want to be able to tab between applications and whatnot. Yeah, that was an interesting journey into the Win32 API, which was weird. Like trying to hook into, like, I've never done that before. It's like DLL hooks into user32. And yeah, that was rough. Like trying to translate all of the, I had to navigate the super archaic API of Windows just to get the custom title bar. And also to get the Windows 11 has these rounded corners. And there's this whack-a-mole where if you enable a certain behavior of a window in Windows, it'll sometimes disable a few other things. And it's super unpredictable, like which thing enables what and which thing disables another thing. And it's just chaos. Yeah, it was a mess. I also learned a lot. If I have a custom title bar, there's got to be some way for Windows to know what part of your application is what. Like if you click and drag somewhere, it probably wants to know if you're clicking the title bar. And so there's this event loop. There's a loop that you can assign a callback to, and then I can tell Windows what is under the cursor at this location. And that's how you make the title bar work again after I've removed it, right? I started writing a blog post about how I got that up and running in Unity. I'm horrible at posting blog posts because my blog is not live yet, but I promise I will post it.
You're a craftsperson here, right? You didn't have to go through this trouble to have the custom title bar and to have the borderless windows. You didn't have to for the standalone application, but you chose to, which includes eating broken glass when it comes to having to deal with the mess that is the Win32 API and all of that stuff. So that's really inspiring.
Speaking of that, I did find it kind of funny that while I was doing this for my own application in Half Edge, I realized that Unity hadn't even done this. For Unity, Unity's title bar is
shame.
Unity has a dark skin, right? But the title bar is still white. I think they fixed that for Unity 7 though, or maybe some version of Unity 6, very recently. Yeah.
So how did you come to learn that the handmade ethos and the handmade values did apply to making Half Edge? What's been handmade to you in that sense?
I totally, in the beginning, I totally had a stereotype of handmade being associated with super low level code of like assembly programming or like pure C programming or whatever. Just assume that I would be like very centered on that. But yeah, when I went to the, let's see, which one was it? It was one of the Handmade Boston.
Yeah, last year.
I was mostly talking about math, right? And like math is pretty applicable to whatever language you use. And while I was there, I thought it was a super nice community. Everybody was super welcoming. I was expecting everybody to be like these judgmental, grumpy people who are like, why are you using C sharp? C sharp is slow. I'm sure some of those people still exist. I had a good time. I thought it was great. And that kind of changed my view of what I thought Handmade was. And yeah, then I've been thinking about that as well. Like, what makes a community like Handmade different was interesting to me. And I think a lot of it comes down to, like you said, people who care about the craft, people who want to know how things work under the surface. Maybe not literally everything down to like building circuits, but you have a kind of curiosity. Like everything is not just a means to an end. You actually care about the process. You actually care to make it right and not just reach some end goal, right? And I think that curiosity is very much, it's just an approach that I have had for all of my work, for better or worse. If you just want to ship products and make money as fast as possible, generally it's going to slow you down a lot to be a perfectionist. But you will learn a ton, and you will, like, I don't know, if you have a curious mind, you're going to learn so much and you're going to find so much that you didn't know about before. I think that mindset, especially now in the wake of AI and everything, having people who care about what they make and they don't just want to churn out as much as possible and do quantity over quality, I think that's sad, and I don't like that kind of approach. And I feel like Handmade, to me, felt a little bit of an oasis. Oh, these are people who care. These are people who are curious about super intricate details, whatever it might be. It could be assembly stuff, but it could also be compute shader stuff, which is also pretty low level.
Yes.
When it comes to software quality, that's not just about the technical stuff. It's also about design. It's about UX.
UI. Yes.
And yeah, and all of those things are like, you can dig deep into those things as well. You can also care a lot about getting those things right.
Bravo, bravo. Freya, I'm seeing comments that people want to see you in person. Please come next year. Come in person. We'll bring you in. No problem. And I do want to spend maybe a few more minutes in the Q&A. If you remember, those who are new, we do, for those people who couldn't come in person this year, given the circumstances of the year, et cetera, we do a Q&A right on the chat server, okay? So please, for the next 5-ish minutes, let's ask questions to Freya about half-edge specifically. You can even get technical with your questions if you'd like, obviously. Show your love, show your support to Freya. Thank you so much. Couple more minutes. Questions are rolling in like crazy. Couple more minutes. Okay, I'm getting DMs asking for 2 more minutes. I'll give you 2 more minutes. Freya's a popular gal. And as a reminder, you can always send a friend request to Freya and DM her off to the side as well. 1 more minute. Get your tickets worth, send her DMs. 1 more minute. Yes, thank you, Freya. She just linked to the Half Edge Discord. half-edge.xyz. All right, I do think Freya deserves another round of applause, doesn't she? She did amazing. Thank you for taking the time in a very busy year for everybody to sit down with me and talk about stuff. After the conference, shortly after, I'll send people who bought tickets the director's cut, because she gets even spicier about Unity, about Handmade, everything, right? So I promise we'll have that for you. So yeah, round of applause for Freya. Thank you, thank you, thank you, thank you, thank you. All right, so this next demo, it's literally coming in clutch. It's coming in hot. So this is one of the, I was talking how Freya worked on the reinvention jam, like the handmade jam that happened recently. And this other demo, the ones we're gonna play now, also comes from the Wheel reinvention jam. So when the jam happened, you know, it's a tough call to make, but I look into submissions and people's commentary and decide like this should be elevated to the conference so that more people, even though all Jam's entries were awesome, you know, pick a couple to showcase. And this is one of them. This is called 6502, the spreadsheet. Which kind of makes you think 6502, what do you mean by that? Is that assembly opcode? What is that? Or what we're talking about? Why a spreadsheet? What's going on? But again, given the nature of the year, everybody's busy, everybody's having a lot of difficulties. He spent, and like he deserves a round of applause very soon. He spent all night trying to finish his demo and even said, hey, it's baked, it's in the Dropbox, I need to fall asleep. So, you know, round of applause for I believe his username, I'm gonna at least put it on the chat for you guys. It's Lewpen. Because I do feel like even after the demo, you can still ping him, okay? I think it's a good show of support that he worked so hard to still ping him, say your words of support and congratulations, and any questions you might have that maybe he can get to later, right? So here we go, 6502, the spreadsheet.
Hi, my name is Lewpen, and I made a spreadsheet that people liked. It describes the 6502 microprocessor, which was used in many popular devices in the 80s and early 90s, such as the Sinclair Spectrum, BBC Micro, NES, and early Apple machines. This processor is simple enough to know in its entirety, but versatile enough to be used in a wide range of applications. To see how this spreadsheet is useful and why you might like it too, we need to go back to the very start. So for our purposes, a computer can be defined as a bus which connects a set of devices together, and the bus allows those devices to send messages to each other. So we have a screen, we have a keyboard of some sort, and inside the machine, we've got the memory, which is used to store information, and the CPU, which is used to process information and control the devices. Let's look at the memory first. So random access memory has a set of locations, each with an address, and at each location you can store a byte. And we can see here the location addresses start from 0, and there are some bytes already in these addresses. The RAM operates by receiving messages on the bus from other devices which want to access those bytes. It can update a byte at any address. Please set this byte. Done. And it can be asked for the current byte at any address. Get me this byte. Here it is. Certain parts of this memory can serve different purposes. Let's lay the memory addresses out in a long line and add some of the things it might contain. It's common to have memory map devices, which mean that they send and receive information via portions of RAM which are assigned to them. For example, a certain area of memory might contain what is to be displayed on the screen. In the case of a simple text-only display, each of the bytes in this area might represent a character to display at each position on the screen. Here, the first byte in the screen memory is the H character, the second is E, and so on. We would expect to see this message in the top corner of the screen. If any of these bytes change in RAM, we would expect what is on the screen to change accordingly. There might also be an area of memory that is updated by a device such as the keyboard when buttons are pressed and released. There's a lot of space left over for the most important part, which is the program code. The program code is used by the CPU and contains a sequence of instructions for it to follow. These instructions describe the application or game that you are running on the computer in a manner that the CPU understands. Let's see how these instructions work. Just as we can interpret bytes as numbers or as characters when we need to, byte values can also be interpreted as instructions to follow in order to perform a particular task. If there were some instructions for a robot, that's a robot by the way, then we might assign different byte values to different movements. Now we can put a sequence of these instruction bytes in the robot's memory and it can follow them one by one. One more ingredient is actually needed if the robot is going to follow instructions one by one, and that is some kind of reference as to which instruction it's currently following. This is called the program counter. This gives you an idea of what instructions can look like. Now, let's think about a CPU. It needs to be able to read from memory and write to memory. It needs to be able to do arithmetic operations, adding, subtracting, comparing things. The 6502 has a number of registers alongside the program counter. We have an A register, X and Y. These can be loaded with bytes from memory, and these are where arithmetic operations will happen before being saved back into memory again. There's also a register called the status register, which is a single byte containing information about the result of the previous instruction. For instance, whether the previous instruction resulted in a negative, 0 or positive value. Let's look at a real instruction on the 6502. So the CPU loads an instruction byte from memory at the current program counter. In this case, it's A9. The CPU selects what to do based on this byte. In this case, we are loading the A register. Much like a variable, we are assigning a value to it with this instruction. The CPU goes in a cycle. It reads the next instruction from memory. It reads more memory if necessary. It updates the registers. It writes to memory if necessary. All of these can be described with simple mathematical expressions. The CPU does this over and over as fast as it can. Emulation of a CPU involves writing these expressions in a programming language and using them to simulate what a real processor would do. An emulator will generally contain a large set of if statements or a switch statement with one entry for each instruction. The complete operation of the CPU can be laid out on a grid. If each instruction is a row in the grid, then we have columns describing the memory reads, the register updates, and the memory writes. The real expressions end up a bit more complex, but they are written using a syntax which is common to many programming languages. These are just some random pieces I cut out. Some basic string manipulation can take any row with the instruction expressions and turn it into an if statement for that instruction in a particular language. Here is the Go code for each instruction, so there is one if statement on each line, and these are generated by the spreadsheet formula. The spreadsheet is designed so that you can select this whole column with the code in and copy it, and then just paste it into your favorite text editor, and there you have a working emulator for the 6502. It takes the current state of the processor, looks at the current instruction, and updates the registers and memory. I think a spreadsheet is actually a great way to describe a CPU's instruction set, or maybe even to design a new instruction set, because it's a way of capturing every piece of information, and it can become a definitive reference which gets straight to the point and just tells you exactly what each instruction does. Thanks to the team for helping to get this thing finished, and thanks to the communities for feedback and advice along the way.
That's crazy. Round of applause. Woo! Lewpen, sweet dreams. Well deserved creating this demo, and the spreadsheet that can emulate just the leveraging of that is wonderful for me. I still think let's put on some music just for a couple of minutes so we can prepare our official talk of the afternoon. I'm so excited. So just a couple of minutes of music, and also we should probably say thank you to Lewpen, because honestly, he deserves it. I'm going to tag him over here again. Well done. Well done. Okay. We'll have our first talk of the afternoon coming very soon. Thank you for showing Lewpen some love. Thank you, thank you. One minute and we'll start our first talk for the afternoon. 1 minute. Spreadsheets are build tools. Sound room, I'm gonna grab microphone 4, LH4 to talk. Okay. Testing 1, 2, 3. Let's give a round of applause one more time for Lewpen 6502, the spreadsheet. Bonkers. Bonkers, I love it. All right, our first talk for the afternoon. Tomas is at this point a good friend, and he's his company's hiring, by the way, so keep that in mind for later. And he's coming in at his own individual capacity, nothing to do with the company, although he works for it, but you know what I mean. And the talk is interesting. It's like systems thinking, just like we do for programming, but applied to a career. So like, how do you bootstrap instead of a compiler? How do you bootstrap a technical career, perhaps? Because he's a principal engineer at his company right now. Company that does a lot of handmade related things, simulation, 3D simulation. You said lots of simulation, Tomas, lots and lots of simulation, which I think lots of people here love that kind of thing. Physics is very attractive. Physics program is very attractive to the handmade community. So what does success mean as a software engineer? And how can you navigate that? That's an interesting question. And I think applying systems thinking to your own career, not just programming, I think can help, having that kind of mindset. So without further ado, let's give a round of applause to Tomas Diaz. You want this one or this? No, I'll take that one. Okay, cool. And this is the thing. You can just use this one for next and then previous. Also,
cool. All right. Thank you, everyone. So I have quite a few slides, 99 to be exact, so we'll just try to get through it, and I'll try to make it interesting on the way. Proficiency patterns and play. So this is, you can read the description, but this is just really one trajectory on how to possibly navigate this, and I'll try to kind of give motivation on why I believe these things. So just to kind of get out of the way, so what is KNC? What do I do? It's a very small company, about 50 of us, but we do quite a bit. We do actual kind of experimentation over in the left, but we also do a ton of software and a lot of simulation. And so we get to work in very unique spaces with really difficult problems, and today I'll try to kind of walk through how we approach those problems and really the technical challenges that we face. So who am I? Why am I speaking? So Abner kind of had some questions in mind that I've been thinking about and I kind of want to think about throughout this talk. So what does a successful software engineer even mean? How is a career change possible? What role does school have? And this talk isn't prescriptive, so I'm not going to say you just have to learn X and you'll be the best. Like, that's not really what I'm trying to advocate for. I really just want to say, X was really useful for me. Maybe it'll be useful for you. This was the type of talk I kind of wished I heard earlier on. So things that I think are important will be kind of an image and statement, but we'll kind of begin in the beginning. So I went to NYU, and I didn't really know what I wanted to study. And I think being in New York, the gravitational pull of finance kind of took over. So I spent a lot of my early years there just thinking about how to price derivatives and how to model these kind of financial instruments and think about them through kind of a mathematical lens. But I took one class that kind of changed the whole trajectory of everything. It was called critical finance, and it introduced me to other thinkers. This is Max Weber. He writes a book called The Protestant Ethic and the Spirit of Capitalism, and it totally transformed my understanding of what finance could be, and that also then introduced me to Jean Baudrillard, and then Deleuze, who wrote one of the most difficult books I've ever tried to get through. I still haven't finished it, called Anti-Oedipus. So if you really want to just be mean to yourself, you can try reading that book. But anyway, these ideas started floating around while I was still very much focused on how to model financial instruments. That was enough to get a job. So this was the view from my office in New York. On Wall Street, and it was working, at a hedge fund doing this. But I hated it, and the view was really kind of the best part of it. So I left, and just by a show of hands, has anyone heard of 42 before? Well, yes. Yes. It is a number. But no, so I left kind of the finance world, and I didn't really know what to do. A friend told me, if you were under 30, you should apply to this program. Just try it out. If Xavier Niel is out there, so this is a French kind of telecommunications person. He funded this program, and I'm severely thankful for him. So totally changed everything, but I'll kind of walk you through what this was. So I applied. It looks fun. People are having a good time. But they actually called the admission test la piscine, which is swimming pool in French, because they describe it as you will be drowning every day. And there's all these references to needing to bring like a towel around because you're just going to be wet and soaking. So to give you some like insight into what this was like, you get this dashboard when you start, and this dashboard is trying to gamify learning. But there are all these little things that kind of nudged you, like all of your hours are tracked, which kind of shows how much effort you're putting into the program. And this, again, this person kind of sneaking out there is Ray Dalio. So this is a financial person who's all about this philosophy of like radical transparency, radical truth. This was really brutal for a lot of people because they started using their hours as a way to measure their own self-worth, and your ego gets destroyed. Everyone's grade is public, and it was not for everyone. And the admission process was a full month. And we started with about 200 students, and by the end, I think we were 50. And then from the 50, I think about 45 got in to the school. But I want to talk about what that looked like day to day. So, this is the second day 2, but it was 0 numbered, so the third day. And we had this problem. So you're given a function, and that will take one character, one char, and we'll put it out. And what you're asked to, so this is the function you can kind of rely on. What you're asked to do is you have an integer, now print that out to the screen. And this really was like a pivotal moment for me, because I'll walk you through, but this seems so trivial. And yet it was so not that, especially third day, not really fully grasping C yet. So why was this challenging? Just take printing, 12,345. Well, first, I'm sure a lot of you are, we're C programmers here, but the number isn't directly printable. It's an integer. So we have to map it to some sort of ASCII value or some sort of char representation. And so for people who don't know this, when you're trying to print the character 0, it maps to an ASCII value, which is 48. There's order there. So the question then is how do I get that first digit? How do I get that 1? How do I print that out and so on? And then what about negative numbers? How do I deal with that? So we'll look at some code, and I'll try to keep this interesting because I know looking at code can sometimes just be a drain. But so here's a function that solves this problem. You have your character. You see, is the number that you're given in as your input less than 0? If it is, we'll make it positive, and we'll print out a little negative sign. Now, if it's less than 10, we can do this really cool trick where we're taking that integer value and moving it up on that 0, which is 48. So you're moving it, pushing it to the right char value that you're interested in. Now, if it's bigger than 10, you do this. And let me just say, these are not the solutions we were writing. This assumes that you understand recursion. This assumes you understand ordering that's going on. So, you take this print number, you divide it by 10, and it calls itself, and then you do a modulo 10. That is not a conceptually easy way to think about this problem. But yet the code is so succinct, and afterwards you would say, wow, this is a really great solution to this, or some people would. So really what we would be doing is more of a non-recursive solution, where we're thinking about how do we approach this in kind of, a way that doesn't require calling ourselves. And so, we handle it the same initially. If it's 0, we'll print out that first kind of 0 character. We'll deal with the negatives the same. But there's a difference here. Now we're thinking about how do we store those individual slots in a way that we can then access at a later time. And so we create a little buffer to do this. And as our number is greater than 0, We then start chopping off pieces of it and storing it into those individual slots. And so then we divide by 10, and we call this in a while loop until we're less. And then we print them out in the order that we've kind of stored them in. We have to be careful with that. Now, again, this was kind of a solution that you could get to at the end of the day, but still, there's other solutions you can think of. And so one solution maybe is, what if I just start from 0 and count up until I hit the number of my input, and on the way I'm doing this storing operation. Like that conceptually I think makes a lot of sense. But the solution's much longer, and so we'll just go through it very, very briefly. So again, we need some way to store our digits, and as we kind of count up, we then store those individual digits, and what we do is we propagate the carry. So once one of those slots becomes 10, means we need to bump up the next one. This is not performance-oriented. Some may argue this isn't even easier to wrap your mind around because you have to do all this carrying operation. But this is how we approach these problems, because again, no one's really telling us what's the right way. They're just telling us you need to solve this problem. And that document I showed you, that's all the resources you were given. And this was before ChatGPT too. So we would eventually print this out, and again, we have some order. Now the next solution is crazy. This is like comically bad, but also at the same time very interesting. Like, how could you even program this in, how large is your file? And I just show this because, so often some people maybe think this is how I would approach it. You're not, how could you not do it this way? And we don't even consider solutions like this because we just immediately write them off. So kind of the first thought I wanted to share was, the right solution is very context dependent. And it's something to keep in your mind. It's like, what context are you working in? So what was our context? Well, we needed to pass this exam every day. And it was very challenging because, that was the 6th exercise. You were graded in order. So if you got the first exercise wrong, but all of the other ones right, you got 0 points for the day. And it was brutal. I mean, it was really soul-crushing to spend, 14 plus hours on the day. And just because you were off on that first one, you got 0 points. So that was our immediate context. Be correct. Not the cleanest code, nor the most beautiful, but really a layer above that was learning the C language, learning about memory layout, learning about type manipulation. And then the layer above that was learning how to solve these problems using a very limited set of tools to the fullest. And we would take advantage of this. We got to the point where our tool set was so limited that we would purposely constrain it. We would say, I bet you can't solve this problem without using malloc. And then we would say, I bet you can't solve this only using malloc. And it's those types of questions that put you in a really interesting space, because then you start thinking about your problem totally differently. You turn your hammer and nail into other things. And that, to me, has been tremendously valuable, is when you start thinking like that. So I'm going to talk about this sort of, we'll go through this. So Joel Gruss writes this great book, definitely worth checking it out. So I'm just going to kind of read through one of these kind of stories. So the interviewer says, I need you to print out the numbers from 1 to 100, except if the number is divisible by 3, print fizz. If it's divisible by 5, print buzz. 15, print fizz buzz. So we know this problem. And I would say, I'm familiar with it. Great. We find that candidates who can't do this right just don't do well here. Great. All right, here's a marker and eraser. And I think, do you need help getting started? No, I'm good. Let's just start with some very standard imports. Import numpy as MP, import TensorFlow as TF. You understand the problem is fizzbuzz, right? Do I ever? Now let's talk about models. I'm thinking a simple multi-layer perceptron with one hidden layer. Like, to me, this is amazing, because it's like, we never would ever plan on using TensorFlow to solve this problem, and then even thinking about it opens up so many new ways of kind of approaching this. So I'm still waiting. I do hiring at my company, so I'm always still waiting for someone to bring this out. So at the end of that career, kind of at 42, we had a hackathon. And this was kind of thrown by AWS. They came in, they had some cool prizes, and they're like, all right, let's see what you guys can do against our APIs. And we were totally lost. I mean, we had built all of our tools ourselves, so we weren't allowed anything in the standard library. Like one of the first things you do when you get into the school was you build your tools. And so we were just like, this is very foreign to us. We'll try to put something together. So a friend of mine and I just very, very tightly took advantage of some of these systems that they had, and we put together this demo where you could act and match other movie clips, and it'd give you a score based off some AI model that they had running in the back end. Now, the reason I bring this up, and I'm not going to show me acting this, this is just a screenshot, is that this was also very incredibly valuable for me. There's tremendous value in connecting tools rather than generating new ones. I'm talking to an audience who's passionate. I'm passionate about making tools myself. That's not what I'm saying is not worthwhile. But I think sometimes we forget, with duct tape, you can get some crazy things working. And don't forget you can do that. That's an incredible power. And you can add so much value that you didn't know was there by just tying things together. So, after school, I saw this application, software engineer with a physical science background. Never let the title dissuade you from applying. Just make sure that when they ask questions, you know the answers. The important point here is interesting work is far more interesting than a pedigree. So often I think people may think I need to go to XY school, and that's really going to make a big decider for me. I think it does help. There's no doubt there. But ultimately, if you have interesting work, that goes way farther, in my opinion. It worked well for me, and that's really the people I work with is really the same for them. So we had some projects at schools just to show what this was. So, we did graphics projects, and everything we did was hand rolled. So we could tell you every little bit about it. And we got into doing fractals, and there's a subset of fractals called flame fractals. So we would implement these. We were really into sorting algorithms, and so we would run these competitions on sorting stacks and stuff like that. So all of this, I think, lended itself well to some of the technical work that I do now, and we'll talk through some of that. So shipbuilding. We've been making ships a long time, and you can kind of tell that by the language that's used. So I'll try to kind of paint, so we always remember this, and maybe some people already know, but starboard, it really comes from the steer. So you have an oar. So if you put the oar in your right hand, that's kind of your starboard side. And port, if you imagine you have an oar in your right hand and you're going up against something, that's your left side. The other way people remember this is port is 4 letters and left is 4 letters. But I like knowing the little bit of the history behind this because it gives you kind of more of a contextual note. Now, only recently has naval architecture really become much more of a scientific field. So there's a bunch of tools to do this kind of analysis, and they're all very dependent on the type of ship. So I was tasked with initially to build a ship, and that was really challenging. So the best way is, we were time constrained. We had about a year to do it. Is you need to move. Moving forward, no matter how bad, is still very more beneficial than getting too stuck. And so we broke a ship down into 3 sections. You have the hull, you have the interior, and then you have the superstructure, which is on top. Now, the first thing is what are our primitives? So we had a plate, a 2-dimensional plate determined by 5 points, just like that. And then we had a mesh plate, which was an N by M grid. That's all we really had. We had some doors and a cube, but those were less useful. And so we created some better abstractions. I remember I created this little ship, and a boss came in and said, "That does not look like a ship," which wasn't a great start, but we were moving forward, and that's was vitally important. We did get to do really cool things because we needed to move fast, so we needed to understand how could we model a superstructure, which is very complicated, very, very simply. And what we came up with was you can use two curves. Very simple. Those, that's a few parameters that you need to now manipulate, and you use a template to sweep over kind of a reference curve, and you can create these very nice shapes, and then you can use that to then, discretize it into a series of plates. But during this whole process, you ultimately start thinking about rotations. And so I'm going to use the next kind of 5 minutes just to try to let you know my understanding about rotations, and maybe it'll help you in the future. So as a programmer, you know about rotations. Everyone knows about rotations, but the way we usually do it is with something called Euler angles. So you have these different axes, and you're just shifting them around. Conceptually, I think this is very straightforward. Like you can teach anyone, this is how you rotate your object. You have kind of these different axes, and you're pushing them in a series of ways. Now, most of you know, but there's an issue here. Like let's say I'm trying to rotate my object. I'm going to rotate it kind of 90 degrees in the x axis. And now I want to do some rotations on the y, so I'm rotating it that way. And then I'm going to rotate it in the z, and something bad happens here. Why is my y and z keeping me in that plane? This is bad, right? Because I want to be able to move that object up. And so this has the name gimbal lock, of course. And it's not good because you can imagine you're trying to rotate something and now gets stuck. Your y and z are no longer effective. So ultimately, someone says, "Oh, you just use quaternions." So much easier. You just make sure you remember all the multiplication rules. So these maps are multiplication rules. Or better yet, a deeper understanding is just remember that the unit quaternions give you a group structure over the 3 sphere. That happens to be isomorphic over the spin 3 or the SU, so the special unitary 2 group, which of course is the universal cover of SO3. Yes, that's much, much more easier. And I think there's a point where you hit this and you're like, nope, I'm not going to go any further. So I'm going to try to just, before we get into kind of a demonstration, is just imagine you have this object. And by the way, flags are really useful if you need to understand orientation. You just attach a flag to it. But nevertheless, how else could we rotate this object? We did it over those kind of angle axes, but there is another, I think, much more intuitive way to do this. So what if we just use a vector? A vector is just x, y, z points. So we have, our x is, say, 0.8, our y is 0.7, whatever it might be. So I'm manipulating those axes, and I'm just drawing a vector. I can then rotate my object to that vector as, just saying align the object to the vector. But there's one last parameter, right? I need to then rotate that flag around that vector. So this is called angle axis representation. And if you can understand this, you're so close to a quaternion. It really is basically this with a little bit more magic going on, but this is a huge conceptual leap. If you're able to just grasp that you're, instead of doing it over some sort of axis and an order, instead it's a vector and an amount that says how much to rotate around that vector. So 3 components to represent the axis, 1 component to represent the rotation amount. And if you can just take away that, then that's a win. But if you want to go deeper, you can start imagining, like, how do I actually put these together? So very high level, you could think rotation is some sort of amount times the axis of rotation, so that vector. And then you can even go deeper and say, actually, I should represent that vector as a series of bases. And so you have the cosine versus amount of rotation and the sine versus those bases, so the x, y, and z. Now the real equation, the real root Here's the quaternion is that. And you get this kind of divide by 2. So theta, your amount, gets divided by 2. This is really hard to understand until you grasp that actually this is applied twice. The quaternion has to be applied twice. If you don't apply it twice, you end up stretching your space, and that's not good. You just want to rotate your space, so lengths would become longer. And really the trick here is that the rotation is in the multiplication. And quaternions and all that crazy maps of manipulation was really to deal with this fact that you want your rotations to be able to stack, and we can do that through multiplication. Now, is there another way to rotate this? Yes, absolutely. There are much more advanced ways to do this. So there are exponential maps, there are rotors in a field called Clifford algebra, which is geometric algebra. There's spinners, which are the same as quaternions in 3 dimensions, but different in 4. And then there's hop fibrations, which are about mapping kind of higher dimensional spaces into lower. Now, I find personally that it's more enjoyable to be creative. Like, you can go dive deep into these topics initially, but it's more fun if you start just asking questions like, can I rotate my space around my object, but not my object? That will then give you the kind of intuition into why these other kind of things exist. So kind of the main, I think, point that I would like to drive, I have other ones, of course, in the talk, but I think this one's very important, is only yourself can be the judge of whether you understand something or not. And that's so crucial to learn. Like, it's so easy. You hit quaternions, you're like, nope, I'm out. And that's fine. I mean, we have to get things done. But you need to be very attuned to when you don't understand something and what exactly you don't understand. Because once you have that, you know what to then learn and how to get rid of it, and there's a lot of value in that. So more understanding, 98% worth it. The 2% is, it's there. There's a good poem, When I Heard the Learned Astronomer by Walt Whitman, that kind of speaks to that 2%, but sometimes you just don't have time to do it, so that's another thing. So after that project about naval architecture, I kind of moved into the search and rescue space. And so, you can't find the trail, your phone is dead, it's getting dark, you have no water. Do you stay put? Do you backtrack? Do you travel in a specific direction? Do you panic? You're now responsible for leading a search and rescue. Kind of what do you do? How do you start searching and how? So I'm going to tell you some truths or myths, and then you can just raise your hand if you believe it's true, if you believe this statement is true. So lost people will turn in the direction of their dominant hand. Just by a show of hands, who thinks that's true? So there's actually support for this claim. Left-handed people will 70% of the time turn left. Right-handed people, if they drive on the left side of the road, it's 50-50. And then if it's right-handed and on the right side, it's about 70% as well. All right, so next statement. Lost people nearly always travel downhill. True. If you believe that's true, raise your hand. Okay. It's about half for those who are online. So climbers in dry climates will go up. They believe that a better vantage point will help them. While skiers, of course, are going to go down. So it's dependent. Okay, next statement. Lost people do not travel at night. True? Less people this time, less people. Okay. Climate is really important on this. So hunters will move at night about 50 times if it's in a dry domain, but much more if it's in a temperate domain because they're used to moving at night. And the last one is investigation always trumps using these statistics. So if you know more about your person who is lost, should you use that or should you use the statistics? True or false? Okay, so more people say yes, investigation is important. And it is, but a bad conclusion from an investigation can just be wrong. So sometimes using the statistics is better because you have to gauge how trustworthy your investigation is. So what was the problem statement that we were really interested in? We were interested in developing machine learning models to help better predict where lost people were. And I want to talk through kind of the real challenges in doing this successfully. We had some model architecture. Again, you can imagine we have some inputs that tell us a little bit about the land. We need to run our model, and then that outputs some sort of distribution heat map that we can then, as a search and rescue personnel could then use to start their search. But let's talk about data. You can imagine if you're lost, you're going to be really bad at giving good data because you're lost. And so the data is really, really bad. There was only 17 data points that we had that were actual paths of lost people. And on a more grim note, that includes everyone that data is only of people who are alive, because we can ask them, kind of where they were, and someone who's familiar with the area can understand the path that they took. That's a lot more common is what's called IPP, so that initial planning point, so that's where that person was last found, or known to be, versus where they were found, so the IPP and find coordinate. More data for that, and then there was just a bunch of really, really noisy data from all over the world using all different formats, so we didn't touch that. So I want to talk about just that path data. How can you even use 17 data points to do anything successful? And so this is just an example of kind of what this data looked like. It's just a series of coordinates, and there's kind of a time element, and you get a bearing and a distance. So what we thought is, let's do a super simple design first. The premise is that if you're lost, you're only working on local knowledge, so just around you. And so you can imagine we take our person and we put them in a grid, and then we just fill up the grid with elevation. And then instead of using that path data to its full extent, we're just using the individual data points. That explodes how much data points that we have. And this actually required us to kind of rework the original data. So now we kind of load in the neighboring cells elevation, and we use that as our training point, and all we're trying to predict is the probability of a direction. So the next step, what's the probability of them staying put, going north, going south, and that was it. It worked somewhat. You would expect a random model to just be giving 11% probability distributed across all of the possible squares. But our kind of default out-of-the-box architecture gave us about almost 60% correct prediction. We did a lot of optimization using Optuna, which is really useful when you hit problems like this, but it can kind of search the hyperparameter space for you, but we started getting better and better. Now the question is, people don't just use elevation when they're lost. They also use man-made structures and hydrology. So what if we then add in additional data? So now we're not only keeping track of our neighboring kind of cells elevation, but also adding if there's like a man-made structure there or a river. Would that increase our kind of model success? And it did. It did quite a bit. There's some technical stuff here, but our model was training really, really well. Now, our next kind of model, and this was the one that I was most excited about, was, we have this place where they were last known, we have this place where they're found. This seems perfect for reinforcement learning. I bet we could train an agent to try to figure out, get to the endpoint, and we'll use that path as a sample. And it was challenging. It was a different paradigm. We trained, and it seemed to be training well, but I'll show in the next few slides that it just didn't do well. And then the last thing to kind of introduce is, so often in machine learning, you need a good metric. You need a good way to score how well your model's doing. Now, for some problems, it's very apparent. If it's tell me if this thing's a cat or a dog, it's very easy to tell. That's an easy metric to design. But for here, this is more challenging. And so this was pulling from research, but they use a different kind of metric, which is a relative metric. The intuition behind this, and this actually has an interesting history because it came from crime statistics, was imagine you're given kind of a map, and that map is a heat map. If you're in charge of search and rescue, you're just going to go to the place that has the highest probability. It's not if it's 80% or 10%. You just want to know in the map what's the highest. And because you're doing that sort of operation, it's a relative metric that we used. And it's called map score to do this. And so we could run this, and you could see that our map scores on our different models, the elevation model, the OSM model, that has the one with the hydrology and the man-made features, and then the reinforcement learning model. But what's much more fun is actually looking at some of these data points. So on these maps, you can see where the IPP is, so where the person was last known to be, and where they were found. And so these were all real cases. Now, when we're looking at elevation data, you can start to see that elevation data works pretty well, but it starts to suffer when the elevation is not changing. So if it's really flat, as you would expect, it gets stuck. And some of these cases, again, more elevation, better for the elevation model. There's more data there for it to kind of manipulate. But you can see kind of on this side, it's so flat over here that it just distributes equally over, and you get a really low score. So not great. Other cases, it's like perfect. So again, it depended on where you're looking. Now, when you add in the OSM models, we get better. So we're able to rerun some of those cases, and we see that we're getting better matching. And so again, just more of these maps to look at, but I wanted to look at the PPO. So this was the reinforcement one that we were so excited about, because you would think we had more data, we're designing this agent, it should kind of learn how to be lost, and then we could use that. And some cases, it just did really, really well. Other cases, it just was terrible. It had this real big interest in wanting to go west for some reason. So the big point here is the representation and transformation of data is often more valuable than the data itself. I tried to kind of walk through, we were given such limited data to begin with, so a handful of actual paths. It's only when you start adding and transforming that data that you really kind of unlock a whole new potential. And I think we see this in low-level programming too, and I know different talks have talked about kind of data-driven programming. So I'm just saying that mindset is useful in other places as well. The last kind of project I just wanted to touch on was a recent one. I think 2 years ago, came to Handmade to recruit for this project, and we did hire someone who helped us a lot. So the problem statement is that there was this need to increase situational awareness and decision-making for senior leadership to enter a geographically separated operating center. This was going to be really challenging because they wanted to look at all of these different data types, like LiDAR, like point clouds. And these were diagrams that were in the initial proposal. But the problem was we ended up getting that contract, and then the client just went away. So we got a lot of freedom to kind of design an application that we were trying to meet this kind of client who no longer had this specific need. And so we have a demo video just to show this, and it's a lot easier to kind of just show what this does, and I'll talk about one of the challenges here. What it allowed you to do was scan your environments. So you could use an iPhone, and using iPhone's LiDAR sensor, you can then build meshes, and then you can texturize those meshes. Once you have that, you have a 3D model, and you can then load that 3D model into like a virtual scene. So this was built using Unity. And what we were super excited about, so we represented everyone as these kind of like black cubes. So that was Matt, who's in the actual, so this was what we wanted to show was like, I'm in virtual space. I'm in kind of VR. Matt is in the office. He's wearing a HoloLens, so an AR augmented lens. He's interacting and seeing me point virtually. And so even though I'm not physically there, he sees that. Streaming point clouds, so how to do that, and so this gives a dimensionality. What we found is, as we kind of continued progress in this program, we started just scanning so many things. Like, we would go to museums and just scan stuff, because you started collecting like a library of 3-dimensional scans that you could then share and talk with friends. I mean, we got really into it, and so this was like someone's kind of rooftop. We're in a kind of transport aircraft here. Hotel room. We just ended up someone's office. Different types of structures, and so this was all kind of there, and it kind of worked collaboratively. But I just wanted to talk about this last point. Streaming points is really, really hard, and this is a very active field. So this image that you see, so MPEG came out with a call and said, please, industry, figure out how to do this for us so we can standardize it. And there's actually three winning solutions that they wanted to investigate. TMC 1 and 3, which were so similar that they just said TMC 1.3, and then TMC 2. Very different approaches. One said, let's take advantage of the fact that point clouds are geometric, so let's build operations that are geometric based. That was TMC 1.3. The other approach is, look, we've done all this great work with video compression. Let's try to take advantage of video compression, and that's TMC 2 that we see. Not particularly straightforward. So each pixel is no longer just color, but has this X, Y, and Z coordinate. And so we move from kind of 16-bit to adding a 48-bit to map those individual dimensions. It's a 200% increase. And this was a really important point too, was compression, if you want to do it quickly, is very different than if you have all the time in the world to do compression. If I want to compress a file, but I can take all the time I want to do it, then I can get it much, much smaller than if I need to do it within some sort of bandwidth constriction so I can get it to you in real time. And that's the tricky part, is you have all these cool algorithms that do this great, but they spend like 3 or 4 hours to compress. Like, that's not useful in a real-time context. And so point clouds, the other core point here is when you think about an image, it basically projects a 3-dimension into a flat surface. What happens when you do that operation is that your neighbors, your neighborhood of pixels, are usually related. If you take a picture right now of my sweater, a lot of neighborhoods of my chest would be very similar. And compression algorithms can take advantage of that. Can't do that in 3 dimensions because neighbors aren't a given structure. They're just discrete points. You can find your nearest neighbor, but that doesn't mean anything in terms of the locality that you can take advantage of in a 2-dimensional image. And it's a trade-off in terms of kind of pre-processing time and more memory and all these things. We jumped the gun. And so I bring this all up because we knew that this was going to be an issue. Like, talk to anyone, they're like, streaming points is really hard. You better use one of these really cool but very complex solutions. So we did. We thought, yeah, we'll try it. They're not easy to use at all, and they're very vague, and there's this sense, too, that they're kind of trying to be purposely vague because people see value in this, and so you end up with just things not working. And so we jumped the gun here because we said, let's do that before we had something working at all. So one solution is better than no solutions. And I like this image because, again, it's not meant to be interpreted this way, but at least you painted a face. It may not be in the right place, but you painted a face. And that was really a huge, I think, thing to remember is even if you're going to have problems, make sure you get the dumb one in first, because then you'll uncover unknowns and things like that. So always very important to do. So conclusion, just some final thoughts here. So context is really important. Make sure that you remember kind of the context you're operating in. Question the context. And when people say this is the right thing to do, make sure you understand the context they're working in. Relate and connect things. So it's so much fun when you can take one thing and put it in somewhere that it's not supposed to be. It opens the door to kind of reimagining the problem or whatever it might be. As I kind of mentioned, I think the most critical thing I tried to kind of say here is be attuned to what you don't know. That's like very valuable information for yourself. So if you don't understand something, try to dial into what specifically don't you understand. It becomes a lot easier to solve that misunderstanding or that lack of knowledge there. Nurture understanding. Key on data representation. So the way you represent data is as crucial as the data itself. So think about how you can manipulate it, how adding just a little bit of other context to it just changes it drastically, like we did in the kind of search and rescue. Implement one. And lastly, I think we saw this as kind of a theme, but remember to have fun. Like if things get too not fun, then try to change the context, do something kind of out of the box. Remember, it's supposed to be fun. When you do a lot of this work, everything is an acronym. So crank it. That way you can kind of remember. So thank you, everyone, and thank you for being here.
Sound room, I'm going to use LH1 as well over here. You can sit right here on the left. Well done. Okay. Can't do a very long Q&A just so we can get back on track on the schedule, but I'm sure they can pester you later, right? Hopefully.
Yeah, absolutely.
And then the chat as well, yeah. And don't worry, guys, I want to give you a quick bathroom break too before the next talk. So we're a little behind schedule, but not too much, and I'll work my organizer magic to make sure we end on time, et cetera, don't worry, right? Just letting you know that even if we're a little behind schedule, I got us covered. So this was awesome. This is fantastic. And we do have some questions coming in, so why don't we get started?
Sure.
Absolutely. So the first one from Sorensen, thank you for your question. Did you arrive at a better alternative for streaming point clouds?
Yeah, we kind of did. I mean, we took a naive solution where what was important was get as many points across and only update points that change enough. Like you think about a scene, a lot of those points are not going to change, only maybe people moving in the scene, and that's a much smaller subset. So if you can do a quick check, which points are changing, send those, good to do. The last thing too is I don't care about dropped points. Drop them all. I mean, so don't worry about the points actually arriving on time. If they don't, just it's fine because there's more points on its way. Yeah.
Next question from Victor. Thank you for your question, Victor. Did you consider pixel streaming instead of streaming points themselves?
Yeah, so we thought, because that was kind of alluded to in TMC2, that implementation, is you can imagine you take, you try to compress your points into some sort of texture, and then you send that texture. We did think about that, but it wasn't kind of meeting. We really got held up and like, let's do the correct thing here, TMC2, and it was just a waste of time.
Yep. Okay, the professor is asking, did the prediction model help find any lost people?
Yeah, so that's the other thing about kind of doing this work is, you get a contract, you give it off to kind of the agency that's funding it, and then you don't really know what they're doing. In theory, those models are in a tool called Landsar, which is open to the public for people who do search and rescue. So those models, in theory, should be there, but they need more validation, of course, before you actually say, I'm going to use this one. So, yeah.
How do you break down problems that seem impossibly large?
Yeah, I mean, that's a really good one. I think we all kind of build a tool set to do that. I think it's really important to remember, like, what is the solution I want? Sometimes it's to have fun, and that's always a good one. Sometimes it's like you have a very clear kind of prototype that you want to invest in. So just always try to remember what is the solution I want, I think is how I do it. And that gives you a way to then decide what's important. And you can then kind of focus in on building the most important part.
Evaporate is asking, why did you leave finance? Not challenging enough for you?
Well, I think
didn't say
it's also a great question. I'm sure that there were other funds out there that would have been more challenging, more technically challenging. I think it's really discouraging when you put a lot of time into a technical problem and no one's really that interested in the technical solution. They're more interested in matching the expected value that they think this asset's worth. So oftentimes you're actually trying to do the reverse, where you're taking what people think the price should be and trying to create math models to meet that way. I didn't like that, so.
Amr Musa, I know this isn't the point of the talk, but I'm curious what RL methods you used, actor, critic, deep Q networks, etc.
Yeah. So we used PPO as our algorithm of choice. We had success with it for, I did a talk at Strange Loop modeling crowds using reinforcement. So we used PPO because that proved to be really useful there. So yeah.
Rest in peace, Strange Loop.
Yeah,
By the way, I got some of those people coming over here. I do feel bad though for Strange Loop. So Mary Bush, thank you for your question. Were you using an agent-based model framework for the lost person models or any other project?
Yeah, so that's another good question. Like in my mind, I was like, I want to build a whole virtual world. I want my, person to be like actually walking around. Don't do that. Like you can simplify your domain where you're basically working on a grid. There is no kind of human person locomotive modeling that needs to go on. You're mostly modeling points on a grid. So you need to reduce your design space a lot. And fortunately, a lot of the work I showed today too is people I work with as well. So it's, I rely on them as well.
Timothy Barnes, see, I didn't forget about you. Sometimes I do questions out of order. How did model validation work with only 17 last seen found samples?
Yeah, great question. We needed to be careful, right? Because, you don't want to be, there's always this tendency to like create a validation set that really, is going to do well because you're kind of sneakily learning it through the training phase. So we actually we asked our collaborator to just hold a few paths for us, so we didn't get to see them. So that way there was no mix-up. We couldn't actually train accidentally on it.
I love this question too. How is working with the DoD? Is it fun or hard?
Yeah, I mean, I think that's there are many layers to that question, and I'm always happy to have conversations offline, talk more about it. I think for me personally, there's a range of very, very interesting, challenging problems, and the DoD is the one who often needs to work in that domain. So you do get to work on really challenging problems, and so for me, I very much have enjoyed it.
Yep, and I'm a military brat. And we have the whole spectrum of opinions on this in the conference. I love to do that. So this question comes from Varan. Have you considered sightlines rather than just the grid?
Sightlines? Like being able to see a farther distance?
It's my understanding. I'm not sure. But
yeah, so that's actually a good question. The idea that you're locally lost works well if you're like in a dense forest, right? Because you can only see so far. But if you start being able to add visual, you're on a mountain, you can see kind of the valley. We did start actually thinking, how would you model that? Like, how do you compress a variable range into a fixed size? And unfortunately, we just ran out of time. But we did, investigate what that would look like.
Yes, this is an interesting question. Let me try and do it justice. So the only send diffs plus ignore drop strategy sounds similar to TV streaming with keyframes. Bandwidth constraints were mentioned, and I understand that larger diffs would require more data. So was the diff compression or point dropping dynamic in any way,
Yeah, I mean, I think our aim was to show kind of a proof of concept. So we were able to kind of not actually do a full production test. So we were working in a very nice, comfortable little environment. We did think about these things, like ideally there would need to be tuning. How much of a deviation should you actually consider? And so we didn't get a chance to actually do the tuning that would ultimately need to be done.
Let's try and do one more question so we can continue with the presentation. But this has been amazing. So, do people often stay put when lost? Did the model ever predict that behavior?
Yeah, I mean, actually, staying put is a really good strategy if someone knows that you've went on a hike and are, you can expect someone to look for you. Sometimes people just do things, don't tell people, and staying put isn't really going to be helpful because no one knows to look for you. But hugging a tree solution is taught to children, and that often works very well. But yeah, so I'm not going to tell you what to do when you're lost, but try not to be lost.
And Tomas, I absolutely love this talk. I just wanted to mention again that he is, and his company is actually actively hiring. At the same time, they didn't sponsor me. So if you want to go talk to him and say, I hate this about your company, blah, blah. By the way, do you hire? Like I love, you can straddle that line. It's okay. It's really fun.
Yeah, I have no ego because of that school. So if you want to come and tell me my work's terrible, that's totally fine.
Round of applause for Tomas Diaz. Handshake, of course. Well done. You can leave that right there. Fantastic. And as promised, so like I said, I think we're officially technically like half an hour behind schedule, but with the demos that are left and the talks that are, the one more talk that's happening, I kind of know the length of it. I'm gonna do my organizer magic. We're gonna be hopefully done by 5 o'clock still. And I wanna give you that bathroom break, okay? So 10 minutes, 3:25, so that you can come back at 3:25. By 3:30, I would love to continue the next talk, all right? So 10 minutes, you guys deserve a quick stretch, okay? A quick bathroom break. See you soon. timing things. But I think if we do have time for Q&A, we can sit down here, almost like a little fireside chat, right? And I can grab on the chat and start with questions. Yeah, you're set. You're set. Yeah. Just wait for my. That's your water bottle. And it's gonna be yours. Testing. No problem. Just like this. Couple minutes. Getting started here soon. Let me check my DMs. Sometimes people send me a DM being like, I'm in the bathroom. And if there's a lot of people in the bathroom, then I wait an extra minute. I'm giving you some behind the scenes look at how this works. Yeah, one more minute. I'll give people one more minute and we'll get started. All right, so in the interest of time, right, to try and get us through by 5 o'clock, the bathroom people can make it later. This is amazing. So I'm excited to announce a speaker who's been with us since the very first Handmade Seattle, I must say. Like when I first started Handmade Seattle 2019, do you remember that? Just like a little hallway, like the live stream broke. Yep. Like, I think I lost your recording, didn't I? Yeah, it's lost media. It's lost media. That was my first time, yeah, you know. So thank you for not being annoyed or too mad by that and coming back. I appreciate that. So Elizabeth Baumel has been many things, but I know that a number one thing in terms of your profession is caring about graphics programming, for example. And your first talk was actually about how to make use and leverage multi-GPU setups, right? And how that works in places like with animatronics at, like, what was it, Disney World? Disney rides and everything. And it's fascinating, the work that you do. And these days, I even got it wrong on the website. You're not even a senior graphics programmer. You're a lead rendering engineer for That's No Moon. Love it. And yeah, Elizabeth's gonna give us a talk titled Programming is Practice Problem Solving. I'm very interested to see what you got for us. So a round of applause for Elizabeth Baumel. Sound room LH1.
Testing, okay. Hi. How y'all doing? Good, all right. Hi, I'm Elizabeth Baumel, and you may remember me from, my greatest hits. Good Times with the Pilot GPUs, that was the multi-GPU talk that's now lost media, but the slides are still up in case you want to check them out. You can teach an old programmer new paradigms, among other things. Anyway, today I'm doing something a little bit different. Normally I do like hyper, ultra prepared ahead of time talks, but I'm just gonna be up here doing bits basically. So I hope you like that kind of thing, in which case you're welcome. Otherwise, I'm sorry, I don't know what to tell you. So here we go. I'm not usually the type to start a talk with a quote, but I saw this on Blue Sky the other day and it kind of resonated with me, so. It is extraordinary that nobody nowadays, under the stress of great troubles, is turned into stone, or a bird, or a tree, or some inanimate object. They used to undergo such metamorphoses in ancient times, or so they say. Though whether that is myth or true story, I know not. Maybe it would be better to change one's nature into something that lacks all feeling, rather than to be so sensitive to evil. Had that been possible, these calamities would in all probability have turned me to stone. And so that was written in 1148. I mean, you could probably tell based on the wording and diction that it was kind of old, but like 1148 is older than I thought it was going to be. And why did I put this here? Well, the world has problems. We have a lot of these. The times are now. The times are bad. What will you do? That is the question, right? Like, political climate notwithstanding, the industry right now is kind of terrifying, right? Like if you haven't been laid off yourself, you almost certainly know somebody who's laid off. You definitely know at least like 2 degrees of separation, someone who's been laid off. And, the rise of, generative AI, especially like for someone in games, right? Like I'm a programmer, but it's kind of scary to see like, hey, we want to automate away a lot of people's jobs. And not to get down the whole Luddite hole, but, a lot of people are thinking like, wow, this is kind of a scary time to be in this industry, huh? So, given that the world has problems, what's this talk about? Well, problem solving, introspection, a touch of existential dread. We'll cross that bridge when we get to it. Crows, because I like them, and so now I'm going to show you some. Communication, touching grass. If you don't do that, you should probably try it. It's fun. It's good for you. And hope. All right, so I know we've already talked about me a little bit, but why you should listen to me, here it is. I'm lead rendering engineer at That's No Moon. It's a game studio, big AAA kind of deal. Our project is unannounced, so I can't tell you anything about it. It is a big AAA game. We're using Unreal, that's about it. And it's not Star Wars, despite the name of the studio. That's all I can say. Before this, I was doing rendering engineering at Epic. I did a bunch of stuff at Unity with the data-oriented technology stack. So you may have seen me do some data-oriented design talks. Before that, I was at a co-dev studio called Disbelief, and before that, I was doing graphics at PlayStation and drivers at Intel. My resume is now long enough that I don't need to get into all the details of every single one anymore. Basically, I do a bunch of triangles and graphics and GPU stuff. But whatever. I also do a bunch of other stuff outside of work that is maybe more interesting to some people. I draw, I play D&D with my friends, snowboard, garden, whatever. I'm a fountain pen enjoyer. I'm telling you all this because these all have something in common, and that is it's problem solving. But anyway, this is a programming conference. That's what y'all are here for. So what do we actually do as programmers? Think about your day as a professional or possibly a hobbyist, right? How do you spend it? You're typing on a computer, moving a mouse around. Maybe you're waiting for a build or a sync. Maybe you're reading code. Probably you're reading code, since I would argue that's most of what programming actually is. Maybe you're reviewing other people's code, testing using the code and the program that you're working on. I hope you're doing that, because I don't. Profiling. If you're not doing that, you should. All these things, right? Where if you were to meet some hermit in the woods who's never used a computer before, I don't know how you would explain what you do to them all day. What we actually do, right? The crux of it is we program digital electronic computers, and it's so easy to forget what that is, right? I mean, I don't have to tell you that computers can do a lot. Obviously, our world has been transformed by them. Information is a fundamental fact of the universe, if you've ever learned about or studied information theory. It turns out that automatically processing it a lot faster than a single human could do saves, us bipedal featherless animals a lot of time. Effectively, anything that can be modeled mathematically and represented as digital values in a digital computer, it's fair game. I'm not going to cover quantum computers. However, if you're going to program a quantum computer, you're still creating a mathematical model that's being simulated and calculated. It's just a different primitive at the bottom of the stack. At the end of the day, what a computer is doing, right? You're making a model, and there's the old adage, right? All models are wrong. Some, a lot, are useful. Speaking of models, here's a great example of a real simple one. Anyone know what this is? Turing machine, that's correct. At the end of, if you simplify everything that we do with a computer, right? We are defining our operands. These are the things that are read. Our operators are processing our transformation steps, and the outputs, right? The things that are written. And probably those are future operands, but maybe sometimes also future operators. It's kind of interesting, the language here, because input and outputs, you got input, processing, output, right? Processing, depending on how low level you're going, those might also include reads and writes, but if you're down at the instruction level, then you're talking about electronic implementations of, an adder or some other piece of an ALU. At any rate. So this is an example of, a little more complex example of doing everything I just talked about in the last slide, but it's for breakout. Basically, we're just defining all the pieces of this model, right? It's just a simulation. We're saying, you've got a ball and you've got velocity, and what kind of data are we using to model what breakout is? But it's all numbers. It's just shit we made up, right? It's here, we'll put this in the computer, and now we're hallucinating a ball bouncing off of a paddle and bouncing off of rocks or whatever, bricks. So anyway, what's cool about programming, right? Why am I even talking about this? It's a really powerful tool for solving problems, right? I would say a uniquely powerful one because given what you can do with a computer, the costs are shockingly low, right? If you want to program, you don't actually need much beyond a working computer and maybe an internet connection. And even then, you don't really need an internet connection. You just need a computer and power. It's not like a lot of other types of engineering where, you need physical supplies and tools, right? And probably a lot of people to do anything of any meaningful scale. I mean, if you're a civil engineer, right, you want to build a bridge. you need concrete and heavy machinery and a whole lot of workers and safety equipment and God knows what else. I'm not a civil engineer, so I couldn't tell you. But, or like maybe you want to build a car, right? You need a machine shop and metals and whatever. Or just even hobby projects, right? Like I used to be big into cosplay back in the day. I still have my fabric stashes and resins and a lot of other stuff that probably I should throw out, but I'm not going to because maybe one day I'll do it again. I don't know. But anyway, yeah, the nice thing about programming is like you can just do a ton of practice without like wasting supplies doing your early bad work, right? Like learning something that involves consumable materials and a lot of startup costs in the form of tools is really expensive. But learning how to program and programming and practicing programming is actually really cheap. So it's a great way to practice how to solve problems. Now, obviously you can't solve all problems with a computer. You can sure design a bridge on a computer, but we haven't yet developed robots that can build entire bridges. So until we do that, you can't actually use a computer to do that. So, is there a second slide to that? Have I been on the right slide? Anyway, okay, so speaking of problem solving, right? I'm sort of generalizing problem solving as an activity. It's not a uniquely human thing, which is pretty cool, actually. Most animal enrichment is just little problems for animals to solve, much like the ones that they solve in the wild. And problem solving can be a lot of fun. So this is Roadster, my buddy. This is a female American crow who lives on my street, and with her beloved husband Highball and idiot son Blorbo. We feed them peanuts. Roadster likes to come close, and we haven't started giving them puzzles yet, but sometimes we'll hide stuff under little plastic containers, and they'll have to find their food. She doesn't know what a computer is. She would probably be freaked out by one, and then once she realizes it doesn't hurt her, she would try and take the keycaps off the keyboard. Possibly would hide seeds in the keyboard. I don't know. I'm not intending to try that. It would probably be funny, but not with my computer. Anyway, she solves problems every day. She has to know where to hide her peanuts. She has to know where to find the peanuts she hid before. She has to deal with other crows encroaching on her territory. She has to tell her idiot son not to ask for food, because I did see him doing that last year in the winter, and I cannot believe this grown crow was like, "Mommy, feed me." And she has no patience for that. So at any rate, speaking of crows, I have another little video about crows right here. So if we could play that video, please. Yeah, so why did I show you that video other than to fill out my talk a little bit? Don't worry about it. The point was, right, tool use is fun. Solving problems is fun. It is something that us, we and other intelligent organisms have evolved to do all day, every day, right? And some problems, obviously, I gotta take the trash out. Well, that's not fun. But, puzzles, solving problems, there are harder problems that we get a lot of pleasure out of solving, after it's been a tough day. You're trying to fix this really hard bug and then you get it right and you're like, that's great. I feel like a god. Same thing with crows. So I've been thinking about this because, problem solving isn't just programming. And I've also been thinking big shocker at this kind of conference, right? I don't actually care about programming. The act of programming is not something that I necessarily enjoy doing. If that's something you're into, that's cool. But for me, I didn't get into programming until later in life, until I was in college, and I had a couple of false starts. So why am I programming? What do I care about, right? I care about solving problems. Programming is a tool for solving a certain set of problems, right? Effectively, low-level programming is the right tool for the job for the types of problems that I want to solve. So I'm a game developer, right? I've been doing game development for 10, 12-ish years at this point. I honestly, when I wanted to do, when I was getting into game development, I was a teenager and I wanted to do the art part of it, because I grew up drawing and painting and stuff like that. But my parents were like, "You're not going to art school, kid." I was like, okay, well, what else can I do? And, I've always had an interest in computers. So I felt okay, well, what do I do how do video games work? How do these things exist? And so I was like, oh, okay, programming, how do I do that? The reason why I got into game development in the first place is I want to make interactive art, right? The reason I want to make interactive art is because it brought me a lot of joy. And I want to bring that kind of joy to other people, the kind of joy that, I had the realization, right, that people make games as opposed to coming from on high, right? As a kid playing Skies of Arcadia in my basement. And I was like, I want to do this. This makes me really happy. I want to make other people really happy. So my point is, know why, think about why you solve the problems you like solving, right? And be honest with yourself. Do you care about the problems that you're solving? Why or why not? For me, I remember in school there were databases class. Ugh, God. I was like, I don't care about looking up some, table about customer data, whatever. And then years later, when I'm trying to come up with my own asset pipeline, I'm like, oh, turns out this was important. So caring about the problem you're solving is going to help you solve that problem a lot faster because you're going to have a lot more fun doing it. And fun is a good motivator, at least in my book. So, think about what you find interesting and ask yourself, why do you find it interesting? Kind of going back to the beginning of this talk a little bit, there are a lot of problems in the world to solve. What do you want to do with your limited time on this earth? Okay. Do you know what problems you want to solve, though? How do you figure out what problems you want to solve? Well, if you don't, here, let me offer you some ideas. There was a silly meme that I couldn't find. It was, a deep-fried JPEG, and it was somebody said something absurd on Tumblr and responded with something like, did you need to say that, right? Was it true? Was it necessary? Was it kind? But these are actually good questions to ask, I think. So I was like, I think that actually applies to figuring out what kind of problems you want to solve, right? Is it true? is it actually a problem, right? Is your problem unsolved? And that doesn't mean that like no one's ever solved it before. It's like, is it a problem that you actually like want to solve? In which case that is a problem that is worth solving. It's unsolved to you. Is it necessary? You know, if it's unsolved and you don't particularly care whether or not it's solved per se, does it need solving? Is more the issue that this thing is annoying you and you don't want to deal with it, but it's got to get done? Or is it like something that is actually worth doing because it would improve iteration time or something in your life, even though you don't really want to do it? It's like, well, you know, this would save me a lot of time if I did it. Okay. Is it kind? If you solve this problem, does that increase net happiness and reduce net suffering in the world? And this is sort of a bigger question where you think about, you know, do I want to work on certain types of products? Do I want to work at certain types of companies? Is, you know, the fun I have doing this type of work actually good for the world? Do I feel good about that? And then, of course, even if you have an answer for the rest of these, am I having fun? Even sometimes when I'm working on games, you know, even though like I'm technically living the dream, right? There are days that are not fun. You know, fixing cook errors, right? Like, oh God, I don't care about this one shader compilation error. Can I just please do my job, right? But sometimes you get to work on like a fun, cool new feature. I'm like, yeah, this is amazing. And that makes it worth it. You know, everything's a mix of things. But, you know, as you're thinking about the problems you solve or want to solve, right, keep asking yourself why. You ever met like a kid, like I don't know how old kids do this at, but, you know, like a 5-year-old, I don't know, and you're talking to them or whatever, and they just go, why? Every time you say something, they go, why? Why? Until eventually you get to the point where you're like, oh, I don't know. And you know what? That's a valid answer. If that's uncomfortable for you, once again, you should ask yourself, why? It's okay to be uncomfortable with not knowing the answer to something, you know? It can be a sign of growth, but you must introspect. You must think about, why is it that I feel bad about not knowing this? Or, you know, why? It is always morally correct to ask why. And I'm going to beat on this a lot. I don't know is a valid answer. There are a lot of people out there who, instead of simply saying, I don't know, will make something up. It's an instinct, and I think it's driven into a lot of us through, you know, school, family, whatever. You know, people say, oh, I don't know, that's not a good answer. How do you not know? It's like, well, I don't know. What do you want me to tell you? So let me ask you this. Why do you program? I'll give you a few seconds to think, and then I want hands up. All right, I saw a hand back there. Why do you program? To keep certain complex things alive. Why?
Some good things go away, but not because they're bad.
Why? Some things go away that are good. Why?
The universe breaks things down, and some things in the universe are good.
Some things in the universe are good. Okay. Let's get another one. Okay, I saw somebody over here first. You. Yeah, you.
To make enough money to live comfortably.
Okay, you program to make enough money to live comfortably. Why? Like, why programming specifically?
I liked video games when I was a teenager, and I just kind of picked it at college, sort of, not randomly, but because I liked video games and wanted to be around them.
Okay, because you like video games. Why?
It was a social bonding experience with people that I trusted and cared about, so, yeah.
Social bonding experience. Okay.
I could do a few more if you want to with the microphone.
Oh, yeah, that's probably better, actually.
Number 4.
Get people, hey, love
Yep,
it.
it works now.
Somebody was raising their hand over here. Go ahead.
Testing. Some software protects people's rights or gives them the agency to avoid software that does not respect their rights.
Why?
Because people are making software that doesn't respect people's rights.
Why?
That's a bigger question than I'm going to tackle.
Okay, I see your hand back there.
Because I like it.
Why?
It's satisfying to solve problems, and it's satisfying to understand how things work, and it's satisfying to look back on the things that I've attempted to do and recognize that I have skills now that I didn't have in the past.
Okay, let's do one more.
Down there, here I go.
Yep.
Because it's something that I can do no matter my, even though I have, some physical things or limitations, I can still do programming, and it's something that I latched onto when I was younger because of that.
Okay, let's dig into the why did you latch onto it when you were younger part.
Because I never really felt like I was good at anything my whole life, and I got my first laptop when I was 14, and everyone's heard this story, sorry. But I think I wanted to make my computer hibernate with a desktop shortcut, and that introduced me to bash scripting. And it was something that I could just do, and it didn't matter if I screwed up, nothing bad happened, nobody yelled at me, it just didn't work, and I would just try again.
Okay, cool. Yeah, I think that's enough interrogation of my audience.
I can mention a couple from the chat too.
Oh, there's a couple from the chat?
Yeah. Real quick. So stressing to answer why. To make the world, this is Margaret, to make the world a better place for myself and everyone in it. Somebody also said, because dopamine is a hell of a drug. We can stop there for now.
All right, yeah, dopamine is a hell of a drug. Turns out you need that to live. Surprising, I know. Okay, that's why, individual people program. So why program, actually? Maybe it's a silly question to ask everybody here, because we all have our own reasons. We all obviously like it enough to either do it professionally or, come to this conference, right? But, if computers disappeared or were no longer the impactful things that they are now for whatever reason, right? Like, why do it? It's actually a really good practice for just problem solving in general outside of a computer. So the nice thing about programming is you have to work within a set of constraints. Now, this is a little bit informed by my data-oriented design background, and some people may argue with me about this, but if you're coming at it from like a low-level programming perspective, like the smaller the piece of hardware, the more constraints you have, and the more constraints you have, the more kind of assumptions that are imposed upon you. And there's an old adage that goes something to the effect of, limits make for better art. There's also like necessity is the mother of invention, right? So constraints can actually be really freeing in a way, because it means you don't have to make those decisions. Those are made for you, so you don't have to think about that any longer, right? Maybe not the best example, but if you're working on a game, you want to hit 60 frames per second, you have 16 milliseconds to finish rendering your frame. If you're looking at some, very complex rendering method, and that takes longer than 16 milliseconds, you can't use it, full stop. You just can't do it. End of story. You don't even have to look about it or think about it any longer. Even more generally, even though we think of there being a lot of unknowns in a lot of computer systems, and sure, there are some real unknowns, there are actually not that many real unknowns in a lot of ways. Like, what input you're getting, right? You have data coming into your program. You have data coming out of your program. The data within your program, maybe you don't have a good way to, profile it or look at it. And, that's a whole other talk about, like, why the tools we have available to us are maybe not so good. But all that data lives in memory somewhere. I mean, unless you've got some kind of weird situation where like solar radiation on your spacecraft that it wasn't hardened well enough is fiddling the bits unexpectedly, that's a different situation. But for the most part, you know what garbage is going in, and you should be able to figure out why the garbage is coming out as that garbage. A lot of other types of problems, not always so conveniently constrained. So let's talk about something, a type of problem solving. How do we apply this to something that is a little bit more soft, a little bit more complex in a lot of ways, not constrained in the same ways, but still actually relevant to your day-to-day lives as programmers? Probably you work with other people. If you're going to work with other people, you have to be able to communicate with them. And it's impossible to read people's minds. So you have to figure out how you're going to communicate what you want to communicate to other people by expressing yourself. You have to be able to understand what other people are telling you and when they're expressing themselves to you. Giving feedback is one of these things when you're iterating on something, you need to be able to do that effectively. And sometimes there's a lot of emotions involved there, and that sort of introduces another layer of complexity. Receiving feedback and integrating feedback is sort of the second half of that. And then simply asking and answering questions is like a skill unto itself. And then, of course, learning is this is sort of a separate thing, but we'll get to that. So this little diagram here that I've put is a little thing from information theory, right? So the idea is like, if you have some message, right, you have some information you want to convey to someone, you have to encode it in some way, send it over a channel, and then there will probably be noise on that line. But assuming you can get it to this decoder and out to the other side, the receiver should be able to have the same information that started at the beginning of the pipe. If you have the right, channel and noise correction and all that. Anyway, when you're expressing yourself, when you're communicating, right, it's about exchange of information, and when you're communicating with somebody, you do have to have an objective, right? Like, sure, it's fun to just kind of like say words at other people in Discord or what have you, but like, usually at work, there's a reason that you need to talk to somebody else on your team, right? So, what do you need to tell somebody and why? What is my objective in talking to this person? And how do I convey what I'm trying to tell them in a way that has the least noise in it? So this is, if you've ever read Strunk and White, this is something that my dad used to give these out to like new hires, or I think maybe he still does. But anyway, my dad works in telecom. The like one biggest line from that book that like if you take nothing else away from it is vigorous writing is concise, which is clipped off at the end there, which is probably poetic in some way, but so that's sort of communication in a nutshell, sort of. But let's dig into expressing yourself, right? Before you can even give this information to somebody else, do you actually understand it well enough to convey it to somebody else, right? If you do, how do you know that they have decoded your message properly? And if you don't understand it well enough, how do you get to the point where you can actually encode that message and get it to somebody else? So these are all questions you need to ask yourself, right? Like, think about some complex concept and think like, okay, where are my holes in knowledge here? If I feel like the edges of what I understand about this are very small or far away, I can probably communicate this generally to somebody else. Like maybe you're working with a junior programmer and you're trying to explain the concept of like a command queue, right? And you're like, okay, well, you get like a command, command packets, you put them in the command list, and then there's sort of like why do we do this? It's, you can, whatever, I'm not gonna get into this right now. You probably know this already. And then to understand Whether or not they've communicated it well, you need to validate with them. And that's sort of the next piece here. Given the input that you receive from them, this is sort of a loop, right? How do you know that they have given you the information? How do you know that you have the same understanding, right? The more complex the message that you're trying to send and receive, the harder it is to decode it, and the more likely that noise is going to get in that message, which is why it's also good to say like vigorous, why I keep saying vigorous writing is concise, right? Like people have a limited attention span. Some people have better reading comprehension than others. You want to make sure that you're giving just enough information to get your point across, and hopefully you're getting just enough information from them to understand them. But if you don't, then you need to kind of ask questions, right? Say you've got their message and you think you understand it, so you can, say it back to them, and hopefully you can express your understanding well enough that it's kind of a weird like hall of mirrors things where you've got it, bouncing back and forth infinitely, but we do have to have that signal collapse at some point. So let's sort of talk about giving feedback. This is sort of a form of interpersonal problem solving, right? Like we've talked about the problems of, sending and receiving information. This is sort of a next level thing, right? When I was at Unity, I did this like leadership training thing. And this is actually one of the most useful things that I learned when I was there, is, if you need to have a hard conversation with someone, or maybe it's not even a hard conversation, like you can use this for, praising somebody, or just like talking about a thing that happened and it's not really anybody's fault. So the format is basically you state a fact. This is a true thing that happened. If something made you feel a certain way, the way that you felt is actually a fact. So to give you an example, let's say someone was, let's say somebody was misgendering me. So I use they, them pronouns. And it's someone was consistently misgendering me, right? Like maybe I have evidence of it in chat, or just like everybody's seen it happen in a meeting or something. I don't know, I'm not saying that this actually happened, but like here's an example, right? And the impact doesn't make me feel so good. Or actually that's part of the fact, right? Someone's misgendering me and that makes me feel not good, and the impact is maybe it's distracting, right? And then the question is I would say that coming up with the question for feedback is the hardest part, because especially when it's sort of like a hard conversation kind of thing, it's really hard not to make it pointed. So I just came up with this example like out of my ass right now, but honestly, I think that probably, even though it sounds pointed, asking the person why they keep using the wrong pronouns is probably, it's open-ended, and they have to answer the question. So a more fun example is, maybe someone you work with is doing an amazing job, right? Like they're just banging everything out. They're doing so much amazing work, and you're like, oh my God, this is great. You can say like, hey, you did this amazing write-up on strand-based hair rendering, and it was really helpful, and it helped us figure out like what we can actually do on this project. And so I basically did, you did this write-up on strand-based hair. It has helped us figure out, that's the fact. The impact is, hey, now we have a better idea of what we can do on this project. The question then, and this is once again the hard part, an easy kind of cop-out, I would say, is like, how do you feel about all this, right? But, maybe my concern is like, maybe to me, like they're doing all this work, is that sustainable, right? Like, how do you feel about how much, because I want them to keep it up, right? Like that's the problem that I'm trying to solve, is like, I want them to know they're doing an amazing job. Please keep doing that. But also like, don't burn yourself out. So that's the giving feedback. And then there's the receiving feedback, right? Like say someone does one of these fact impact question things with you, right? Sometimes you'll go through one of these things and it'll be totally surprising to you. You'll be like, oh, I had no idea I was doing that, right? Like, I don't know, maybe someone comes up to you and is like, hey, you're bouncing your leg all the time and it's really distracting to me. Is this something that you're able to stop doing? Maybe it's something that's you don't even notice you're doing it. And you're like, oh, I didn't realize, I'm sorry, right? Or, you know, maybe you have a different example of like, hey, I noticed, you know, you always have this kind of interesting glow in your artwork, and I think it looks really atmospheric, and I would like to emulate that. How do I do that? And then you'd be like, oh, I didn't even realize I was doing that, right? Like, and then you realize maybe they have weird monitor settings, or maybe they have weird, I don't know, they're doing something with their brushes. Maybe their understanding of the whole thing is different. Maybe they're like, oh, I don't even like that. I don't know how to make myself stop doing it. So that's kind of like, the question is to strike a discussion so that you can kind of understand what problem you want to solve, maybe a problem that this other person wants to solve, maybe you need to solve a problem together. In the event where there's kind of, it's a hard conversation or like feelings are involved, right? Feelings can seem like noise, but they're not always noise. So you should ask yourself, why do you feel those feelings? Because discomfort can be good, even though it feels bad. So I sort of covered this a little bit already, but yeah, it's like, okay, once you've agreed on the problem to solve, you gotta figure out like, okay, here's what we're gonna do about it. Here's what we wanna have happen. You know, SMART goals, whatever, you've probably heard of these before. We don't wanna be loosey-goosey about it, right? We want specifics. So the crux of all this is like, when you're doing problem solving between people, you want to have specific plans for what you're gonna do, how you're gonna do it. They have to actually make sense, right? Specific, measurable, achievable, relevant, and time bound. Like, so I want this to, you know, this pattern to stop, you know, within the next couple of weeks, or with, you know, now, right? Like, do not do this again, or like in the next month. I don't know. I don't know your life. So the next thing, and this is something that is close to my heart, is asking questions. So when you go to ask a question, right, you have to actually realize that you need to ask the question. And sometimes when you're earlier in your career, you have no idea what's going on, right? You're like, I don't know enough to ask a question. I don't even know what I know. I don't know why I am here. I can't believe anybody let me in here. You know, but if you can set aside the panic for a moment, think about like, okay, what do you actually know right now? Maybe write that down. I don't know. What information are you missing? What do you need to receive? Maybe you don't know the answer to that question. What is your objective, right? What are you trying to do? What problem are you trying to solve? And if you just don't know, right, if you're totally lost, going to somebody else and saying like, hey, I'm completely lost, this is what I have to do, like, please help, do that. It is better to ask for help and risk looking like an idiot than sit there and suffer in silence. Ask me how I know. And then on the reverse side, you know, answering questions, right? Somebody comes to you with a question. Maybe it's a complex question. Think, what do you know about this question? Do you have all the information to send that this person is asking for? What if you don't know the answer? Or what if you don't know the complete answer? It's okay to not know things. Just don't make stuff up. Don't do it. If you feel the need to provide a made-up answer, simply do not. And ask yourself instead, why do you feel the need to do that? I don't know is a valid answer. I don't know can also be, you know, it can feel stressful in a situation where like, oh my God, I'm supposed to be the expert on this. How is it that I don't know the answer to this question? I don't want to look like an idiot. But like, I don't have the entirety of the DirectX API in my head. I'm not going to tell you like, oh yeah, that's because of the resource binding tier thing here, though that was actually something I knew off the top of my head one time. So maybe that's not a good example. But anyway, some API minutiae. If you can say like, I don't know, I can go look it up, I'll find out for you. That's fine. Most reasonable people will accept that as a perfectly valid answer. And if they don't, I don't know what their problem is. They need to chill. But, for sort of a greater I don't know problem solving thing, right? Like maybe this isn't even question and answer anymore. It's like, wow. Why is there so much dark matter in the universe? What's that about, right? Sometimes I don't know is really exciting. It's like, oh man, I want to find out what this is. You get to go find out. That's fun, right? Or maybe you're working on an art project, right? And you're thinking like, okay, I want to achieve this particular look. How am I going to do it? That means you get to experiment. You get to play around and have fun. It means you get to learn some stuff. Maybe it's about asking and answering questions from other people, but it's also fucking around and finding out. So, yeah, problem solving can be a lot of fun. It doesn't just have to be like, work stuff, working with other people, trying to, clean up the world's messes. It can just be, using your stick to get the little snack out of the tube. Low stakes messing around and, low risk of failure, you can learn a lot. And that's actually the best way to practice. So I used to draw a lot more, and I still draw sometimes, but, at some point, people kind of like, you start to develop standards for yourself and you kind of freak yourself out and you're like, oh, it's not good enough. Oh, I'm not good enough, right? So I got into gardening, I don't know, a few years ago. I'm just screwing around. The soil at my house is kind of, it's sort of silty and like, it's thick, right? So I just planted a carrot randomly in a spot, and I was like, well, this will probably break up the soil here. I don't know. It might not grow at all. Who cares? I actually transplanted it because I thought, well, it'll probably die. If it doesn't, well, cool. This carrot ended up being 0.5 kilogram. I made 2 carrot cakes, 2 of them. So sometimes fucking around and finding out is actually really rewarding. Okay, that's it.
Bravo. Bravo.
Thank you.
Since we did audience interaction, I'm going to count that as your substitute for Q&A.
Okay.
I hope people still ask you questions here in the chat server or talk to you in person. Are you going to be around?
Yeah, I'm around.
That's amazing. That way I'll be back on schedule here. That's my fault, not yours. Thank you so much. One more round of applause for Elizabeth Baumel. That was really fun.
I'm glad you enjoyed it.
Yep, I got you. All right. Yeah, I'll just put this back on the Fireside chat situation here. Perfect. All right. Oh my God, I can't believe it. We're going to be doing a couple of demos, and it's the end of the conference. I'll give my closing notes very soon. I'm going to get emotional. It's been a wonderful week so far. So, yes, is Mason here? Can you raise your hand? You here, Mason Remaley? Yeah. Awesome, thank you. So this next demo is from the person who gave the talk yesterday about the Vulkan. You remember? It's not about the API. Independent game developer Mason Remaley, who is one of the folks at Handmade community who has, shipped a game, like completely production ready, beautiful game. And I kind of want to play that trailer. And after we play that trailer for that video game, you're gonna see like 10 minutes tops of interview style, like I did with Freya earlier, just like 10 minutes tops, so you can learn more about how Way of Rhea was made. And I avoid fancy slides or fancy videos during that interview because we do go low level sometimes, and I want us to like pay attention to that. But then after that, we'll do some Q&A with Mason right here on the Fireside chat, and then after that, we'll do our final demo for the day. Crazy, crazy. So yeah, round of applause for Way of Rhea by Mason Remaley. Mason, thank you so much for joining us at Handmade Seattle today.
Yeah, thank you for having me.
Now, Way of Rhea, I was just calling it a hard but forgiving puzzler game. And I wonder if you can tell the audience what I mean by that.
Yeah, so I've always been a huge fan of puzzle games. And I think there's a core tension in the genre sometimes where you'll have a puzzle game where it has a really fun, engaging, interesting puzzle, and you figure out the solution, but then it's a platformer and you don't quite make the jump. Maybe it involves pushing blocks around and you realize, oh, that was wrong, and then you have to start over. And the issue is that this is frustrating, right? If you're playing an action game and you have to redo a level, that can be fun because redoing the same action sequence multiple times can be engaging, but resolving a puzzle that you already know the solution for is drag. With Way of Rhea, while the puzzles are hard, inputting the solutions to the puzzles is easy. And if you make a mistake, you can always undo. If you don't want to wait for a long action to complete, you can always fast forward, etc.
That's amazing. Is this your first officially shipped game?
Yeah, I've built like little things for fun, and then big things that I never finished. This is the first title that I'm actually shipping.
The art, the music, everything is gorgeous. The gameplay is solid. Just want to say congratulations. Can you also explain to the audience what you mean by custom engine?
It's like tough to like nail down exactly what a game engine is, right? I'm sure we all know, but the way that I look at it is a game engine is the code that is game independent. So like the renderer, the physics, and then maybe some game logic if you're making multiple games in a similar enough genre. For me, iteration time is really important. I like building engines and I have the time to do the upfront investment, but when I'm actually working on the game, I really want to be able to iterate quickly. And a lot of existing engines don't really check my boxes here. For example, a feature that really helps me iterate quickly is hot swapping. And while most off-the-shelf engines claim to support hot swapping, they typically really work in practice. One of the features my engine has is that you can edit any of the game code, including UI and physics and stuff, while the game's running, and maybe 80 milliseconds later or so, you see those results in game. I spent a lot of time getting all that stuff so that when I was time to focus on designing puzzles, I could focus on that instead of being distracted by waiting for it to reload or trying to get back to the save point, etc.
What about the split between, if somebody is talking about making a video game these days, there's some classic terms that they're going to use. Oh, like this is the engine, but this is the gameplay programming. How long did it take for you to flesh out an engine to the point that you could do gameplay programming? Or do you even not adopt these terms? Like, do you blur the lines between making an engine and gameplay programming? Is it all just one big giant soup to you? Or like, how do you go about thinking about this stuff?
So yeah, I'm happy with the final result, but I don't think I drew the line in quite the right place. In Way of Rhea, I put as much as possible into the gameplay code. This is partly motivated by the fact that my gameplay code can hot swap and the engine code can't. If I, for example, put the physics engine in the gameplay code, then I can iterate on it quickly. So that's what I did. But it was also motivated by this hypothesis that for a game that isn't technologically complicated, the engine should be minimal. It seems pretty reasonable, but I would say having done it, I have now changed my view on the responsibilities of an engine. And I think that even for technologically simple games, you really want the engine to be powerful and featureful so that when it comes time to try out new gameplay features, you can try them out quickly and easily and then discard them if they don't work. So for my new engine I'm building for my future games, I am starting out with a lot more built into the engine upfront.
Interesting. And what about reusing components, or I'm not sure what to call it, modules, libraries, or like reusing parts of your old engine for the new project? Is that going to happen? You just said new engine, right? Which is interesting. That almost sounds like you're discarding the old one. Are you actually discarding everything?
The hope was that I would use it for multiple games. The issue is that because I put so much in the gameplay code, it's a bit of a pain. Now, obviously, I can take algorithms and stuff that I learned and easily port them over, but I'm not going to be taking over a lot of code. I also took this as an opportunity to switch from Rust to Zig. A bunch of stuff is changing now, but I am building a much more, I'm not trying to build something general purpose on the level of Godot or Unity or Unreal, but it's much more general purpose than what I built for Way of Rhea, and the goal is to use this for all my future games.
I'm assuming you do feel like you're iterating and being more productive in a faster way than you were with your first game, or am I wrong?
Yeah, so if I look back at like how long it took me to build the first engine, a lot of it was just spent learning things I didn't know. I'm getting pretty close to the functionality I used to have in a small fraction of the time. I already learned all the hard lessons. I already figured out a bunch of the APIs and stuff. And then there's some things that are new, switching from OpenGL to Vulkan, for example. But that was going to happen eventually either way.
I also have a question around the timeline for the first game. I'm assuming this was a multi-year process, right?
I started Way of Rhea as just like a game jam game in 2018 with some friends. We actually signed up for an expo to show off the game without having made the game yet. The expo was starting in a week, and we told them we'll have a game in a week. So we built the game and showed it at the expo.
I love that you mentioned this jam, because we have handmade jams happening all the time, and I know they're awesome, but I had no idea just the extent at which they can create a lot of value, because a jam entry can become somebody's next successful, often commercially successful project, or like their life's ambition. Like we've seen that happening a lot in Handmade. There's some truth to that with Way of Rhea too, so I just wanted to put that out there. You guys should be doing more jams, okay, people? They're awesome.
Yeah, a point that I would make about jams is like they're really good for getting you started on something, but you want to have it be a conscious flip when it stops being a jam and starts being a project. With Way of Rhea, if I knew I was going to be serious, I probably would have picked another genre. I like a lot of different genres of games, but I just, I was like, oh, this is what I happen to be working on, and I just kept doing it. So I think jams are really great for getting started, but I think you gotta, like, when you decide to switch to being serious, you gotta, okay, now that it's serious, do I need to reconsider anything about this project?
When you mentioned switching from Rust to now Zig, right? And you've tried languages that the majority of the Handmade audience, although that's been starting to change, but majority of the Handmade audience still sticks to things like C, and if they could do assembly, they would all the time. We've seen some changes in the last few years for sure. Some indie developers in Handmade are switching to Odin or Zig, Jai, for example. Rust, not as much, but we've also seen some Rust. And you've tried Rust in a very serious way for a game, which is something that many people have wondered about, how that might feel like to use Rust for a video game. You're actually one of the very rare cases where you've actually successfully shipped a good game using Rust. And now it sounds like you're gonna make your next, hopefully successful game using Zig.
Yeah, so I guess the first thing I'd say is I understand why people feel nervous about switching away from languages that are well established, like C++, right? Like you look at what industry is doing and you go, they probably have a good reason, right? But I think that you need to consider what those reasons are and whether they apply to you, right? Like if you're a big AAA company, then you have a big workforce that already knows these languages, and you have a big code base already written in these languages, and switching to a new language, you better be getting a lot for that, because it's going to be a lot of work. And look, it's going to happen. It's going to take a while, but it's going to happen. But like, it's not a surprise that you're not seeing people just throw out their engines and rewrite them. But if you're like an indie studio and you're writing something new from scratch, you don't need to be that conservative about it. The reality is all these languages compile down to x64. C, it's a low-level language, but it doesn't map to how the CPU actually works, right? Like C has its own kind of high-level idea, like the kind of abstraction of what the CPU is, and you're programming that, not like the CPU. And yeah, you can drop down to assembly, but like, we've been doing that for a long time. And so when people make new languages, they realize, hey, what if we made those things easier to do? So yeah, I think that if you're considering what language to use, you should really look at the languages themselves and whether they enable you to do the things that you want to do or not.
Round of applause for Mason Remaley.
Be a puzzler too, or is that something that you're not going to reveal anything just yet?
Come down here, Mason. Where are you? Let's do a quick Q&A. That's going to be fun. You can come down here, and I'm already seeing, of course, Rust and Zig related questions. Get ready. This is going to be interesting. Let me make sure that the switch is on number 1. Testing, 1, 2, 3. Perfect. Thank you very much. Okay. Once again, congratulations on literally shipping a game. It's now out on Steam. Well done. That was just, yes. The first question comes from Holmér, who says, "Ooh, a switch to Zig from Rust is fun. I'd be curious to hear your thought process on why you made that switch."
Yeah, so when and I mean, I think everyone knows because of the talk yesterday, but like full disclosure, I'm on like the Zig board. I don't want anyone to be like, he's just biased because he's on the Zig board and he didn't admit it. Yeah, when I started on Way of Rhea, it was super early days for Zig still. I wasn't aware of it. And I was like looking at my options, and the options I was aware of at the time were like Rust, C, C++. And to be honest, I was being very conservative, and I was like, well, everyone makes engines in C and C++, so that's what I should do too. A friend of mine, Juliet, shout out if she's watching this, was pestering me to like try Rust, and was like, check out this new language, it's super cool. And honestly, like I was like not interested, and I got really mad at CMake one day. And I was like, you know what, I'm gonna take a break from the C++ stuff and just like read the official like Rust book, which is like free online. And I was like, oh geez, like in a language with a build system built in, and like a unit testing suite built in, and documentation generation, and like, you know, algebraic data types, or, you know, tag unions. I was like, this looks great, and just like was persuaded that like, yeah, we can make better languages than C and C++. So the switch to Rust wasn't necessarily that like I liked Rust in particular. It was more like I liked not doing. I mean, and I do like Rust. I think it's a good language, but I was like, I like doing. I like using languages that I've like, you know, learned a little bit since we designed those other ones. So, you know, then Way of Rhea, you know, it was a hobby for most of the development, and it was under development for a long time. So, you know, wrapping up Way of Rhea, you know, there's a lot more options to pick from, and I felt that Zig was just much better suited for the types of work that I want to do. In particular, I would say having, you know, being able to pass allocators around. You know, Rust kind of expects you can do whatever you want, but Rust expects you to use a single kind of global heap allocator for everything. Whereas like in engine code, you know, I really just kind of want to be bump allocating into some arrays of fixed sizes most of the time. And like, you know, I could do that in Rust, but I'm cutting against I'm kind of swimming upstream if I do. That combined with the unsafe portion of Rust feels kind of poorly specified to me. I'm never really sure if what I'm doing is correct. And, you know, I got to talk to Vulkan, I got to talk to low-level OS APIs. So I'm going to be using that part of the language. And on the flip side, Zig is very good at that stuff. You know, they have much better pointer types than C. You know, you really just kind of can do all your little bit fiddly stuff and be confident that you're doing it right. You get things like alignment built into the pointer type, you know.
That was one of the questions, by the way. How many unsafe blocks did you use in Way of Rhea?
I definitely didn't shy away from it, but also like, I think it's like I'm torn on this, because on one hand, I think that a lot of Rust people are kind of too obsessed with safety in contexts where it doesn't matter. Like, don't get me wrong, there's situations where you really want safety, right? But there's also like, you know, you're making a single-player video game, and like, it's, you know, it doesn't really matter too much unless it makes you more productive. So I'm definitely not in the camp of like everything needs to be safe all the time. But on the flip side, I also think that like the borrow checker isn't as much of a pain as a lot of people who try Rust like for a day seem to think it is. And I think that once you mess around with it a bit, you're like, well, okay, yeah, as long as I know who owns what, it's not like a huge deal. So I used a lot of unsafe blocks, but it wasn't so much to like work around the borrow checker as it was to, don't get me wrong, it is restrictive. It's a type system. You know, the more type systems you have, the more restriction you have, right? But it was mostly because I was like talking to C or talking to the operating system, and yeah, I do a lot of that, so it was a lot of unsafe.
And somebody asked, how was the experience of porting from Rust to Zig, and what difficulties did you face in the process? Although if I can, it sounds like you did discard.
Oh yeah, no, it's not a port.
It's not a port. Interesting.
So yeah, Way of Rhea shipped with like, you know, mostly Rust code and and a lot of lines of code and like a scripting language I wrote in Rust. I actually used Zig as like a build system for parts of it. But like, yeah, Way of Rhea was just like Rust mostly. And then my new engine, like I'm definitely taking ideas from the old engine and stuff, but it's all new code. I don't know, like the other day I like wanted to port my texture tool. I copy pasted a struct definition for like the DDS header, but like, I don't know, that's not really like a real port. I could have just copied that from the Microsoft documentation if I wanted to.
What did you like the most? Programming, designing puzzles, or doing the art, since you did, you know, so much?
So I didn't do the art. Carolyn Whitmire, super talented artist, did the artwork. I don't want to take credit for that. That part was fun since I didn't have to do anything and just great art showed up on the screen. especially because I'm used to trying to do the art, and like I enjoy doing visual art, but I'm not like a trained visual artist. So it's really cool to work with someone who is, and then just like have things come out that are better than my vision would have been for it.
Yes.
Yeah. So between like puzzles and game design, I don't think I can pick a favorite. I think for me, I really enjoy making things for people. And so, like, making puzzles, it's, to me at least, and maybe there's other ways to look at it, to me it's all about thinking, like, okay, like, what is, like, the core, like, little trick that I want someone to figure out? Like, what's the thing that they didn't think of that I want to demonstrate with this puzzle? Like, what's the little twist where it's, like, it's a self-consistent, like, it's a consequence of the rules that you might not have thought of that you need to figure out to solve this puzzle, and then how can I kind of, like, not hold your hand and tell you the solution, but give you something where you will eventually find it. And so I'm thinking about people, but it's like kind of the same thing when I'm programming, right? Like if I'm building like an engine tool, the people might just be me, but I'm thinking about like, how am I later going to use this tool to make a game? Or how is this going to run on the player's computer? And I think I just really enjoy building systems to give people experiences. And so I like both parts a lot.
How do I get more into puzzle games? They've never been my thing, but I want to approach handmade folks' work with an open mind.
Yeah, it's tricky because, like, I would say, like, a big problem with puzzle games, right, is they're really fun until you get stuck, and then you're like, oh, all right, I'm done now. I would say, first of all, like, if you pick there's some puzzle games that are just really good, but also if you're not really playing puzzle games a lot, you might enjoy puzzle games that was not a half answer. First part, there are some puzzle games that are like really, really high quality that you'll get recommended over and over again, and check those out first because it's easier to get into the genre with those like really popular ones, like Baso, right? Like it's kind of hard, but a lot of people love that game. But also, if you pick a game that isn't forcing itself to be linear, then when you get stuck, you can just try out other puzzles. Some games you have to solve a puzzle to move on. Some games let you try out, different things. So if you play something like The Witness, it's more open world, right? So I would recommend looking for some games where you can just play other areas when you get stuck. But also, if you're just not into it, you're not into it. You don't have to like something you don't like.
Where's the curated Mason list of games that they should play? Put it on the chat.
I can name a few off the top of my head. Portal is one of my all-time favorite games.
Portal.
It is actually pretty linear, but it's just like really, really well designed. So I think if you haven't played it, like play it. That was probably what like inspired my love for puzzle games as a kid. I like The Witness a lot. Baba Is You is great, and Talos Principle is really good. It also gets hard, but like you don't even have to finish Talos Principle. I actually don't think I ever finished it, but I just really enjoyed running around in that world and trying out new games. I'm trying out new mechanics, new puzzles. So that'd be a few games to start with.
If I may also add to that, you can also play games that aren't strictly puzzle genres, but that game has some puzzles sometimes. That could be as interesting. Like Tears of the Kingdom, the latest Zelda game, has some puzzles going on here and there. Next question. When did you know the game was done?
When the release date arrived. Yeah, no, I actually was sneaky and I didn't set the release date until it was secretly done because I didn't want to have to crunch last minute to finish it. I set the release date when it was done, and I set it for 2 months after it was done, or maybe it was a week away from being done. Mm-hmm. So I watched a Hank Green video that I really liked, and I can't remember exactly what the phrasing was, but the gist of it was I wish I could remember if it was in the talk I would have got the quote. But the gist of it was at some point you just have to put stuff out there because you can keep polishing forever, but you get these diminishing returns, and you just if you put something out there and you move on to the next thing, you can take everything you've learned and you just automatically have leveled up. So I got to the point where obviously there's always things to improve, but I got to the point where the things that I would want to do to improve it would just basically be making the whole game again, and at that point, just make another game.
Right. I completely understand that.
And I'm not saying you have to wait until you get to that point either, but I'm just saying if you're at that point, just put it out there. Don't keep delaying. I also just had some ideas around I knew what amount of content I wanted to have in the game, and I hit the mark where I had that much content, and then I was like, all right, I'm going to do some polish, but the content's there now. If I think I should have better content, then that should be a different game.
It is my understanding that the switch to Vulkan occurred sometime in the middle of developing Way of Rhea. Was there a particular experience that finally precipitated that switch?
Oh, good question. But no, I actually shipped Wryl with OpenGL. So yeah,
So your next project will probably be...
Yeah. So I developed
Okay.
Wryl with OpenGL. When I started it, I guess I don't remember what year Vulkan was actually like announced in. I think it was available, but it was like very much newer at the time. So when I started it, I was like already familiar with OpenGL, and I was like, yeah, this is what I'm going to do. But it's like, it's been a long time. OpenGL is still supported everywhere, but these new APIs are just like more and more relevant. And so during development of Freya, I started looking into Vulkan, not as like a thing I wanted to switch to, but as a like, okay, like at some point I'm going to make this next engine, or even if I kept using the same engine, I knew I maybe would want to switch graphics APIs. So yeah, I didn't actually have to port, thankfully. I think that porting OpenGL to Vulkan it's like this weird thing where like Vulkan has, like I went over in the talk, right, like that there's all these features that you don't necessarily need to use, and I kind of suspect that a lot of them are there to make the porting process easier, which is great in a way. But the thing is, if you program Vulkan that way, then it's also very complicated. And so I think it would have been very painful to try to port Freya to Vulkan. And it feels really nice just being able to do a clean break and kind of do things in the simple way from the beginning instead of having this weird intermediate step where everything's very complex.
You've probably learned a lot about game engine development while making this game, and I want to hear all that. But I'm maybe more interested to hear what you have learned about shipping specifically that will probably help other people who want to ship things.
Yeah, so first, very short answer. I gave a talk at Software You Can Love called It's Not About the Technology, Game Engines, or Art Tools. If you want to learn more about my thoughts on engines and what I learned about engines from building the Freya engine, that's like 45 minutes of that. And it's not about shipping, but if you want to know what I learned about like the business of indie game development, my talk at Handmade a couple years ago, it's not survivorship bias, unsuccessful software endeavors, is about that. What I learned, but I guess like shipping, that's a slightly different question. Let me see, off the top of my head, I would say, if I had to just like give someone some really quick advice, it would be like, you gotta have the people who are going to eventually, like, if say you're shipping a game, the people who are going to buy your game, you gotta have those people playing it in advance, right? Like, I mean, you have to have someone playing it, but it should, like, ideally, it's like your actual target audience. I mean, if any, someone is better than no one, but like having your buddy who doesn't actually play puzzle games or whatever test your puzzle game is not necessary. Like, it's not bad, but it's not the best test. Like, you want to find the community that actually is interested in your product, and like be talking to them and be interacting with them, and be a part of that community yourself. Because otherwise, you don't know. Like, you're kind of driving blind.
Let's do one more question. As a single dev on a large project, how did you keep yourself on a realistic timeline? Any tips?
I sort of didn't.
Oh boy!
Right, because I mean, I started it in 2018. It was a hobby for a lot of that time, but then I didn't ship it until 2024. So, that's if you're trying to be profitable on indie games, it's a little bit long. I got a lot better at it towards the end when I was taking it more seriously, and I think part of it is. It's easy to be a perfectionist when you're just watching other people and complaining when they don't get things right. But when you're doing it yourself, you have to say, okay, like what do I really care about? Like, what matters, and what matters to the end user? Like, again, like, it comes back to like having the actual target audience use your thing. I know it doesn't sound like shipping advice, because it's like, well, that just sounds like a thing you do when you're developing, but my point is that a lot of times people don't have the target audience use the thing until it's already done. And so, yeah, I mean, I think that it's really eye-opening to get your game play-tested by people who would buy it, and then you can figure out, like, oh, holy crap, like, they really care about X, Y, and Z that I didn't think of, and they don't care at all about all of this other stuff that I'm spending time on. Maybe I should stop spending time on all of that stuff and spend a bunch of time on this stuff instead.
You've done amazing with the talk yesterday, and you've done amazing today demoing Freya with people. So please, round of applause for Mason Remaley.
Thank you.
By the way, if people want to support you, what can they do?
Oh, yeah. Actually, I got the sale sorted out. The Way of Freya is on sale on Steam. It's like 30% off.
Nice.
I think till the end of the day, until tomorrow.
Ooh.
And yeah, so if you want to support me, that's the best way to do it.
Support handmade games.
And if you're not into puzzle games, no problem. If you're interested in like my work in general, you can find me online at gamesbymason.com.
Gamesbymason.com.
Yeah, follow other stuff I'm doing there.
I hope people in the chat, post those links there. That sale, that's awesome. I'm glad you got it done. Final round of applause. Final round of applause. I think that was really good. That was really good.
Oh, thank you again for having me.
Of course. And oh my God, guys! I hope you're not falling asleep. We got one more demo, and then we're closing out the conference. And I'll give you. I saw some commentary about dinner plans or like tomorrow the hangouts. Like what's going on? I will give you all that juicy detail after we play our last demo. It's a quick online demo. Unfortunately, he could not be here either, but amazing person, recurring character as well since the very beginning. How many of you have heard of Whitebox? I wonder from the community. You see that? I hope Andrew Reese says hi in the chat. Over and over, I think on the website I said like the #1 most recurring demo in Handmade Seattle. Like this guy does not give up. It's a good product. I believe it's watch how your code behaves as you write it. So it's interesting, like when you have to debug your software, you know what this looks like. You know about your debugging symbols, you know about your linker, you know how annoying that is. I would love for us to move away from that or to have some supplement to that. And so I bring him every year because I want more people to try it out. and I think it's interesting the way he's been taking this, I believe, in a full-time way, in an indie way as well. So many indies. For an indie conference, obviously, I'm really proud of that. So, final demo for Handmade Seattle 2024. Round of applause for Whitebox Systems.
Hello, everyone. I'm Andrew Reese, and I'm here to show you why you need Whitebox in your debugging toolkit. First, let's install the latest nightly. And done. At its most basic, Whitebox is a standard debugger. You can run exes, place breakpoints, and step through code as you'd expect. You'll notice as I step through that the timeline is filling up at the bottom. This shows all of the changes of state that Whitebox has seen. You no longer have to keep all of the relevant previous values in your head, and if you step past the line you care about, you can just look a sample back. You can see multiple levels of the call stack at once, including function return values and data changing in different stack frames. You can add watch expressions, like in a traditional debugger, but notice how it applies retrospectively to the entire timeline and how it updates immediately as we type. We don't have to step manually to capture data. We can give Whitebox multiple points in the code to sample as we run normally. When I do, notice how much less data there is in the timeline. You might also make out that while addresses are changing, values are remaining the same across runs. And we're not limited to just points. We can give Whitebox ranges of lines to sample. You can, of course, mix and match the different inspection types. Whitebox is designed around practical workflows for solving tricky bugs, by quickly giving you a bird's eye view before you dive into the details on anything suspicious. Okay, well we've covered the basics now. Let's go solve some real bugs. This is a C++ plugin for DAWs that I walked through in repo with Sander from SparkBurst. There are two instances of the plugin DLL which share some memory. The component we're looking at records the audio waveform, deduplicating chunks it's seen before. We'll play the audio and, oh, we've got a read exception. This happens when deleting from the plugin chunks array. We'll run this again and sample writes to both instances of this data structure. A convenience Whitebox gives you that other tools seem to miss is arbitrary sizes for data inspections. This means we can inspect an entire struct at once. There is a hardware limit of 32 bytes though, so we only cover the length of the second array instance. I'm expecting to see samples where elements were inserted and maybe removed from this array. Because the plugin instances run in their own thread, it's useful to split these out into separate timelines. Because Whitebox shows us where all these writes took place, it jumps out as odd that we're writing data in a print chunks function. If we jump to this location, we can see the error in the code. Instead of taking a reference to the current item in the array, we're overwriting the data for a previous reference. This means pointers that should be confined to a single instance of the plugin are actually shared, which causes mischief after realloc. Inspecting in the same way after fixing the bug shows what we expected. Let's watch live as items get appended into the array once per second. One down, let's solve another. Here we're investigating a known bug, where deduplication fails if we offset the cursor from an initial run. We know where in the code this is supposed to take place, so we'll chuck a sample there and see what's going on. Somewhat pleasingly, we automatically visualize a normalized version of the audio waveform within Whitebox. We don't need to have had perfect foresight about what to inspect, and we can add other things after the fact. From a rough glance, the two copies of the waveform look like they should be a match. We can highlight the locations where they differ, or filter the timeline to only show those points. Subtracting one waveform from another leaves us with a very small residue. The minimum and maximum expression values, which are shown in the tooltip, are tiny. This gives us a clue as to what's going on. It appears that the audio samples are calculated slightly differently at different offsets, leading to a floating point error. Our initial suspicion was that we were reading one waveform offset relative to the other. I'd just like to show you what that looks like, so I'll simulate it here by modifying the array index. Compare how easy it is to see in Whitebox's timeline view to how difficult it would be seeing only a single instance in time in a typical debugger. As it turns out, when you're mutating state, time is an integral component. Whitebox has many more tools to give you fast and frictionless visibility into how your code runs. These include inline visualization of vectors and images, file watcher-triggered actions, timeline-aware inspection conditions, data breakpoints scoped to given code ranges, and that's not to mention the entire JIT compiling workflow. Thank you for watching. Now that you're convinced that you need Whitebox in your debugging toolkit, request a demo or buy it now from whitebox.systems.
Bravo! That was really cool. And even after, as we close out the conference, I do still hope that you guys talk to all presenters in the chat server, send them your, your support, your love, ask questions, ask Andrew questions. I know I am running out of time. I'm sorry, Andrew. It's been quite the conference. I've had a lot of fun in this conference, I have to say. I'm starting my closing speech here, okay? I'm starting my closing speech here, but you guys can use the chat server, no problem. And yeah, I just want to say thank you, because some of you could make it, some of you couldn't. Some presenters could make it, some couldn't. But even so, I think we delivered an interesting conference. I think we delivered an interesting number of presentations, talks, demos, podcasts. It went so smoothly. So I want to start first, as I close out the conference, really from the bottom of my heart, the Seattle Center staff and also my own staff. It's not, I know I look like the only person like in charge like that, and maybe I am the face of it, but without the people kind of like in the back over there in the sound room, I don't know how many of you have seen that sound room like lurking over there. As you walk up and leave, look at the sound room. See Phil, see Devine, like the people in my about page in the conference website, like see their faces, talk to them, thank them. They like to be lurkers too, but they deserve a round of applause right now for helping me put together this conference. Truly, truly, truly. And the Seattle Center staff as well, obviously, and the ushers and everything, the security guards that you don't even see. Like, there's a lot going on behind the scenes for this to go as smoothly as it did, despite all the conditions of this year. So thank you for those who braved the storm and actually got lucky enough to make it here. Like, that's awesome. I hope you take advantage of it. And what else can I say? I think that starting next year, I really want to build out more than just conferences. We've already started some meetups, right? handmadecities.com/meetups. So if anybody here thinks they have the social shops to run a meetup in their area, come talk to me, okay? Remember, tomorrow, for those who are here in person tomorrow, it's Hangouts. Please go to the conference website, click on day 3. It's official Hangouts. I'll be there personally, kind of like hanging out with you. And you can talk to me and you can be like, Abner, I do want to help with meetups. Or I want to join a meetup and it's not on the list. It's not on the list yet. So I want a wish list. Tell me what to wish list. We have a drop-down wish list, by the way. You can check that out and pick the city that you might be interested in. Because once we have enough people subscribing to that city, we'll try and spin up a meetup for that city. So that's a big goal for next year. And I think some of the meetup hosts from this year some of them are here. Is the DC meetup host here? Can you raise your hand? You know what? Is it okay if you come down here? Just have people see your face? Because some other people here are from DC, right? Is the meetup host from Detroit here? I wonder. Can you come down too so people see your face and they know how to talk to you? Okay. Is the meetup? They did not know this was happening. Is the meetup host from? I think both of you exactly. New York City. Hey, come down here, Mark. Awesome. I just want to show faces, okay? And I'll mention where they're from again, so you can talk to them as well. something better than subscribing on some website is talking to the actual host, right? So you guys kind of like have that chance, okay? Are you guys here tomorrow too, like hanging out as well? Yes, awesome. Okay, Hans, come down here. We have French meetups too. I love it. Martin, this is cool. Am I missing anybody? Any meetup host that I don't know that is here? Raise your hand. Am I missing anybody? Am I missing anybody? Okay, cool. I mean, technically, Alan Webster. Are you here, Alan? Or did you leave? Is Alan Webster, did he go? Okay. He's like, I gave my talk and I'm tired. Very good, very good. Because it starts with Seattle. Stay right here, I'll get to you in a second. It starts with Seattle. Handmade Seattle is where it started. When Handmade Hero started, it was right here in Seattle. So this is kind of where the biggest meetups are happening. So for example, this year at Handmade Boston, which is our conference in the East Coast, it's still smaller compared to Seattle. I was in that conference this year, I was like, wow, this is the size of my monthly meetups in Seattle. Like, they're large, right? And I love it. It's just every month we meet in Seattle, and then Alan Webster is going to be the host for that starting in January, so that I can then expand. Like Phil Holmér, who is my technical producer, who is in the sound room that I hope you thank him for his work. He's now started co-working sessions in Seattle. So like every other week, handmade people go to some coffee shop or they go somewhere, Third Place Books, a library, and like they just work together. You know, whatever you want to work on, they do that. And that lets me start doing weekly hangouts. So at my place, I'm not going to announce what my place is on live, but every Sunday is what I try to do. Just like, come to my place, let's just hang out. I call that the third place just because there's no pressure. It's just every week you can, because we have co-working, and because we have monthly meetups that are more official, we can now have this weekly thing. And just because of that, in the last few hangouts, I've seen a couple of job offers. I've seen people who's like, oh, this guy's a engineering director for my company, and this guy's unemployed. Do you need help? Like a contracting job? Like, it wasn't on purpose. It's just, we're just hanging out and it kind of happened. It's the spontaneous stuff we were talking about yesterday with Andrew Kelly's talk, where programmers kind of like come together through the same values. We're in the same kind of like place, and we just grow and grow and grow. That's going to be important. So yes, we have DC right here with Felix and John, right? So if you are living in DC, or you know anybody who lives in DC, these are the two folks to talk to, okay, tonight and tomorrow, all right, for DC. Then we have Detroit, right? Yep. How's Detroit going? I know that it's still small. We need to get that growing. I hope there's some Detroit people here and tomorrow. Then we have New York City. Do you guys remember programming on my mobile phone? Like I'm seeing, so yep, that's him. This is the guy. Now he's doing New York City meetups. Thank you, dude. And then Martin, we have here for France as well. So are you the only French person today, do you think? And this in person? The only one you know. We'll seek them out, because in previous years we've had several French folks. But same thing, if you know anybody from the France area, subscribe or talk to Martin here. And I hope that tomorrow during the Hangouts, we can talk some more about the meetups, okay? So round of applause for this meetup host for being the pioneers, in the same way that we built for Handmade Cities the Ticketmaster replacement. So you guys come here, I wrote my own Ticketmaster. I started writing my own meetup.com, right? Except it's not a dashboard, it's like a command line program. And I'm forcing them to use this command line program to send out meetup invites. And I just thank you so much, and I apologize. I apologize very much, thank you. It'll get better, right? That's the hope. So that's the plan for next year, is to flesh that out. These things that we don't have to depend, like Andrew Kelly was saying yesterday, on services and companies that can just get acquired like that. And all of a sudden, all the meetup data got vacuumed up, right? The fact that this is just, it's just me. I'm running this. I have my staff, obviously, but it's indie, it's me, and fuck companies. You know? Like, sorry for those who are hiring. I appreciate you, but you know what I mean. You know what I'm talking about, okay? Community-oriented. That's what we want to do. So one more round of applause. You can go back and sit down. I appreciate it. Yeah. Scrambling. Okay, very good. And now let's talk about Hangouts. For the online audience, stick around for a second. I'm going to talk to the people who are here in person. So interesting situations with the power outages, right? So for example, I think tonight I might have to, I have a love of my life. I have a partner whose house has lost power until Saturday. And they have to work too, and like they haven't showered. It's a lot going on, right? And I kind of want to be with them tonight, right? Be with my partner and make sure that they're okay. I hope people forgive me for that, just for tonight, okay? We're still gonna do dinner tonight, but I can't be the one officially kind of like reserving that. But then tomorrow, as promised, on the conference website, day 3, Handmade Seattle, day 3. Everything's booked, everything's good to go. Now, the last location, you know how you saw that tomorrow we have the Mopop Museum at 11 a.m.? That's gonna be fun. Again, I'm booking that, it's on me. Your ticket kind of pays for that, all right? So I hope I see you there. Have some fun at Mopop Museum here in Seattle, 11 a.m. starting. If you come in later, just DM me and I'll like help you out to find, where we are. Then at 2 p.m., this is thanks to Taylor Robbins who helped me out with this, Flat Stick Pub. Fun as fuck. It's amazing. Oh my God, like they invented like their own shuffleboard game or something like that. And they have mini golf, and you can order drinks, and you can order food. You can start partying at 2 p.m. if you want to, because that's when it's booked for 2 p.m., right? Hours and hours and hours. Then I have a private after party at 7 p.m., whose location will be disclosed on the private chat server. 2-ish p.m., somewhere like that. I'll just mention that on the chat. Why am I doing this? Because if I disclose the location, what if it's my place? You don't know that. I don't want to say it in public, but I could say it to ticket holders in the chat. I can just mention that. So keep an eye on the Meetups channel, on the private chat server. Tomorrow, when Flat Stick Pub is happening, around 2 o'clock, 3 o'clock, thereabouts, I'm going to post a little announcement. First come, first served for the final after party, because if there's too many people, then we can't fit everybody, right? But that's when we might get all the Choco Vine. You know how much I kept Choco Vine references to a minimum, people, and Majora's Mask references to a minimum, okay? Can you give me that? Can you give me that? But at tomorrow's after party, all hell breaks loose. And if you haven't tried Choco Vine before, it's beautiful. So for today specifically, since I can't be here, right? Since today specifically, please network again. Please hang out again as I close out the conference, either right here a little bit or the lobby, okay? And as you saw, like I did yesterday, we announced a couple of locations that people are splitting off to. We assigned some leaders to go to those places. So just literally hang around in the lobby, okay, just for a few minutes, and then I will yell and yap about the locations for dinner tonight, okay? And with that said, online audience, thank you. So many ticket sales and donations online from all kinds of people. Freya was a particularly, thank you everybody though. Thank you everybody online and in person for what you're doing here, okay? Thank you so much. Without you, this cannot happen, okay? This is a fancy conference, just like GDC or whatever it might be. It's as fancy as those conferences, and yet there's 0 sponsors. It's just me. It's just me. Thank you. Thank you. Just to finish off, ticket sales cover the operating expenses, covers paying for my lovely staff in the Seattle Center. That's what tickets do. I also have a donate button on the website. Donations is through Donor Box. I'm sure you've heard of that. It's pretty much as popular as Patreon. The Donor Box that's for me. Like if you want to send $5 my way, that's what pays my rent. That's what pays my groceries, my healthcare, the occasional night out. That's it. I'm not ever going to become rich from this. I love it though. I love to be able to have a whole year where I'm just spending time and finding ways to grow this community, to make sure that there is some repeatable exposure to like-minded friends who genuinely give a shit about software and quality and their users, and they want to do better by them. No matter what, we're gonna be in this together, and I'm here for you. Talk to me whenever you need to. Some people mentioned on the chat like that I helped them find jobs and things. I can do that too, okay? So your ticket is not just for the conferences. I try to help the community, and I genuinely want that, okay? My incentive is clear. I may not be a nonprofit, Andrew Kelly. I'm a small business owner, but it's like a very mom and pop shop vibe. Like, you know that I want to sell tickets. And so if I feel like last year, for example, where we sold out the entire venue, and yet the mass layoff apocalypse happened, and we had less people than we had today, or yesterday, right? I had no idea what was going on. That's when meetups started to become a big thing. Because it's like, yo, we need to keep a pulse in the community and make sure they're doing okay. And now with the co-working in Seattle and the hangouts and everything, now I can finally see how you're doing, right? You found a job, great, buy a ticket. You know, you're doing okay now, you landed on your feet, buy a ticket for the conference. Like the incentives are so obvious. This direct customer to like business relationship is something that is sorely missing in software. I hope it doesn't happen just for me as a conference organizer, but like those people like the File Pilot, this Voyager File Pilot software, this indie guy making a file explorer blazing fast from scratch and says, I don't like subscription models. I don't want to get acquired. I want to start my own software shop and just sell the freaking binary to you, right? That can happen again. There's still examples where that can happen again. And now I'm yapping and yapping and yapping. I'm sure you're hungry. I'm sure you want to hang out. So once again, see you next year.